All right. So here I am. How are you guys?
Yo, 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 yo.
Let's go. Let me
Holy
share my
moly,
I
that
can't
screen.
quality.
put my camera on because it's broken.
No problem.
My camera's broken.
Mhm. I think I'm not gonna give a whole welcome to the rational frontier thing here. It's fine. We can just jump
You
right
can
into
do
it.
it, man. If you
Do
want to do
whatever
it,
you
you can do
want.
it.
Do whatever you
But
want,
In-
man.
it's not all
introduce
rational.
introduce us, man. You gotta introduce us, the gang, bro. You know, we
Everybody
kidnapped
already knows.
we kidnapped him.
Yeah.
We told him we're
Yeah.
unless he does this video with us,
Yeah.
we're gonna kill his family.
Brutal.
Unless and until I do this video, it's completely over for me. So today we're gonna do.
Yeah, Eddie's sitting with his mother right now and his grandmother. You know, they're just having a
Better last until midnight.
having some tea.
Can you guys see my screen? And there we go. That
Yeah,
should
I can see it.
I can try to turn my camera, but it's fucked up.
Look at that
It's
beautiful
broken.
infinite regress.
Look, it's frozen right away.
Amazing quality.
Frozen
This
right
is
away.
like 4K.
There's a poop stain on it.
It's frozen.
Dude, that's like
Is it
4K
frozen?
quality.
Is it frozen? Can you see me?
Oh, it's
Yeah,
better.
the G camera is frozen. The other
there you
looks
go.
great.
Yeah, bro.
Camera's
Let's go.
It's totally fucked though. You see my camera.
It's just like
Put that
brown.
on your
What's
lens
the
with your
fucking
sharp.
Yeah, you got,
That
bro,
camera.
it looks like you got some like schmutz on there.
It won't come off, man.
Bro, you gotta get the schmutz off. What are you
I'm
doing?
gonna do. Okay, I'm gonna turn this off.
The stream.
Can you guys see my screen okay? Is it good?
Yeah, it's working perfectly.
My upside down shit, my Down syndrome. Oh, bro. Wait,
You just have a stroke?
no,
How many
I
pages?
was I was gonna
My
say
upside down,
that my
my
upside down,
syndrome.
like my profile pic, bro. It looks like it kind of like if you squint, it looks like my hair is like my beard. You know what I mean?
Yep.
It looks like a beard, right?
Yeah. Okay. So let's do this read along.
Let's do it.
We have roughly 25 pages to go. Let's go.
Yeah, bro. Yeah.
Mhm.
Like I said, bro, I'm gonna try and restrict myself, bro. Like until like you like ask an explicit like question, you know?
He's holding in the beast.
So would people want to like share the reading here? And first of all, is this like copyrighted material or is this like free for all kind of thing?
I have no idea. It's a research. It's
I mean,
a
I
research
guess-
paper, man.
Yeah, I guess if we are like does like fair use apply on research papers? Like,
Yeah.
Yeah, of course. Yeah, of course it
Okay.
does.
It's the
I
public
hope so.
domain.
I hope so. If it's in the public
let the
domain,
lawyers
then we can do
decide
like anything with it.
Do we have a Jew in the gang that might be able to look at that?
The fuck?
Yeah. Yeah.
Statists?
So I was thinking was
when we need them.
I mean, do you have any
either-
thoughts before, like, just from skimming over the paper? Or thoughts you want to say beforehand, like, or just like the general notes you've taken, or like what you think? I don't know what you think is important to say.
So far, I do not think like there's much to say. In all honesty, we're gonna have to go a little deeper because like so far, like what
Mhm.
skimming I did do, it was okay, like I kind of agree with it. Like that's what I came off of it as. We're like, I think like we should
Okay.
go like a proper deep dive into this. Like the skimming just told me that I should read the paper deeply. In all honesty, not too much.
Okay.
Yeah. So,
I think the
what do you
later
guys?
sections are probably going to be more interesting. I mean, I'll have more to say about the later
Yeah.
sections.
Mhm. So, what do you guys want me to read and then we discuss, or would you guys want to like pick a paragraph to read and like
Go ahead,
everybody?
go ahead and read. Go ahead and read, and just like whenever you feel like something is interesting, like you want to discuss it, or anybody feels like something's interesting and like you want to discuss
Yeah.
it or say anything about it, or
Mhm.
just like whatever you're thinking something, say it out loud, right? Like I said,
Okay,
it just
that's
it's
completely
just
fair enough.
open. Yeah.
Yeah. Right. So, I'm gonna read out loud because, like, I guess the audience can get some help in that. Hmm. It is reasonably fair to say that the major achievement of the 19th century was a formal and rigorous understanding of the previously intuitive idea of energy, and that the major achievement of the 20th century has been a similar grasp of the previously intuitive idea of information.
There we go.
Hmm. Fair enough. Uh, I could agree with that so far. Uh, at least as that idea bears on systems of communication.
I think yes, the information
This is
for
just
communications engineering. You know,
yeah.
like
We're talking about physics
everything.
and engineering here, right?
Every, everything that came from sort of Shannon's work in World War II on
Yeah.
deciphering codes. You know what I mean?
Mhm. Yeah.
And forming ciphers, right? Like code breaking and stuff. You know, Shannon was
Yeah.
working in World War II. Like Gibson was also working in World War II. So they started
Mhm.
like the cognitivist school started like at the same time Gibson's like ecological
Yeah.
like psychology studies started, right?
Hmm. So we are uh like this is also like connected to the idea, like connected to the history of computer science and its development. So I'm
Right.
excited
Yes.
about
Yes.
that.
I mean, Shannon information is definitely like was
Yeah.
key to the development of computers and all that
Mhm.
stuff.
Yeah. From what I remember of the Shannon theorem in my like college classes, like it's about like you can compress like I don't exactly remember. I think it was some square root, like something amount of okay, like you can compress data to a limit, and after that limit, like if you compress it further, you're gonna have information loss. But you could like there is a limit to which till the point you can compress without information loss, right? Like, and I feel very stupid that I don't remember a very easy formula, but you could always look those up.
Mhm.
In all honesty, let's look those up.
Right.
Let's look it up. Why not?
I think it's something logarithmic.
Um, I can sort of explain it simpler. Um, Sort of Shannon information is sort of a metric for determining
Yeah, it's logarithmic.
like
Yep.
you have a already fully specified set of like a vocabulary, you know, like symbols, right? And like an alphabet, I mean alphabet, right?
Yeah.
And like so you can sort of it like it's not a metric for specifying y, but it's a metric for distinguishing y from p if
Yeah.
y and p are already specified. You know, so it's just a metric for distinguishing y from p because you already have y and p. Right?
Yeah. Fair enough. Fair enough. Uh, yep. And let's go. All right. Now let's see what do we have for the 21st century. As we peer into the 21st century, we can see science shaping up to address the intuitive idea of knowledge, more precisely of knowing about as a property that some material systems can possess with respect to themselves and to other material systems. Hmm. Okay, so
And
that's
by the way,
interesting. Next aspect, right?
I just want to note really quickly that like a lot of this stuff, this
Mhm.
paper was in 1995, but a
Yeah.
lot of this stuff Turvey continues like a lot of these lines of reasoning like in his book from
Mhm.
2019, lectures on oh, I just linked it to fucking Certino by accident.
Mhm.
Uh, in VC text, I'm gonna
Yeah.
link it. Lectures on perception.
All right. One suspects that a major scientific goal of the next century, perhaps the major goal, will be a formal and rigorous understanding of knowing about. Like, so like, of course, like this does mean like epistemology, but I really like
Mhm.
it's interesting to frame it this way, knowing about. So like knowing about,
Yes.
you
Yes.
know, mhm.
Goal
and
directed.
Yes, and this is like in lecture one of lectures on perception, which is titled "What kind of systems do we study?" He says we study intentional epistemic systems. And epistemic is a qualifier on
yeah,
intentional. Like you can have intentional systems that are not epistemic systems, right? Like they can be following a goal, but not like they don't have to know their goal to follow the goal. You know what I'm saying?
yeah.
To
So like,
progress
from
toward a goal.
let me know if I'm getting this right. Like some material systems can possess about themselves or other material systems. This is like living organisms, right? Like this is living beings. These
Yes.
material systems.
Yes.
Yeah. Fair enough. So far,
Epistemic intentional systems.
yeah. So far, I do agree. In some quarters, there may be an argument made that we have already made good progress on this topic, to the point of understanding that the topic is closely related to the exact idea of computation developed in this century as an integral component of science's formal grasp of knowledge, of information. Knowing about is a species of computation over discrete symbol strings, that is, representations. From other quarters, will come the claim that we are only now beginning to make good progress on this topic, given the newly appreciated formalization of a neural network as a parallel communication of continuously graded signals among very many computationally simple processing elements. Yeah, I think that I hit my crow there, so I'll have to like
An
stop it.
interesting. There's an interesting history of this
Yeah.
in this book. This book has an interesting history of this, so I'll link this book. Like it like goes
Mhm.
over the history of like
Yeah. And
this whole
connecting it
this whole
to,
view.
yeah, the discrete symbol string. Like I'm also getting flashbacks to my theory of computation class. So let's see
Mhm.
how much of that I find here.
Right,
Uh,
and like Turvey basically starts lectures on perception like the exact same way like he's starting this paper. So like there's a lot of similarities like in what
yeah,
like if you the beginning of lectures on perception, you'll see it's like basically the
yeah,
same way he starts it.
yeah. I want to know what this properly means. This line. Knowing about is a species of computation over discrete symbol strings, that is representations.
Mhm.
Like this
Yeah,
is
that's the computationalist representationalist. Yeah,
yeah, yeah. But what does
that's
it
the
mean? Like dumb it down as much as you can, and then we'll
right.
get to it. Mhm.
Well,
Symbol manipulation.
This is the
Basically.
three-term
yeah,
relationship.
rule based symbol manipulation is basically the model, right, of cognition, right? It's just like a universal Turing machine is just like we can deduce like like simulacra of life and like mind and all that from this universal Turing machine or whatever, right? Like it's like we don't have to consider the material details or like the embodied like details of like the organism, right? Because we can consider, just like purely like formally, like cognition is like as operating over formal objects, right? So it's just purely formally, purely like disembodied, you know.
Mhm. Is that the
So we don't
proper
have
way
to
to
even
view?
consider brain dynamics and stuff. No, of course not.
Yeah.
I'm
Okay.
trying to,
Fair
I'm
enough.
just
Fair
trying to
enough. So
explain the view here.
yeah. Yeah. Okay. So like, does the author agree with this, or like is he gonna critique this later on?
No, no,
No, he doesn't
Okay.
agree with it.
well, he doesn't agree with it, but he critiques it more in the lectures on perception, like book. Like he goes into it, like really, like he gives it, like a full like account, like in like he gives the full account, like he gives it, what's it called? Like he gives it as much like credence as possible, like he gives it. Like I
Right
forget the
or
word,
wrong?
I'm looking for the
Steelman.
word. You know? Yeah, Steelman, like he Steelmans it. You know what I mean?
Okay, makes sense. Uh, because
But that's in
no,
lectures on perception.
yeah, okay, makes sense. But you know,
He Steelmans it, and then he defeats it. He critiques it. But in a bunch of other papers, there's more of a focus on like the critique of like the computationalist view, and a bunch of other different papers, but like not so much in this paper. This paper is more of a positive account of our view, like the alternative view, the ecological approach. Right.
fair enough, fair enough. Okay, make good progress on newly appraised. Okay, then there's neural networks. Uh, then from the neural network
Which are
perspective, yeah,
which are anything but neural, by
yeah.
the
From the neural network perspective, knowing about is a species of dynamics, specifically of the time evolution of neural-like states. Okay, like so, I'm pretty sure he's just laying out like you know what arguments different people are making, and this is like standard CS based epistemology stuff, as I like to call it. Like pretty famous these days. Hmm.
yeah.
Yeah. Seen from these two departure points, the challenge of knowing about reduces to that of developing and understanding particular mechanisms with the ability to mimic the cognitive phenomena, memory, language, perception, learning that characterize organisms. Oh wait, like I kind of missed out. Knowing about reduces development. Yeah, for sure. That characterize organisms, especially humans, and of collecting these achievements into a single unified knower. Okay, so uh, you know, the challenge is basically we get the different, elements and aspects of what makes a knower, and then put it together again into the knower. You know,
Yeah, it's called modularization. Modularization. That's like
Mhm.
like if you pick up any cognitive science book right today, they'll talk all about modularization. I don't
That's
want to
the
get too
correct.
deep into that, but there's a lot of stuff on that I can say.
Yep, and yep, I'm also going to write down POC. Uh, that's what it will connect to. Okay. Hmm. For reasons that will become apparent, we suspect that the foregoing attitude cum strategy will prove unsatisfactory. Okay, now the base thing starts and will be or ought
Right.
to be yeah.
He's saying that
Will-
that sort of strategy is going to prove unsatisfactory.
yeah. So throw it away. And will be or ought to be discarded long before the 21st century reaches a close. Based. Contrary to the current hopes and contrary to the current hopes and aspirations, it seems to us most unlikely that knowing about can be equated with and understood by the embodying of cognitive capabilities by an arbitrarily chosen material system using processes whose reality is guarded only by their implementation. Similarly, it seems to us that the goal of a unified computational account, symbolic or sub-symbolic, of cognition is a case of misplaced emphasis. Okay, so what are these 2 points that he is trying to like use as a negative against these two approaches? You know, hmm.
Which 2 points? He's
Like
just
first is Pollack 1993. So what he's talking about, despite the current hopes that we have, uh, like simply, you know, embodying cognitive capabilities by an arbitrarily chosen material system using processes whose reality is the guaranteed only by their implementation. What does this mean? What is he talking about here?
well, he's talking
Structure
about
independent of the
computation.
flow of energy.
Mhm.
Yeah, he's talking about like how computation, like, how computers are built. Like he's talking about like building like a simulacra, right? Like a mimic. Like that's the explanatory target is like a simulacra, a simulation of
Mhm.
these functions like memory or
Yeah.
language or learning.
Hmm. Fair enough. So like that's not going to be uh what do you say? That's
Mm.
an unlikely thing, but I would want to see why is that unlikely. Like
Well, yeah, he doesn't really talk about it here. Like I said, he talks about it in lectures on perception. I think
fair
lecture
enough.
13, he
Fair,
introduces the idea, but then he talks about it more in like the lectures that follow lecture 13.
fair enough. Fair enough. At least if it's somewhere, I'll get to it. Um.
Mhm.
Yep. This is the same thing as well. He's just saying it's misplaced, but he's not talking about why it is.
Mhm.
Let's see where he gets to the positive case. Mhm. To be blunt and to the point, knowing about as a natural phenomena will demand a radical extension of physics and quite possibly an inverting of the classical understanding that the functional order defining living beings, examples, learning, patterns of mating behavior, directed locomotion in cluttered surroundings, is too special an aspect of nature to sustain universal generalizations of the kind that typify physics. When turned on its head, the classical understanding becomes material systems that express knowing about are more general in respect to the principles that underlie them than the material systems that physics currently addresses. Okay, let's see. That this is a
And
principle.
that point, that's a point from Robert Rosen specifically.
Yeah.
Like literally, Robert Rosen wrote a whole book about this point, life itself, and like he talks about it more in a bunch of other papers. I'm actually writing like sort of a review of like you know like Rosen's arguments for this claim and like putting them together because I think it's a really important point, especially for like my interests in getting into biotechnologies, right?
Oh, that's based.
And like,
Uh, but
yeah,
what? Uh, okay, material systems that express knowing about, so that's living beings with some sort of a cognitive faculty, are more general in respect to the principles that underlie them than the material systems that physics currently addresses. What does this mean? Like, what
right.
is physics lacking here?
Living systems are more general, right? They can basically they what is it? What's the word I'm looking for? They can we can learn that's not the word I'm looking for, but we can
Mhm.
learn more general laws from studying living systems, right? Than from studying you know, structureless particles in a vacuum and or like a matter in a box that we wait until it reaches equilibrium, right? These very limiting cases, right? Because, you know, living systems they embody more general laws, right? It's not like it doesn't matter whether or not like you can apply like the laws like of like quantum phenomena, right, to like the molecular phenomena, right, of biology, right? Like you can apply the laws of molecular phenomena, right, to the molecular phenomena like of an organism, right? And
Mhm.
it's not gonna invalidate those laws, right? But
Mm.
it's not gonna you're not gonna be able to infer anything from that to anything about the organism. You know what I mean?
Mm. Fair enough. Like,
Right? We
I
we
don't
need
know how much, I don't know how much I agree with this, but so far so good. Like, from what you're telling me, like,
yeah.
I can
There's a lot
learn.
that goes into this, right?
Yeah.
So,
Like,
there's a lot that goes into this. Basically, living systems, right? They basically provide like a natural classroom for studying things without having to take them apart and destroy them, right? How do we study things without taking them apart? Like if we take apart a cell, we would just destroy it, right? So we can't learn anything about the cell, right? Its organization by taking it apart. You know what I'm saying? So how do we study it, right? That's what living systems they provide like a natural classroom for that, right? So we develop instead of taking some geometry, like some mathematics and physics from studying molecular phenomena, right? We study living systems and try to develop a mathematics and physics appropriate to the phenomena, the living system, right?
Mm-hmm. Fair enough.
And so, yeah. And so
So
we're basically saying like new things about matter in general really can be learned from studying living systems, right? Like as opposed to the view that nothing new can be learned about matter in general by studying living systems.
mhm. I will still have to like think about it. Like, let me give you a counter now. Like, what
Mhm.
for sure, like if you do destroy a cell, you don't know how the cell works when it was not destroyed.
Right.
You might want to destroy a cell to like gain the information of what's inside a cell, more accurately. So like, it might be useful to do that in certain cases. And you know,
Yeah, sure,
like,
but for certain purposes, right? Not for
yeah,
explaining how
the
any of
cell
those
works.
components are yeah, like
Together.
coordinated into a cell.
Yeah, yeah,
Yeah.
for sure, for
You
sure.
get what I'm
For that,
saying?
you would need a method that observes it in real time working, right? Makes
Yeah,
sense.
but what you need is instead of using extrinsic units, right? You let the system define its own units, right? That you use, and there's a lot that goes into this. Like I don't know if you want to get into it right now. Maybe get into it later when we get into the later parts of
Okay.
the. It's going to get into that a little bit.
Hmm. But like,
It's going to
I'm
get
just
into
confused.
like how do we do this?
Yeah, like my confusion is that, uh, like, can we get new physics out of this? I'm pretty sure, like,
Yes, and this is
how
exactly what Rosen talked about, and
can we get new
like
biology
even
out of this?
Schrodinger, Einstein, all of these people are like Einstein has a famous quote like we can learn like just by looking at living things just how primitive physics still is, and like Schrodinger is saying like living systems they call for like in his paper what is life, right? He's saying that it might call for a new physics completely, right? And it's like this is a whole history that this Rosen really goes through in detail in his book, and he like in
Okay.
several of places, you know.
Yeah,
But
I'm,
there's definitely a new
I
physics.
am
Like
like,
there has been physics that has been developed from studying living systems, right?
for sure, for sure.
That could not have been
I
developed
agree.
otherwise.
Yeah, that the latter part is what I am confused about. Could it not have been developed? Like, we could certainly
No.
like understand this. I'm willing to grant that there is some knowledge out there that you're gonna have to study by, like, you can only gain it by studying
Sorry,
it.
you cut out just for a bit there. I didn't
Yeah,
hear what you said.
yeah. I'm willing to grant that there is some knowledge out there that you can only know by studying living organisms in action. Uh, but is
Well, but
new
you can't know. You
physics
can't
part of it?
you yes, the physics appropriate to studying living things.
Oh, fair enough. Fair enough. So I was thinking like, fair enough. Like,
And what that is but that's it extends much farther than that because remember living things are a natural classroom for studying things without taking them apart, right? And like that it opens the range of like meters and like that we can create, right? That we can conceptualize and understand, right?
mhm.
And that opens the range to like exponentially much more observables that we can use and
Oh,
measure
for sure.
through these meters, right? You get what I'm
For
saying?
sure. Yeah, yeah, yeah. Yeah, I do good. I do exactly get what you're saying, and I would agree with that. Certainly.
Right, because like think about like the artificial like instruments, measurement instruments that we have today, right? They're immeasurably just way like more primitive than a living system, right? They can uh do like multivariable measurements like just like effortlessly basically, you know what I mean? That we can only do single variable measurements with our instruments, right? and it's like these measurement systems that are living systems have evolved literally over millions of years or billions of years. You know what I mean? So of course they're far more like advanced, right? You know,
Fair enough. Fair enough. Uh, yeah,
and
but like,
that's a big motive for me in getting into biotechnologies.
mhm. One thing that this does, like, that there's a reason I'm getting stuck here because, uh, like, it's almost proposing that there are two different physics, one for material
No, not at
systems and
all.
one for not at all.
Not at all.
Oh,
Not
okay.
at all.
Like, but you could see how like someone reading it at first glance could get that view. Like, but we'll see if that is the case going further.
No, 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 not at all. That's not what. Well, they're getting this from Rosen, and that's definitely not what Rosen is saying at all.
Oh,
It
fair
sounds
enough.
like he was literally saying that that's not the case, like a few minutes earlier.
Yeah.
Right?
Mhm.
Like saying that
Well,
there
it's
is no
again.
separate physics for organisms and separate physics
Yeah,
for
remember,
particles.
remember the molecular phenomena of an organism, right? It doesn't violate any molecular known laws, right? You get what I'm saying?
Mhm.
So
Yeah,
it's more
but wouldn't you
general.
say
It's more general. It's not a different physics at all. It actually includes the old physics, right? The inadequate physics, right? And it generalizes it, right? It actually gives the old physics its proper place. You get what I'm saying? Its proper context, right? Or its proper limits, right? Because it can't define that on its own, right? From within its own limits, right?
fair enough? But wouldn't you say that, let's say, if these material systems that express knowing about are indeed material, then the most
Hmm.
general case would be like
Hence
the
why they
way.
teach us new things about matter. You know, they're
Yeah.
material, right? I mean,
Mhm.
right? They're organized material systems. So how do we explain how matter organizes in such a form to exhibit
Oh, for
knowing
sure, for
about,
sure.
right?
But
So
but
that's what
isn't
we
the
learn
most
new things about matter.
yes, but isn't the most general account then going to be basically an account of the fundamental particles of matter, and then we build up, like, not that
No,
we
because
rationalistically
there
build
is no fundamental particles of matter. There's nothing is more fundamental than anything else metaphysically. There's no metaphysical fundamentality.
And like you don't
That's
define things by a sum of their parts.
yeah. Fundamentality is epistemological, strictly
Mm.
like higher. It's a hierarchy thing. Like
Let's take, for the sake of argument, it is a hierarchy thing. I would agree with that, but let's take, for the sake of argument, let's say uh, atoms are made up of three types of particles. One is like an electron, the other are like quarks.
maybe a formalism, but we know that we need two mutually exclusive formalisms to describe any quantum phenomenon adequately. You know, we need to measure position and like we need to measure it as a particle and measure it as a wave, mutually exclusive measures, but we need both to describe it, right? So it's the fact here is that what's true about reality, right? That we can have incompatible formalisms and that no one formalism exhausts reality, right?
Also, like
It's that
if you apply
reality
it
is not
to both at
formalizable,
once, you literally can't.
right?
But reality is one whole, right? So like a theory of reality would
Right.
have so
Yeah,
many
but it's not
components.
formalizable. It's not
Sure.
formalizable, right? It's like
And it's not
it's
about
it's one whole, right? And it's what allows for incompatible formalisms to exist, right? Because there's no
I would say
contradictions in reality.
uh, those are just bad theories. Like I would then
No,
posit.
I wouldn't say so at all because they have their limited use.
Yeah, but like
they can
just
describe
because you
things.
can get, and this is what,
You
inductive I would say here. Like, just because you can get some good results doesn't mean your theory is true, right? For example,
But
true.
it's not about getting
What
some,
is
it's about
true?
it can actually like describe everything that it wants to describe and it describes it properly, but it just cannot describe
Yeah,
everything because it's
that's
impossible
what
to
formalism
describe
is
everything.
for.
Mhm.
Yeah, it's like I don't want to get too much into this, right? But we can just
Yeah.
reason like from like Rosen, he reasons from Gödel's incompleteness theorem, right? And thinks about that and about impredicativity, right? That there are impredicativities, right? In reality, that I mean, every single field, right, runs into impredicativities, and this is like you see all these like foundation crises, right, in the history of mathematics and physics, right? This is just each field running into like the non-formalizability of their subject matter, right? And these are the foundation crises that keep happening, because they're trying to formalize everything, and reality is non-formalizable, right? There's an essential semantic component to reality, right? Such that what that means, right, is that like no one way of describing a system fully exhausts that system's identity, right? There can be multiple different ways of describing it, right? Multiple ways, unequivocal ways of interacting with the system, right? Because there's more than one thing in reality, right? There's all these different things that interact. You know what I'm
An
saying?
example,
Right?
an example
But
that
it's like
we often use.
Like,
There's the
Eddie
I'm
wants
pizza.
sure
to say an
that.
example.
Go ahead. Go ahead.
Yeah, well, an example that G often uses like a pizza slicing, right? You can cut the pizza in many different ways, but only one at a time. And no way that you're cutting the pizza is actually like exhausting every way that you can cut a pizza. The way you cut it is different from one another, but they're all about the pizza,
Yeah,
There's
but
not
then
Right,
one
and the only
true
way
way of doing
it's
it.
possible that you can cut it any one way is that there's multiple different ways that are possible, right? And it's just what happens here is that you lose information, right? You lose information in this process, right? Of like getting up reality, right, into like formalizable fragments, right? You lose information that like what formalization does. That's the purpose of it. Like that's the whole point, that once you're in the formalization, you can't even entail the existence of anything outside of it, right? You can't even say that anything outside of it exists, right? So you can't, and nothing inside of it by no purely like internal syntactic means, right? It can't escape, it can't entail anything outside of it, right? So it's just pure syntax. And that's the beauty. That's the beauty of it. That's the whole point of it, right? We have these little syntactic engines that we can play around with, right? But that's
don't
just what
think
formalisms are.
I don't think that's the entire point, because that's the modern physics kind of view here, which is that
No, no.
you know
That's
like
just what formalisms are, right? That's what you need, like a purely formal description that's independent of like any material details, any dynamical details, right? In order for computation to work, right? It
Mhm.
works purely on formal like objects, right? And so it's just like everything purely follows from the rules which are fixed in advance, but are beyond the reach of entailment. Like they're unentailed entailers. They just entail everything. Just everything follows from them, but nothing that follows from them can entail the rules, right? So they're unentailed within the formalism, right?
I
It's
just had
something
a
else.
random idea.
There's
Like you
always
can
unentailed
use,
components.
yeah, you can, for example, you can use Newtonian dynamics to predict, oh, this asteroid will move in this way, but you cannot use Newtonian physics to, for example, explain that, oh, maybe our civilization will just nuke this asteroid because like it's coming towards the
Oh,
Earth
for
or
sure,
some
for sure.
shit.
Yeah,
This
like
can still
Earth
happen.
theory. Yeah, for sure. But
Yeah,
that doesn't then say that Newtonian dynamics then precludes those other fields
well,
of study.
we know for a fact that no natural system naturally follows Newtonian fucking mechanics, bro. We had to create, like what these mechanistic formalisms do, right? Is they tell us what happens when we can arbitrarily limit some variable. We can arbitrarily suppress some variable, right? That's what happened. That's what it tells us what happens, right? So we can create machines this way, right? We can create a whole new class of systems that do satisfy our mechanistic formalisms, right? Because nature doesn't, natural systems don't, right? And
This
so we
is
could
how
create all these
this is how
things,
I
these
would put it.
machines.
Yeah, like this is what I would say about Newtonian mechanics, and tell me if you agree with this or disagree with this, just so that we can like get on a similar vocabulary. Because
Mm.
what in my opinion Newton did is that he integrated, you know, like the behavior of objects he saw around him, and like he integrated those into like certain
I don't
cause
agree
and
with that.
effect.
I definitely don't agree with that. Not at all.
Why?
There's absolutely no reference to causality at all possible in the Newtonian formalism.
Well, the third law of motion, what would that be?
Motion, it's just the Newton's laws are not laws, they're just definitions, right? And he's defining motion statically, like there's literally no change, no difference.
I'm sure, but like when the
It's just
what he
like you realize T is just a label, right? It just labels states. There's no actual temporal extent to any of these states, no temporal duration, like they're durationless, right? It's just
yeah,
it's
but
purely it's just purely by rote iteration of the rules, right? That we can create an infinite time series, like Taylor's theorem. You know what I mean?
Mhm.
And
Hmm.
Rosen explained this. Rosen explains exactly what Newton, what he thinks Newton did. Like exact, like it's very like you'll probably understand it better than me because you understand like the math and stuff probably that Rosen talks about. But
Fair
in
enough.
life itself, I would really recommend read life itself and like his discussion there.
Hmm.
Here, I'll link it for you
There is
so we don't get
plenty
stuck on this.
like there is plenty here that I can agree with, but there's plenty that I am, clearly not agreeing with. And then I'll have to like do thinking about like, am I right or is this
Yeah,
right? But
I'm thinking maybe like we save it for a later day, right?
yeah, we could.
Where we review Rosen, right?
Mhm.
Directly.
Yeah, I could definitely do like a deep dive into that because so far I'm in agreement with Peikoff and Inductica and like David Harriman on like the account
Yeah,
of
I understand.
Newton and Maxwell. So if that
And
is
I
not
disagree with them on a lot of stuff. I definitely disagree with them on a lot of stuff. I mean, Peikoff's definitely not too great on physics. On definitely not on the history of physics or physics.
yeah, but like further from Peikoff, like David Harriman and Inductica, James Elias, like that's where I'm getting
Yeah,
my
those people. Yeah, no, I don't agree that they're uh, definitely not as knowledgeable as Rosen. Definitely not as knowledgeable as the people I've been reading about the history of physics and
oh,
all
but
this stuff here.
knowledge
Wonder
There's
if
a lot of there's a lot of stuff
Einstein.
that I've been reading recently about like Newton's like explicit like quotes where he's saying that he was trying to like bring back like he was trying to save God. Like he was
yeah,
he
for
was he
sure.
was very happy. He was very happy about like people using his theorems and stuff to prove God. Because he did like the mechanical worldview. Like he said, like the mechanical world argues for it argues for a clockmaker. The clock
Hmm.
worldview,
So it
right?
argues for a god, yeah.
Argues for a god. Yeah.
With
So
that, I
I
wonder
mean, I
if
don't know if you put all your cards in that area there.
No, no, no. I'm not saying I agree with that. I'm just saying what he did there, and maybe there is just more to it. Maybe I need to read more.
Yeah, there's definitely a lot more to it. There's a lot more to it. Yeah, 100%. Like that's
Do you
just like
agree
the
with? Mhm.
of the mythicized history. That's just the public school history. Literally, like just what they teach in like elementary school. Like like Newton saw the apples falling. Then he induced gravity. But no,
Well,
I
it
like
wasn't just
like
that. It was
the
it
gravity
was
point. The gravity point was actually way entirely separate from his like whole formalism and actually caused a lot of problems for him in his formalism.
Mhm. For
He
sure.
kind of
But
just
wonder if
gave an
like
ad hoc account. He gave an ad hoc account of it, really, kind of like like epicycles, in the geocentric theory.
Mhm. Well, Sharon, I'll look into it. Like, do send me that as well. Like, I can do research. That. Do you agree with Inductica on his critique of like modern
Yeah, in
physics?
VC, I just put it I just put it in VC text.
Yeah.
Rosen's discussion on
Mhm.
that.
Okay.
We can look over that later.
Yeah. Do you agree with Inductica on his critique of like like the need for the concept of the ether.
Definitely not.
Why?
I definitely don't agree with uh his theories or whatever about needing concept of the ether.
Why so?
Wonder if like Swinson
I mean,
on
for
the
quite a few reasons. I've talked about it in the chat before.
Okay.
Like you
We,
can
we,
search in the chat. Yeah,
yeah, but I certainly
but
am coming
it's
from that school of thought.
I
Like
think it's I think it's more of the I think it's more of the I think it's just more of the same wrong or direction that physics has taken, where it's taken the wrong direction. It's just more of the same thing, right? And it's not asking the right questions. It's not seeing what's actually needed here, right? And what we actually need to understand. And like, yeah, again, I mean, it's just not asking the right questions to begin with, So it's not going to be able to see what's wrong with it's the direction it's taking. You know what I mean?
I don't even know what an ether is. I'm gonna be honest.
Yeah.
You don't need a substrate to explain these things.
Right.
No, it's not a
You don't.
substrate. It's we can discuss the ether some other time. But
Well, yeah, I mean, it's totally undefined and undetermined. It does there's no really like it's just like, oh, there's an ether, so let's theorize about what it might be.
no, like there's a proper argument there. If you want to do it right now, we could do it right now.
I don't
Which
agree with
is
the argument because I don't agree with how he characterizes I mean, what light is in general. He doesn't really. I don't think he understands what he's talking about there. But I've talked about it before, right? And like what my sort of alternative sort of account of like some of the things that he raises, like people have asked me this question before, right?
Mhm.
But I don't think it like I honestly really don't think it's even worth like it's even worth it, like worth addressing so seriously. It's not something I take serious, you know. And
Sure,
that's like, maybe that gives you an idea of like of where I'm at with that, because I really don't even take it seriously.
mm-hmm. Sure, but I do think like that's a proper debate to be had, and
Mhm.
I do
Sure.
think that
Yeah, I'm down. I'm definitely down to have it. But like, I'm telling you right now, bro. I mean, you're going to be like, I don't know, humbled by it probably.
yeah, that's a good thing if I
I mean,
am because like
I was there too. You saw. I probably introduced you to that, didn't I? I introduced you to Inductica and like the
no,
ether stuff. I was posting those videos. So I was with you on that, right? I had that view. And then I like when I actually learned about the fucking anything that what was actually being talked about, right? Then I understood how it was just nonsense.
Mm, okay,
So
send me the
I'm telling you, like I was there with you, and then I learned literally just like anything about what was actually being talked about, like light and like unending light, right? And how light is structured and all that stuff is like it just completely just oh yeah, that stuff is nonsense. It doesn't make any sense. It's just total goobity gobbledygook, just totally made up to waste time.
Yeah, I don't think so. I do not agree with you there. We can have
I
that
mean,
discussion.
I didn't think so either, right? Because I didn't know anything. I didn't know
Sure,
anything about anything that was being talked about, but then I did learn about it. So
sure, we can have that discussion, and you can send me the material. I'll look it up. But that's an important
yeah,
discussion.
but I
I'm
yeah,
not.
I mean it's an important discussion, but it's an important point. I mean, you should probably
Right.
value that a little bit more. Like, you know what I'm saying? Like that I was there with you, but then I just learned. Like I just learned, and then I knew it was nonsense.
Sure, sure,
So maybe it's something you
sure.
should be questioning more yourself, right?
Yeah, but I'll question it when I see like why you
Right.
moved away. So like, do send me
Yeah,
that.
yeah, yeah. You definitely, yeah. You got to learn. You got to learn why. You
Mm-hmm.
gotta.
Mm-hmm.
And I'm saying when you learn why, I think you'll be humbled and you'll be like, oh yeah.
Sure, sure. We'll see. But what is the like? Also, does this not smell of a little bit of primacy of consciousness here? Because like
No,
materials. that know about are more general in respect to principles that underlie them than the material.
Then the systems that currently occupy most of physics, like most of physicists, they're currently occupied by very simple systems, very like limiting cases, and like living systems are embodiments of much more general laws, pertaining to like irreversibility and non-equilibrium, far from equilibrium thermodynamics, right, and self-organization,
But sure, like
physics
that
for complex systems, right?
is. But how does that make it more general? You can get more
I
things out
just
of it.
told you.
No, that doesn't make it more general. I don't think so. Because like
Yeah,
more
it's the amount of things that it can accommodate, right? That makes it more general. It can explain more things, including where the old theory, right, the old physics, right, where all these old theories, where their proper context is, what their proper context is. So yes, it's more general. It's more inclusive.
I'll do my thinking about that as well. But sure, like a lot to agree and a lot to disagree and a lot to think about there.
Because it doesn't just replace the old view. You get what I'm saying?
I
It
know, like
actually
you're
explains
saying
it,
it
it
comes to
explains what the old
yeah.
view explained, right? And how the old
But
view like works, right? And what it works with, right? It explains
this is
it.
what I gotta read, right? To like know more
Yeah.
about this. Okay. All right.
Like Rosen, yeah.
Yeah.
Yeah,
Okay, let's
he talks about it in there, but also in Essays on Life Itself. So I'll link Essays on Life Itself too.
let's continue then. Uh, rather than a reduction of knowing about to the contents of any current physics, hmm, an amplification of physics by the rigorous study of knowing about is envisaged. Again, to be similarly blunt and to the point, it is not the unification of any
Right. Remember, we don't approach living systems with the physics and mathematics derived from studying molecular dynamics, right? We approach living systems and then develop the physics and mathematics appropriate to studying them.
yeah, for sure.
That's
Like
what he's saying there. That's what he's saying there.
sure. But would you say that living systems are indeed emergent from the physics of the molecules?
No,
Well, how are
I
they
don't know
getting
what
there?
that means. What do
Are
you
they
mean? How are they
they're
getting there?
made up of molecules, right?
I wouldn't say made up.
I mean, that's what their constituent particles are molecules.
Molecules can certainly be like differentiated from, you know, like there's like organic molecules, right, that can be
Yeah.
differentiated, right? But
Even
those
in
are
and for, right?
differentiations of a whole organism, right?
Yeah, for sure. But like the whole is the sum of its parts, correct?
Yeah,
Like and such
the whole is no, definitely not. No, yeah, an entity's identity is not parts. An
no,
entity's
I'm not
identity
saying
is
that's
its
the correct
properties,
entity.
right?
Yeah,
Yeah,
for
that's like
sure.
more
But
of a
where
No, that's what you're saying. Yeah,
fundamentals view.
yeah.
the
When you say a
problem?
whole is the sum of its parts, you're saying that you're locating causal primacy in the parts, right?
Yeah.
Yeah,
And
but that's
that leads to
where
an infinite regress. But that leads to an infinite regress. No, it's not. It's not true. That's an erroneous view.
no, but it doesn't necessarily has to be an infinite regress because you could simply have
But it is.
yeah, sure. Like let me
You
speak,
can let
which
him
would be
speak.
You'd have to arbitrarily stop at some point.
Yeah,
the
with
thing
some
is
unentailed entailer, some unmoved mover, and that's a violation of the second law of thermodynamics. So, I mean,
not an
once you have a
unmoved
violation of the
mover,
second law of
but
thermodynamics, you just don't have a universe anymore.
It might help
how is it
to use
how
Yeah,
is it
the
a
yes,
second law
yes, an
violation?
unmoved mover.
How is it
That's the only
violation?
way you can stop
How
this
do we
infinite
no,
regress is by fiat.
once again, like we're not trying to reduce there to be like like this is where the mover is. We're trying to observe, and if there is found to be some
Yeah,
fundamentality to the
and
particle,
you won't find the movement in the order, right? The order, the higher order movement, right? You won't find any like this is the mistake, right? It's like we say, we have this movement, this coordination, this thing that like exists right at this scale, right? And then like let's see if we can find some mark of that, like just like a property in some isolated component, right? If we can't find it
No, I'm not
there,
saying that.
then the phenomena is just like unreal, right? It's just an appearance, you know what I mean? It's just an
No, no.
illusion,
Let's
right?
take
Buying this
let,
fundamental
let's take
reality,
a
it's just an emergent thing. Yeah.
let, let's take an example. Table
Same thing.
salt. That's NaCl. That's sodium chloride, right? Now both sodium and chlorine have a very different nature than sodium chloride.
Salts.
But we can, yeah. Can you hear me?
Okay. How do you get the how do you get the edibility of salt from
Yeah,
you
yeah,
know
that's
the
where we're
this
getting. Yeah, that's where we're getting from. But
right?
the way,
No, you're
sodium.
not. Okay, so like we can give the most extensive like chemical description we want, right? Of like things like enzymes, right? But enzymes they have much more entailments, right? Than can be captured in this formalism here, right? So it just
No, no,
you
it's not
can't
a
capture
formalism.
sort of.
Like
It is a
sodium and
formalism, yes.
chlorine do
Okay,
exist,
so
and when
write
they
it down,
combine,
write it
do
down, write it down, write down the formula, right? Write it down, and then
those
put some table
formulas
salt next to it, right?
represent something.
Put some table
There's
salt. Put some table. Yeah, it represents something, right? It's a formalism. I get it, right? But how? Right. So,
I'm not talking
let's
about
say
the
I.
formulas. I'm talking about the thing out
Yes.
there. I'm talking about the
Okay.
table
Yeah.
salt.
Sure. Yeah. Sure. But you were just referencing formalism. So write it down. You write it down. Let's look at this formalism. So, can you learn anything about table salt by just looking at these like symbols?
I didn't say that I could.
No, right. So you learned about table salt, and then you attributed, what you knew about table salt to the symbols. You get what I'm saying?
Yeah.
Like you had to have
We know,
independent access to knowledge about the table salts.
we know
Right?
that when sodium and chlorine combine, we can see that that's table salt. We can
Mhm.
measure its, like molecular weight. It's equal
Okay.
to the combination of sodium and chlorine. Like there are, and we can also, get it to.
Yeah, under the formalism. Under the
No,
formalism, right? Yeah.
like we can weigh
Yes,
this
under
stuff.
the formalism. What do you mean? Yes, but under the formalism, that's what table salt
The
is.
formalism represents things out there in reality, you see. Right? Like that, I'm talking
But
about
well,
the.
if
Does it?
you argue
Okay, but can it
that
exhaust
without
their identity?
explaining,
Does it exhaust their identity? Can you exhaust their identity?
obviously,
Does this equation exhaust its identity?
I don't care about the equation. I'm talking about the reality of things out here. Like the
that's
equation
what
Then
makes
why are you talking
the
about the
thing
equation?
is. The thing is that let's say you're saying like you can we can explain like organisms through like analyzing the molecules, but then why are we explaining through molecules? Why are we not explaining through individual atoms?
Yeah,
Why are we
the
not
equation,
explaining through
the formalism here.
atoms?
Maybe to make
Yeah,
it like
It's,
very
it's just a way
explicit.
of it's just a way that we can
Many people talking
understand
at the same time.
table salt. What is it? Literally just tells you what you can understand table salt by decomposing it into its components. That's literally all the formalism tells you, right? And then he's trying to say that's the ultimate reality of what table salt is, right?
no, that's not what I'm saying. I'm
Okay,
saying like
does that
it
does
does
that
tell
does
you,
that does
right?
that process lose information about table salt? Yes or no?
For sure.
So yeah. So I don't know where you're going with this. You're trying to say like
No, but
that's the
what
reasoning
I'm
I'm getting here. That's kind of
let me go
dissipating
there.
here.
Let me go there. Let me go there, and you'll know where I'm going with this. There is that when, let's say, neither sodium and nor chlorine, none of them have, let's say, edible properties. But when they do combine, they do
Mhm.
have edible properties, right? Like that's table salt. And we
Okay,
can actually
it doesn't explain
explain
that.
this. I'm getting there. Let me. We can explain why this happens due to their, like chemical
Yeah,
structure
you
in a
you know
certain way,
why
which is.
it's wrong. You just said that we lose information in this process of decomposition, right? So analysis and synthesis are not equal here, right? So it's not
We're
the
not
case.
doing it
It's
just
not the case
once,
that
though.
you can. But what
We're
it's
not
not
doing
the
it just
case, right?
once. We have
Because of the
many
fact that we
different.
lose information in analysis, we lose information in the analysis, in the decomposition, right? That you're talking about, we lose information. We do not, what that means, right, is that it is not the case, right, that we synthesize the edible salt right from its components like that, right? That's where the edibility of it comes from, right? Is its
Where does it
components.
come from?
What do you mean? Where does it go? It's its properties as an entity in relation to other entities.
Does that have a cause at all, or it just is?
That is a cause.
Which is?
That's its identity. That's how it acts as an entity.
Yeah, the
Its
relation
causes.
between me and salt
The
that I
causes.
can eat, it's edible because
Yeah.
of the relation between me and salt.
Yeah,
Yeah.
for sure. Like table salt is edible is certainly its identity, and thus,
Yes,
that is
because
for sure. But like, are you saying that
because it's
we can explain
disposed.
no
It's
properties?
disposed.
Like there is no
Right?
explanation of properties by the
No.
analysis of its
It needs
parts.
to be
Like none of it.
included in the broader
You have
system.
to. You can only understand what the parts are going to help you understand by first having the whole system. Right? You can only decompose a system once you first have the whole system. Right?
I think
Into its
an
parts. You
example,
understand?
another example that is very intuitive to me is like you take the action of painting. Well, you're not going to be able to find
Mm.
painting in the brush or in the painter or in the canvas, right? Painting is
Yeah, for
only the
sure.
whole thing. That's kind of the similar thing with edibility. You're only going to be able to reference the edibility
Is
of salt
painting
as something
some
that you can
some
eat.
is
You're
painting
not going to
some
find it.
non-material thing? Is painting non-existent because it's not decomposable into
Once
any
again,
one
I'm not
component?
saying that decomposing it gives you edibility. I'm saying that you could still explain its edibility by explaining how the sodium and the chlorine
No, you
interact with it.
can't because you
Hold
lose
on.
information.
Hold on.
You would have unentailed. You would have unentailed terms, right? What explanation means is that there is no unentailed term.
Sodium and chlorine by themselves are toxic. You would not be able to get to
Right.
edibility from combining them.
You do. That's when you
Right.
get salt.
Because
No,
you looked
you
at
get
the salt, you
edibility
didn't
because
look
salt.
at the sodium and chlorine separate
What you
from
did
each
is
other.
you
You
looked
look
at
at
the
the
salt.
salt.
No.
Yeah, you looked
But
at the salt and then you attributed right the function into its decomposed parts. But how did you do that? How did you split the function? How did you do this? Right? Like do the decomposition right now. Right? How do you pose
we can
edibility, the
also
function of
do
the salt that you got from the
composition
salt?
of
You got from the salt.
we can also do composition of the
Right?
sodium and chlorine as well. This is a reaction that goes
Bro,
both ways.
but you lose, dude. You lose information in the decomposition,
We
bro.
do
So
lose some
analysis is not
information
equivalent to
depending on.
synthesis. Exactly,
I'm sure we
analysis
do
is not
lose
equivalent to
some,
synthesis.
but you can gain other things.
You need to do something to them, right? You need to add a bunch of stuff. You need to do something. These dynamics are the source, right, of this organization, right? The surrounding dynamics that are added to the situation, right? That's the source of the order here that you see in table salt, right? That gets formed, right? That's the process. The process of it's literally not entailed by those parts, those components, right? All that whole process requires compose it again into table salt.
Yeah, I think I'm not
You
getting
get what I'm
it.
saying?
Like, I
Yeah,
guess
For fuck's
I'll
sake,
need to read
dude.
more on this. I would say we can move on.
Yes, okay. There's a good example in Rosen's works where he talks about the whether like the function of fuck, I forget the function, like a plane, right? It splits the function of like a bird's wing into two separate parts, right? And that's like the mechanical way of doing it. But you can't. How do you do that? Right? How do you split the bird's wing into two separate parts that you can like where at analysis and synthesis are equal function again, right? You just can't do it, right? Because you can't do that for natural systems. But I just I'm saying, look at Rosen's example there. That I think that's a perfect example for like concretizing what I'm saying here.
Give me the example again. Like, let me think about this.
If you search bird or plane, like bird, something like that, or wing, in life itself or essays on life itself, I think it's in both.
Mm-hmm. Okay, I will do that. But sure. Like, where were we?
I mean, I don't know. It kind of seemed like you just were just
Mhm.
like like just bare negation of what I was saying. Not really like any reason for the negation. Just like, oh man, I don't know, it doesn't work. I can't make sense of it. Right?
No, it's not.
Like,
It's not that. It's not that. Like
yeah,
what? Okay. Would you want to move on, or would you want to like have this debate right
yeah,
now?
yeah. No, I want to move on. I'm just like saying, like, I felt like I tried to like explain it, and you're just kind of
There
negating
is
what I was saying.
there is certainly a reason here why I gave the salt analysis. I was trying to give the example of emergent properties, like, but those emergent properties still can be explained by, like, not just by decompose. I'm not saying we just decompose it and that's how we know everything. I'm saying that the properties are still coming from the
The
interactions,
table salt.
between
You're
all.
getting the property from the
Table salt
table
is
salt.
made up of something. Yeah, yeah, that it is. Like A is A, I agree. But like what is A is the question.
Yeah.
You could do
What is
what is
A,
A,
right?
but
Yeah. How did you identify the property, bro? What did you didn't refer to its components. You referred to it
once
in its
again,
in its environment, right? You referred to it in its relation to other things, right? And
sure,
in its own
including its
inclusion,
components.
you just included it. You just included it in its own relations to other things, right?
Okay.
That's how you identified its properties. You looked at the larger system, the more inclusive system that embodies the laws, right? The law sort of, if you want to like if you want more saltiness in your food, put the salt in it, right? That's the law here, right? It invariably
Sure.
links, an action to a property of the environment, right? That I can pick up,
Mhm.
right? I can pick up that this salt will salt in my food, right?
For sure, you could do that, but not all
That's
I am
I do
saying
it,
is that you
right?
do
On a
that.
daily basis. Yes.
I'm sure. I'm sure you
Is
do
that
that.
unreal? Is like painting unreal because you can identify with that with its components?
Once again, you could actually do it. Let's take the painting example. Uh, yeah, like painting is the process of the artist creating something using certain materials, and like the components there is of course the artist and his body and his mind, like the vision inside his head, and the materials used, and when a certain process happens, then
Inside his
that
head?
becomes the painting.
Side is that?
And
Yeah, I
well,
don't
his
agree with
ideas
that
are
description at all.
inside his head, isn't it? Ideas tend to be
No,
inside heads.
It's not in your
no, they don't.
brain.
Where are ideas? I mean,
They're
where's
actions.
yeah, but
Where's
like
running? I point to the runner. That's where running is. That guy over
once
there, he's
again, I'm
running.
talking about not running but feet. Like idea, where are ideas?
Yeah, it's an
And
action.
in the idea maker.
What does the action do?
Ideas aren't entities. They're not stored in some fucking mystical container, bro. Like they're not like
Not mystical. It's right here.
it,
It's material.
it is very mystic. It is very mystic, right? Because
Is memory mystic? Like computers have memory and
well,
nothing mystical.
I don't agree that that's how memory works. I
Computers
think
don't
memory is
remember. Computers are just like
yeah,
writing one or
they don't
zero.
they don't have any
It doesn't have
history.
meaning to
I mean,
Yeah,
I
you
guess
can't
we were
formalize
just talking
natural
about this
history.
earlier today, literally, when we were talking about the wizard conversation about what the brain is and what it does. And what it
Any so-called history that a computer has access to, it's literally has to be given to it like by an outside agent.
Kind of
Yeah,
goes
for
with
sure. But
what
that
you
doesn't
were saying
negate
earlier,
that
right?
it does have indeed memory. Like it can store past
No, it
events.
doesn't.
Well,
That's not what memory is.
memory on a computer is a completely different thing from a memory of like a person or like an animal. Because
Right.
Sure,
it's
correct.
like on a computer it has no meaning to the
I can
computer.
build a computer. Right.
Sure.
Yep. Exactly.
There is
My
also
memories.
conventional ability.
I think memory is a function of the continuity of transformation events in the environment, just moving through the environment. That I can move from one vista to the next vista, one room to another, and there's an invariant relationship across this movement, right? Where I can literally just like I know where I am because I didn't just pop into existence out of nowhere. I know I can point to where my kitchen is from where I'm standing right now, right?
Yeah.
Because I know where it is, right? These invariants are the ecological psychology, like our view is that literally the means of perception action or any form of cognition or whatever, right, is literally the structure of the environment around you. Focus itself, right, is a function of the structure of ambient energy, right? Like unstructured light is unfocusable. That's just a fact of optics.
Can you say that again once?
Say what again?
Like the point about focus.
Yeah, unstructured light is unfocusable.
Yeah, no,
It's like
I understand that, but before that, like how focus is itself a product of the environment
it's
around it.
well, the means of focusing upon
Yeah.
things, right? About of scrutinizing things in more or less finer detail, right? It's
Mhm.
a function of literally the structure, right, of the environment around you, the energy around you, right? This you're in this sea of energy, right? That's just being structured by everything around you, right? And so, like, if there's a lot of experiments we can do to show that, like, if we put like goggles over your eyes and stuff that like diffuse the light, such that you don't have any access to structured light. It's just purely diffused, right? Unstructured, right? There's no differences in different directions, right? And so what people report is that they don't see like black or like the color of like whatever the light is, right? Or yeah, like whatever the light is, the color, they don't see that. They just see nothing. They just stop seeing. And it's like what snow blindness is. That's another example, snow blindness, right? You just don't have anything to attach to, right? In the environment.
Yeah, I can see that. So that's certainly true for like how perception works. Yeah.
Yes, but like, what
Literally
we would say is
everything
that
about you
perception,
is through the lens of perception, basically.
yeah, like perception is like continuous with conceiving. Like perception is just like conceiving is literally just like detecting higher order invariance. Like it's like I like to analogize it to like just climbing up a hill and like getting a more like coarser view of like all the particulars around you. You know what I mean? You can see the larger relations between things, right?
Mhm. Yeah. Yeah, we're making very slow progress. So like because we basically
Yeah.
are like
Yeah, I mean,
Bro.
I'm
debating every
thinking that the
point.
paper
We're
makes.
debating
What
every
matters
line
is
here.
that it's interesting and we're learning.
Well, it's you
Yeah.
guys
Well, I
spend
think
most
that
of the time
I mean,
disagreeing.
but this is all pretty basic. This is
I
all
hope
pretty basic stuff.
sure, sure.
yeah,
Like
but that's kind of what I'm.
it's basic to it's basic for you. You have been doing like
Yeah,
research into this, of course.
No, I mean like everybody here is like very like
yeah, we are,
you
but
have to say
Yeah,
it
we're
so
very
many times.
familiar. Yeah.
Yeah,
it
but like
seems
that
more
just
that
means
like
that it's
it's
basic for you guys because you have been doing
yeah,
research into it.
that's
Like
it.
I'll still have to like go at it
Yeah.
first-handed. Right? Hmm.
No, we're trying to yeah, right?
Yeah.
I mean, but it's harder to explain when you're like just so just like I don't know, negative, about it. Like just
I
like
mean,
not
No, no,
even
no, I'm not
considering
negative.
it for a second. It seems like
See,
I
I
mean,
am.
I think he's trying to consider, but it is hard to like. It's really hard
I'm
to see where the assumptions you've made your entire life that might be wrong when you're like
no, yeah,
no,
yeah. I guess
different
I
I
guess,
say I'm
but
certainly
it's like
open to that as well.
I guess it's like
Uh,
something you need to think about, and you can't think about it in the moment. You know what I mean?
no, no, no. I am actually like what I'm doing by talking to you is thinking about it, right? Like, I see. This is
Yeah.
my view of this. Like, if to like properly understand it, I'm gonna have to view it from every angle. I'm gonna have to think about it. I'm gonna have to see what it does it contradict with something which is in my current knowledge. If yes, which one of these principles is the correct one, and so on and so forth. So like that's the process, right? That's the process that we're
Right.
going through right
Yeah.
now. So fair enough.
100%.
Yeah,
I
I don't
mean,
think we'll be able to
like,
complete this
I mean,
today.
I don't think, I don't think I've ever let you down, man.
Yeah, I mean, I'm having fun. I hope you guys are as well. It's not too boring for you.
No, yeah, I'm fine. I'm just kind of
Yeah.
fucking hot right now because it like Like maybe it seems like I'm getting hot because I am getting hot because I'm out here and it's fucking hot and I'm like sweating my ass off. I'm like,
Probably running around the
I,
house.
you know
I
what I
don't
mean?
worry about like
Oh yeah,
debating.
and I've been doing
Debating can be
laps. I've been.
frustrating. Like I don't take that. You know, I don't mind if
Oh yeah, I
people
gotta
do better
stop
than
because
me.
I don't even realize it and I'm like doing laps. I'm doing laps literally like for the last hour I was doing laps or something.
Mhm.
What
Yeah.
it does
Bro,
seem
where
to
the
me
fuck is
that
Stratino?
Bro,
maybe
he's not
this
coming,
paper is
man.
actually too advanced. Like there's too many assumptions that we have that are incompatible to get. Like I just see no way that we're getting through all of this paper.
I mean, what do you think, Eddie, is the solution here?
Well, I think we have to go more basic than the paper because just the conversation that we had on
No,
impredicativity.
the paper gets into some basic stuff. I think we keep going. The paper is good. It's a good jumping off point.
How about
Like
Key,
that's
you
like
take over?
that's like you're saying.
Like
I
like
think
you
we
can
should
give us
continue
spiraled
in the
in.
paper.
g-
No, you
like
should read it. You should read it. You should read
oh I
it.
will, but
We should continue.
it would take it would take way longer to like read all of this than
I
we
think once
tried
we are
previously.
past the basics, then a lot of it is going to be faster.
Well, I don't know.
Mhm.
You're gonna get
Yes,
more.
yeah,
You're gonna get more out of the first part of this paper than we would because
yeah,
we already read it.
yeah.
So
I like. I'm saying that's why I keep saying let's continue. That's why I keep saying let's continue because I think we're going to find the answers if we keep reading.
Mhm. Yeah, but
And I
it's
gotta get some water.
we have not completed 2 pages and it's 25 pages. So like
Well, we won't
I think we got
finish it.
I think we got past the like rough patch. You know what I mean? I think we got past it, bro. We're gonna move smoothly forward.
yeah. Okay,
You know what I'm
I
saying?
have no problem in continuing to try. Like I don't have a problem there. But I
Let's do it
I
and we'll
would
see.
propose this. Yeah, I would propose this. Like why don't you guys like give me like a overview instead of going through the entire paper and I can go through it myself and come back. And ask questions, so on and so forth.
I mean, I don't think that would be as helpful. Really, I think the read along is the thing we're here for. You know?
Fair enough. Fair enough. All right. So let's continue that. Where were we? Okay. Rather than a reduction of knowing about to the contents of any current physics, an amplification of physics by rigorous study of knowing about is envisaged. Again, to be similarly blunt and to the point, it is not unification of different hypothesized mechanisms of cognitive phenomena that should be sought, but rather the unification of cognition and nature. See Pollack 993. Okay, unification of cognition and nature. What does different that should be sought?
That we are part of the world we're striving to know, right?
Yeah,
And that
fair enough.
you
Like
know,
this is
and science should have an account of the facts that make science possible, like living organisms, such as
This
humans,
is the
right?
point about how this is like not a separate category of science. It's
Right.
just literally expanding upon, like making the
Mhm.
current sciences account for all those ecological factors, right?
Mhm.
Right, because usually the view is just to sort of treat cognition as like any sort of just treat life and mind, right? The facts of life and mind as um, sort of illusory or worse, just like unreal, right? Belying some fundamental reality, some so-called fundamental reality where in looking at this fundamental reality, the facts of life and mind are conspicuously missing. Life and mind cannot exist right in the mechanistic world.
Mhm.
Hence the
Yeah.
dualism that's been in all throughout history. Right?
Mhm. Yeah, I would certainly need to read more about this to even comment on this. So, uh, yeah, in all honesty, like, are you sure this is the first? Like, as Eddie said, like, are you sure this is the first paper for us to read together? Like,
Yeah, bro.
okay.
I
Alright,
mean,
let's get through it.
I guess it's probably either that or introduction to ecological psychology.
Mm-hmm. Yeah.
Yeah, either that. I mean, Introduction to Ecological Psychology is something that's super easy to read. I mean, you can read it on your own, bro. We're here for the you know,
Real stuff.
we're in the trench, we're in the trenches right now, bro. You know, this is
We want the
Yeah,
juice.
but then
this is the
yeah, yeah.
real like hardcore stuff, you know.
Mm-hmm.
We're in the trenches fighting the 1,000-year Kantian Reich.
I think we can like continue and go through the box psychology and the cost between past and present. And maybe that gives us a like kind of a starting point, more like what you were trying to get at, G.
This box.
Well, he's almost there.
Yeah, we're almost.
Okay. So where was I? Where was I? Yeah, this sought after unification is between the laws of and principles formative of nature and the defining qualities of material epistemic systems. Importantly, the assertion above, inverting the ordinary treatment of cognition as special and contemporary physics as general. Hmm,
Bro,
okay.
wow, wow.
Yeah,
Wow. Like I just saw a wall of rain come at me, bro, and then just come in my house, bro. That's crazy.
mhm, yeah.
Yeah.
For once that achieving unification will be pursuant to a conceptual revolution in physics that discloses the basis of knowing about as generic. Hmm. What does that mean? What
Yeah,
do you mean
and
by that?
Turvey has done like he's not sitting from an armchair here. Like he's literally like doing this from like he's an experimentalist. You know what I mean? He's
Yeah.
like just like Gibson, right? He's forming all this stuff from his like ages of work on these on the subject. You know?
Mhm. Hmm. So what? Tell me if I'm wrong because I do not think I am here. What the project here it is being entailed as is that okay in our current
It's
physics.
the
Yeah.
it's trying to find the physics and mathematics that's appropriate to the facts of psychology.
No. It's not sure that is
Huh?
fine enough, but it's I think it's more like he's making a stronger case here than just that. Like he's saying that the you know historically what we have is the uh, you know basis of knowing about is has been a special case and the basis of
Mm-hmm.
material reality as the more general case. What he's saying is that
Mm-hmm.
we're going and when I say general, like I mean it, and I do think he means it this way here. It's the same way general relativity and special relativity is meant, in the sense that the general theory is the broader theory, the special theory is the narrower theory, right? So
Yeah.
I'll have to think about that. Like something about it doesn't sit right with me, but we have already argued about that before. So like, what's the point? I'll just do the
Yeah.
thinking. Yeah.
I think it's more broadly on the impredicative implications of Izot.
Ahead, like what do you mean by that?
Uh,
Uh,
like active matter and such.
I think
Mm.
we're
Okay.
opening a bunch of what's it called?
I think we're
Worms right now.
I think we're getting off.
we don't need to go down any other different route right now. Just like we could
Yeah, let's
continue with
focus
the
on this one
paper.
for
All right. It is precisely for such reasons that knowing about is so challenging now, and will be so challenging for men and women for of the next century. It demands a dramatic and far from obvious overhaul of our fundamental orientations, physically and philosophically, toward living things, their surroundings, and the relations that hold between them. Hmm. Okay. Psychology on the cusp between the past, present, and the next centuries. Around the around the beginning of the 20th century, the structuralist and functionalist controversy was in full swing, each claiming to pave the royal road to a scientific psychology. For the structuralists, the central question was, what is mind? And the preferred experimental method was introspection. The method defined psychology as an anthropocentric science. Only humans have language and the ability thereby to communicate mental content as immediately experienced. Uh, for the structuralists, the view of the mind went hand in hand with an acceptance of the burgeoning field of physiology as a way of modeling the brain, the seat of consciousness, and of explaining the connection of the elements of mind to the bodily sensations residing in the brain. Structuralism boasted that psychology was distinguished as a science by its method for getting how the foundational aspect of mental content and to mental chemistry, how elemental experiences combine. Not surprisingly, structuralists championed mind and body as separate and interactive, and the belief that volitional psychology were what mechanical forces were to physics. Doesn't the mere thought of moving the body motivate its limbs? Functionalism grew out of the positive reaction to pragmatism of evolutionary biology and the negative reaction to the narrow focus of structuralism's questions and methodology. Rather than being a coherent school comprising single minded adherents to strict doctrine, as structuralists were, functionalists were eclectic on method and pragmatic about theory. That's not a good
Yeah,
thing.
this whole theory, but like I mean, this whole history, by the way, is talked about in depth in Lombardo's book that I gave earlier.
Hmm. Yeah. For them, the central question was not what is mind, but what is mind good for? So functionalism, right? Uh,
Yeah,
Yeah.
their quest was not simply to know about mind, but to know how mind works in accomplishing adaptive ends for the whole organism, whatever its species. Hence, the questions posed by the by the functionalist tended to be practical, biological, mol- and molar, while those posed by the structuralist tended to be disinterested, physiological, and molecular. Hmm. For the functionalist, the issue was not so much what experiences constitute the mind, but adaptive purposes justify the existence of mind. The functionalist philosophy might best be described as a kind of double aspect, aspecticism, expectism, a neural a neutral monism or perspectival realism, with the mind being viewed as the brain looked at from the inside and the brain as the mind looked at from the outside. Both consciousness and behavior were processes whose streaming through time defined analysis into the fundamental elements sought by structuralists. This
defied.
structuralism, yeah, there's structuralism and functionalism. There is cognitivism and ecological realism, and then there's the 21st century where more base things are supposed to come. Hmm. Can I select this? No, I can't. Hmm. So the structuralists are like, let's see, like what principal difference lie between the structuralists and the functionalists. The structuralists are trying to find the mind in the brain, right? Like they're trying to like figure out
Mhm.
like what, like trying to reduce it down to like reduce the emergent property down to simply like the physical reality, which I hmm, which I do think is not entirely possible in the sense that you like even if you explain like if there is an alien that comes to Earth tomorrow and you explain it to it, you know what dosages of what chemicals goes on inside the brain when a man experiences a feeling of love, will still not know the feeling of love. So like the consciousness, the psychology element of the it is separate. Though I would classify it as an emergent property, but we had a discussion about that, so no need to revisit that. The functionalists are, in my opinion, this is like the pragmatism of psychology, if I'm correct. Like this is just who cares what the brain is, what the mind is, what does it do, like what is it good for, you know? Um, Let me know if I'm correct
Well,
in
more
this.
like what it is what it's good for.
Yeah,
Yeah,
but
I mean,
would you agree with that?
keep in mind, because I remember this is exactly what we were talking about, G, whenever we were reading this paper, that some people might misinterpret what pragmatism means here.
Yeah, yeah.
Oh yeah.
Tell me about it. Tell me about it.
Well, I mean, like pragmatism as a philosophy is not really like the pragmatists like John Dewey wasn't really like his psychology was mostly in just like the education stuff, you know, the statist education, all that stuff, you know, that Peikoff likes to talk against, right? But like where the really like heart of like, you know, the pragmatist, like their sort of like innovations or like their what is it, their impact on psychology, right, is like, you know, like William James, right, people like William James, and you know, like the behaviorists, right, like Edwin Holt, uh like these people like William James, you know, even Rand and Binswanger, they both praise William James psychology, by the way. Like Rand, like her conceptual like psychology like was influenced by James a lot.
Mhm.
So
Mm.
like
Okay.
that's what we're talking about here. It's not really like the pragmatist philosophy, you know, it's just
Yeah, it's
like
not
their
what
work in
Zulu is
psychology.
talking about, because I know a lot
Yeah.
of people in Zulu Quarter are like, "Oh, pragmatism."
No, but yeah, it's
No,
not,
no, no.
well, it's not ecological psychology, right? James
What
disagreed with
is
them on a lot of
like?
stuff.
What did?
On a lot of stuff.
Yeah.
I mean Gibson disagreed
Yeah.
with them on a lot of stuff.
Yeah,
Just
and we
like
also talked
he
about like like the whole visiting of the pragmatists is not like people try to like uh put like oh man, we were talking about it. It's like people try to put Gibson's novel approach into like other people's like terms. You know what I mean? Because it's like I think if you Google ecological
Yeah, but it's a
psychology,
completely like novel approach they developed, you know, after like years of like
yeah,
trying to make the old like traditional approaches work, you know. And he just saw that they didn't work, you know, so he was like realizing like, oh, I need to develop something new appropriate to these facts to like explain it, you know.
Mm-hmm.
yeah.
Okay. Um. So tell me what functionalism like. What is it trying to do here? Because structuralism, like I think I got structuralism right. If
Well,
no
yeah, I
one's
mean, it's
correcting
not
me.
really so important in the grand scheme of things. It's really not that important. Like in
Yeah,
the point of this paper, I'm saying like you could probably like if you want to learn more about that history, because there's a lot more to it. Like you can look at Lombardo's book because he really goes in great detail, like in all about all the like key figures in the history and everything, and like they're like all that stuff. You know what I mean?
yeah.
Mm-hmm. Okay. Ooh. The 20th century has borne witness to many changes in psychology and the branches of natural science to which it closely allied. Not surprisingly, the opposing perspectives of structuralism and functionalism, prominent at the cusp of the 19th and 20th centuries, have gone. They were displaced early in the present century by new psychologies such as behavioralism and gesta. What is this? Gestaltism. As the 20th
Gestalt,
century, Gestaltism. Okay, like this is French, I would believe.
German.
German. Okay. Okay. As the 20th century unfolded, however, structuralism and functionalism began to reemerge in new and more compelling forms. A kind of structuralism in the currently dominant perspective in psychological research and theory. Cognitivism interprets mental states as the computational states of a Turing machine or the time evolving states of a connectionist neural network machine. lineage is largely structuralism. Inheritance includes a bias.
I posted earlier. One of the links I posted earlier was Brain, that book. There's like a really like I found the history it gave in like one of the first couple chapters. It gave a history of like the beginnings of cognitivism and the beginnings of ecological psychology is like they began like basically side by side in the same areas, like both as a reaction against behaviorism, right? Because it's usually character like ecological psychology is usually characterized mistakenly as a reaction against cognitivism, but they actually both came out like at the same time as reactions against behaviorism and just went their own route, right? Each went their own route, right?
Mm-hmm. Okay.
But there's an interesting history there.
All right. Cognitivism's lineage is largely structuralism. The inheritance includes a bias towards human intellectual prowess and emphasis on physiological underpinnings and Cartesian dualism, strengthened by the appreciation that mentalism and materialism can coexist comfortably within a computational perspective on mind. The coherence of cognitivism or cognitive science, such as it exists, is induced by a rejection of logical and methodological behavioralism and an embracing of mind as the topic of study. Mind is imbued, however, with functionalistic goals as well as traditional structuralist properties, where the structuralists at the cusp of the 19th and 20th century were strict doctrinaires. The structuralists at the cusp of the 20th and 21st century are eclectic, encouraged by the explosion of computer and medical technology to borrow concepts and principles from a multitude of disciplines.
Yeah, there's
Functionalists.
there's a cool paper by this guy. He has a similar name to you. He has a similar name as you. I forget. Lucas Favello. Yeah, Lucas Favello. And like he has this like study where he asked a bunch of cognitivists and neuro scientists, cognitive neuroscientists, like about the concept of representation, right? Like these concepts, right, that are fundamental to the cognitivist approach, and none of them could agree on like what a representation is, how we look at representations in the brain or whatever, how we identify them. They have no solid understanding of what it is. It's just totally, it's eclectic. It's just totally, uh, like a lot of it is really just like oh, we're just using words, right? And then like we're he's gonna figure out. But then the neuroscientist, he doesn't have any observables called sensations, right? He doesn't have any sensations that you can find in the brain, like fucking like blue, you can't find that in the brain. You know what I'm saying? You can't find the environment in the brain, right? He doesn't have any representations of the world in the brain, no 3D models in the brain. He doesn't have any of these concepts, right? That he can find in the brain. All he cares about is the metabolism of neurons, right?
Mhm. Fair enough. Mm. Yeah. I think like outside of the
And the
physicist.
neurons don't care what you're feeling, what you're thinking, they just care about their metabolism and like their environments.
Mhm. Yeah. Okay. We can talk about like. Mm. Fair enough. Fair enough. Okay. Let's continue. The functionalism to be found at the present cusp between centuries is the form of ecological realism. Okay, so ecological realism is a form of functionalism there.
Yeah, I mean, descent
It's
is like
part.
functionalism is like a precursor.
Yeah, it's
Okay.
like part of the same like
So
continuity
structuralism becomes
ideas here.
cognitivism and functionalism becomes ecological realism.
Mhm.
Okay.
Yeah, there's a good paper by Shaw on that. Um, in this new realism, a new look at new realism. This book, Shaw had a good paper on because there's also a movement like I forget when, but like called the New Realists, right? And the critical realists. Yeah, I don't know if you know anything about that, but he's talking about he talks about ecological realism and he talks about a bunch of history stuff pertaining to that, like the development, like ecological realism is like different. You know what I mean from these other views. Yeah, and like from like other functionalists, like other functionalists out like they came from functionalism, like the new realists, right? Like how the ecological realist view is different.
Okay. Send me that as well. Yeah, holy
Yeah,
shit,
I
man.
put
You
that
guys
I
have
put all these in VC text. I've been putting all these in VC text.
yeah. I believe you guys have been like at this, uh like ecological psychology, you know, uh pipeline for a while because you have a lot of material and you're of
Yeah,
course like smart avid. So yeah.
yeah, it's a large
Take
body of work, like
yeah, maybe like
empirically
months.
established stuff.
Yeah. I'd say like there is certainly a lot that I am like from just what I'm getting through here. Like there is certainly value to be had for me here. I don't know how much I'd come to agree or disagree with this, but I'm liking the process of like studying this at least. The like
Like I
like
said, it's definitely interesting. Like, say, just if you're interested in the history of philosophy, right? I mean, that's definitely that's a big interest, right?
I'm
I
also
mean, just
interested in like
for
psychology as well, right? Like
yeah,
so. hmm. All right, let's go. Hmm. The functionalism to be found at the present cusp between centuries is in the form of ecological realism, a perspective that emerged in the latter third of the century, largely inspired by American psychologist James J. Gibson, to greater or lesser degree. This perspective is heir to themes developed under pragmatic functionalism, especially as envisaged by American C.S. Peirce, William James, and John Dewey.
yeah,
Psychology.
American like functionalism, like the American pragmatists, right, are different than what's his name, uh, the pragmatists, right, in like Europe. You know what I mean? I don't know if I'm getting that right.
Mm-hmm. Mm-hmm. Okay. Hmm. Act psychology, a brand of structuralism, and Gestalt psychology, especially is holism. Uh, like the functionalism of old, the concerns of ecological psychology are more molar than molecular, and its goals focus on the individual adaptability in evolutionary functional contexts of all organisms, within and across phyla. The streams of behavior and consciousness that figured prominently in the first round of functionalism are replaced with active organisms qua perceivers engaged in dynamical transactions with their functionally defined environments. The second round of functionalism, ecological psychology, shapes the vision of the future science of mind expressed in the present article. Hmm. All right. So that's the history of psychology, I guess, that we can call it. Right.
Very,
Yeah, it's a
very
brief
summarized.
summary. Yeah.
Yeah. Of course. Uh, all right. Let's go further. How much further would you guys be willing to go today? Because what we've been at it
I'm
for
willing
like
to go as far as you want to go, bro.
Yeah, personally, I'm
okay.
also, I don't have much else to do. So I could sit for like a few
I'm
hours
chilling.
with just one
I'm
small
chilling.
break
I'm
to eat.
chilling.
Yeah. I would actually let me look it up. So it's 1 at night for me right now, like roughly 1:20. And I have somewhere to be at noon tomorrow. So like and so that means I should be up at around 9 to 10 tomorrow. I think I can go for like half an hour more and then I should get like an 8 hours of sleep.
Okay.
Okay. Let's see how much we can cover in half an hour. Hmm.
Yeah, I'm willing. We can continue this like tomorrow too.
Yeah,
If you want.
yeah. I would be willing to do like a long term thing about this. No problem with that. Like it's not like we are leaving. Yeah. Okay. The disposition to know is a natural property of a. Okay, like let me also read the headline: Organism, environment, mutuality, and reciprocity. Hmm. This is an interesting headline. I would like to read this. The
Hmm.
disposition to know is a natural property of certain class of material systems called organisms. Fair enough. Historically, all attempts to understand this property have been shaped by the metaphysical stance of dualism. Fair enough. Psychologists and philosophers have long referred to dualism of mind and body, identifying the need for two distinct languages, mentalese and physicalese, to describe what appear to be two radically contrasting aspects of nature. Uh, hmm. Do you guys like? Are we going to get to some sort of mind-body integration here?
Deeper than that.
Yeah.
Yeah.
I didn't hear you guys.
I said it's a bit deeper than that.
Yeah.
More,
Oh,
more than mind body integration, organism environment integration.
mhm. Yeah, fair enough. Like I would call that. Yeah, fair enough. Fair enough. Yeah. Close relatives of dualism of mind and body are symbol matter dualism, subjective objective dualism, and perception action dualism. To adopt dualism any of the preceding forms is, is to cleave to a particular methodology in which the two things referred to are defined independently of each other, studied independently of each other, and interpreted through independent scientific accounts. Thus, for example, the experimental study of perception and theories of perception have generally proceeded independently of the experimental study of action and theories of action, with the upshot that efforts to understand how perception controls action and action enhances perception are forced into arbitrary and special mediators, schemas, set points, inferential processes. Dualism, therefore, has unwelcome scientific consequences. By sanctifying the logical independence of mind and body, symbol and matter, perception and action, subjective and objective points of view, dualism as a doctrine encourages conceptual divisions in science that give rise to mysteries versus potentially tractable scientific problems that become apparent as soon as questions are raised, how the states or processes in questions are connected.
I'm really restricting myself here, by the way, because I have so much to say about dualism,
Oh,
and
say it,
I
say it,
have
say it, say
so.
it, say it.
No, I don't like
Please.
because we're strapped on time, and it's like so I could talk about it for hours, and I've literally
Okay.
talked about it for hours on Sakura's channel. You know what I mean? Like on several videos, I've
Including
talked
on
about it for like
this
hours
paper,
and hours.
pretty much.
Yeah.
We were sharing
Yeah,
with
it's just like
You know, a lot
there's
of
a lot more, like so much richer stuff that we can talk about just about dualism, you know. But like we could say that for another day, and I think it would be like a fruitful discussion if you're interested in that.
okay. Yeah, I would certainly be, but like we might be strapped for time today, but we will have more days. So if you have something to say, please
Mhm.
say.
No, I mean it's gonna be it's a lot. It's a lot. Like it's
It'll
like
be
a
a
whole
5
different
hour
topic on
tangent.
its own. I mean, yeah, it's a whole different topic on its own. That's what I mean.
Mhm.
And that's probably why they don't go into all the things that I would go into it in this paper, right? I just want to note that there's more to it. Yeah, you know.
Hmm. Okay. The dualisms mentioned are, in our view, subordinate to organism environment dualism. It is the keystone that holds them in place, as depicted in the figure. So, like, this is the figure: subjective, objective, perceptive action, simple matter, mind, body, environment, and organism environment. Where's the keystone?
The keystone is the
The
organism
keystone
environment
is
dualism.
the one in the middle.
Ah, I don't know. Like, I forgot where I was. Oh, yeah,
Oh,
Oh,
it's
yeah.
right there.
It- yeah. It is the keystone that holds them in place, as depicted in the figure. In a theory of knowing about, the two principal players are organism and environment. Organism environment dualism establishes the ground for this theory as the logical independence of the two terms, meaning that a theory of the organism, the knower, can be built independently of a theory of the environment, the known, and vice versa. Hmm? Let's think about this for a minute. Inverted establishes the grounds for this theory as the logical independence of good, the theory of all.
Yeah, I mean, we could think about this for ages. Like I said, this is like one of the big things, the very big things that we could. It's a whole topic on its own, right? Because it's so key. You see, it's the keystone here. You know,
Hmm?
like they treat it
What
like
would
the
you?
organism environment dualism is the fundamental dualism. Like all these other dualisms are subordinate to it. You know.
Hmm? Okay. Hmm. I presume logical independence has sponsored theories of knowing about in which organisms are
I linked
continually.
earlier, by the way. By the way,
Yeah.
if you want to look more into it, like on your own, I linked earlier literally all my notes on it. Yeah, on organism and environment stuff. Or link. Yeah, earlier Sakura linked the PDF on my notes, the organism environment system there. I just collected a lot of like all my notes there about this stuff, and that you'll see like it's literally like 500 pages long. So
Okay. Like I will certainly look into it. Uh, hmm. See, like this is where like I want to like marinate in this. Like I want to
I know,
understand
I
what
know, I
this
know, I
theory.
know. But like I
You
marinated
know.
in it for like a long time, bro. You know, I like I said, bro. Like if you look in that PDF, it's like over 500 pages, dude. Just
Yeah.
like stuff I pulled from like a bunch of other papers and like
Yeah, I mean,
integrated together.
if you really want to marinate in it, it's gonna take a really long time, much longer.
Oh yeah, but you know, a useful resource is like if you go to Sakura's channel, right? We like look at some of the discussions where we're going over my notes. There's like we went over my notes there.
Yeah.
Some So like you can see us talking about it and discussing it further, if you want to marinate even further in it, you know?
Yeah. I'd certainly get to that, but
And I always reference stuff, whatever I'm talking about, like I'm getting it really I'm usually getting it from somewhere. So I reference what I'm talking about, where I'm getting it from. So I'm very like consistent with that. So it's a good source for like
but
resources and
that's a
stuff.
good virtue.
Yeah.
Yeah. That is
Cause
a
like
virtue
you,
because like yeah.
sorry, like you
Go
said,
ahead.
it's like it's a huge body of work, right?
Yeah.
So it's a good resource for stepping in that big, like that ocean, you know what I mean? Like where do you look for this thing? Where do you look for that? When you want to know this thing, right? I reference all that stuff.
Hmm. Yeah. Fair enough. Like then that's very good. I always have appreciated that because even after talking to you, like I can go back and like just check the chats and like go and read something, and that's very
Yeah,
helpful. Thank
and I'm not like unapproachable. You can always ask, and all of us like we're also
Oh yeah,
like
yeah. Like which is something very good about you guys in your community is that you're always there. Like you're always willing to talk about these things. You're always there to
Mhm.
Yeah,
put
of
your
course.
positive case forward. So like even if
Of course, man.
I'm pre- yeah, I'm pretty
We're,
sure
we're
like
happy to talk about the evidence that supports our claims. Like anybody should be happy
Because
to
we
talk
have
about
all of it.
yeah,
whatever evidence that they're saying supports their claims, right? We could talk about it all day.
yeah, yeah, that makes sense. Hmm. Okay, the presumed logical independence has sponsored theories of going about in which organisms are continually in the business of figuring out the world in which they act, much like detectives facing the scene of a crime. They only vague clues to the perpetrator. More profoundly, the overarching dualism of organism and environment sanctifies the interpretation of living things as the products of a process, that is to say, evolution, which lies beyond the laws and principles governing inanimate nature. Hmm, Does it? Does it? Does
Yeah.
it? Like, does
Evolution?
evolution lie? Yeah.
I don't know if I even agree with the animate inanimate sort of distinction, really. But
Uh,
I, But yeah, this is again. He's talking about a different view. You know what I mean?
Mm-hmm.
Sanctifies the interpretation of living things as products of a process, that is to say, evolution, which lies beyond. Yeah. So yeah, this view is that living things are beyond the laws of physics, right? Like, and there's a lot of reasons for that, like that they say that view, right? Like, there's a lot of different reasons for this, and like Rod Swenson, his papers, he really talks about that a lot. But yeah, that's another topic that we would get more into. We could get more into another time, but
Okay.
like we basically, I mean, in our view, well, they're actually gonna get into it right now, actually. So like, let's get into it. They're getting into it now. So let's continue.
Mhm. Okay. Under this concept, no, like I said, yeah, from here,
Yes,
right?
yes, yes.
Yeah, is essentially unpredictable and contingent rather than necessary or entailed. Under the okay, this is the necessary contingent dichotomy.
Mhm.
That's to keep in mind.
Yeah,
Uh, Under its conceptual umbrella, the origin of systems exhibiting knowing about was a frozen accident, lacking lineage with and necessary relation to the generic principles formative of nature. In our view, the most important conceptual step to be taken in the 21st century with respect to the foundations of a scientific attack on knowing about is the rejection of organism environment dualism and the acceptance of organism environment mutuality and reciprocity. Well, I would agree with this. I would agree with this. From what I, you know, have like just from like this is just true, right? Uh, like
yeah.
these are interconnected. Like these are interconnected and mutually. What do you say? Uh,
It's good to explain what mutuality and reciprocity means in a second here.
yeah, I'll have to see what reciprocity. Like so far, like I'm with the sentiment. So like I'm
Mhm.
at this moment I'm agreeing with this statement. So at least I'm agreeing with the most important conceptual step. That's something, you know, right? So in 1913, Lawrence Henderson published a small volume entitled "The Fitness of the Environment," in which he sought to balance Darwin's evolutionary thesis of fitness of living things for the environments with an account of the fitness of our planet for life. For example, he addressed the importance of the heat capacity of liquid water, maintaining a relative constant temperature of the Earth's surface. Makes sense. A feature essential to the survival of organisms which can function only within a restricted temperature range. Anderson's work was given a mixed reception. Some found it stimulating, others thought it was latitudinous. The investigation of the evolution of Earth as a system conducted largely since Henderson's time has affirmed Henderson's hypothesis of the reciprocal fit between living things and their terrestrial surroundings. Hmm. A key observation is the increase over geological time of entropy production in the biosphere with the growth and differentiation of organisms. Figure 11.2a.
On these points
This is
here, I'm gonna give you a few links here from Turvey and Swenson. You see their reference Swenson and Turvey's papers. I'll link that
yeah,
one. Swenson's other. I'll link lecture 20 of Turvey's book, Lectures on Perception. Like he
yeah.
talks all about this in more detail. But this is all very important stuff. Like Swenson, like all of his papers are on this specifically. And Swenson and Turvey, they had a paper a few years before this paper that we're reading on thermodynamic reasons for perception action cycles.
Mhm. Okay, all right. Mhm. Okay, a key observation is the increase of geological time. Okay, this is basically okay how much living things have differentiated and specialized over time, right?
Yeah.
Shows a progressive departure of the Earth as a global single system away from equilibrium as indexed by the increase in the atmospheric oxygen, the transformation of the redox state of the planetary system from reducing when life first appeared, some 3.8 billion years ago, to mildly oxidative 2 billion years ago, and presently highly oxidative state can be taken as a measure of progressive ordering or internal entropy reduction of the planetary system as a whole. Hmm. This progressive increase of order in the small at the scale of the Earth is also a measure of balance of is also a measure by the balance requirements of the second law of thermodynamics of an increase in the rate of entropy production in the large uh, on the scale of the universe.
Again, Swenson goes really deep into these points here that are just like basically briefly mentioned here. Swenson goes into a lot of detail on these points.
Hmm. The atmosphere at the outset of life was mildly reducing, meaning that the earliest life forms were anaerobic, acquiring their energy resources through fermentation. About 3.5 billion years ago, protocyanobacteria, ancestors of blue-green algae, achieved a linkage between the limitless supply of photons from the sun and an essentially limitless supply of electrons in water to bring about the release of oxygen into the atmosphere. As a consequence, life proliferated at an accelerated rate. Atmospheric oxygen accumulated beginning about 2 billion years ago. Once the oxygen sinks, such as our iron formations were filled, and the planetary redox potential shifted from reducing to oxidative. Atmospheric oxygen functioned as an internal resource or potential that operated over evolutionary time to drive the planetary system even further from equilibrium. 11b elaborates the preceding time theme by showing that not only did terrestrial entropy production increase, with an increase in the quantity of order or living matter over geological time, but so did the intensity of entropy production. So where's
Yeah, so it's
the
saying that order is producing faster is producing entropy faster than disorder. More order is producing entropy faster than less order. So the planet itself moves itself farther from equilibrium, produces order in order to produce entropy at a faster rate at the scale of the geocosmic system, Earth system, right? The geocosmic Earth system, the Earth and its surroundings.
Mhm. Okay? Over geological time measured in billion. Fair enough. Fair enough. Specifically, figure 11.2b
There's some important
depicts the
points in the description there, by the way.
Oh, okay. So we should read this. Over geological time, measured in billions of years, atmospheric oxygen accumulated gradually at first, and then at a comparatively rapid pace, with an increase in numbers and variety of life forms, when it reached the current level of 21% uh, of the atmospheric gases. Accumulation began about 2 billion years ago when the Earth's oxygen binding chemicals became saturated and the oxygen released by bacteria during photosynthesis was free to enter the atmosphere. The oxygen built up as a measure of a progressive ordering or internal entropy production of the planetary system as a whole. Looking within the last billion years, figure B, the rate at
Yeah,
which
so
the
basically,
planetary
like what life did, right? They linked the virtually limitless source of energy from like the solar radiation from the sun, right? And the virtually limitless source of like oxygen, like burning oxygen, right? From what is it called?
from the
Like
moon,
in the water, right? In the water, and just linked it together. You know what I mean?
the eukaryotic bacteria, right? Like they
Yeah.
produce the like the prokaryotes, right? The
Yeah.
prokaryotes the protocyanobacteria. So these were
Yes,
prokaryotic.
yes. The
Uh,
essentially limitless supply of
homo-
electrons in the water. That's what it said.
yeah.
You already read that part, yeah.
So, yeah, yeah. So that's why that happened. Like, I understand that. I understand like the entire causal link there. So that makes sense to me. Hmm. Okay. The oxygen buildup is a measure of a progressive ordering or internal. We already read this.
Looking within the last billion years, the rate at which the planet's chemical energy was burned up through the use of oxygen increased with the rate at which the respiration per unit mass of living things increased as the numbers of levels of living things progressively amplified, pictured in B. An important reading of A and B is that living things in the planet constitute a unitary system abiding by a principle of maximizing the rate of entropy production. And that's what Swenson calls the fourth law of thermodynamics, the law of maximum entropy production. And he gives like a whole formulation of that and like why we need a fourth law and all that.
Mm-hmm. Mm.
It's like
Okay.
a useful selection principle. Basically, is how we would describe it, like a physical selection principle.
Mm-hmm. Okay. All right. Hmm. Specific. Now we can start from there. Specifically,
You know, honestly, the next paper we should read is probably
uh,
Swenson's one of Swenson's newer papers. We should probably read Swenson's one of Swenson's newer papers as like the next paper. I think that would be good.
mhm. Okay, we could do that. Anyway, let's
Yeah,
try to
so we're
get
here.
through this page and then call it a day. And like just have some like discussions about this so far. And, like basically that, yeah. All right. So
Mhm.
specifically, figure 11.2b depicts the respiratory intensity per unit mass of living things over the past 600 million years. Aerobic respiration, oxidative uh, phosphorylation, is the process by which living things employ oxygen to release the energy potential from their food. Fair enough. In aerobic respiration, one molecule of oxygen is used to the conversion of atom rate to organic carbon. This is just respiration. The mass-specific respiration intensity is the rate at which the chemical resources are dissipated or burned by oxygen into waste or heat produced per unit mass of the body weight. It is therefore a measure of the specific or per unit mass rate of entropy production. In combination, figure 11.2a and 11.2b reveal the global nature of evolutionary ordering. Higher ordered states require higher rates of dissipation to maintain their spatial and temporal extents. The increase in the atmospheric oxygen over evolutionary time due to the activity of living things provided the potential required for progressively higher ordered states. As can be seen, the sharp increase in the respiration intensity function in 11.2b corresponds to the sharp increase in the buildup of atmospheric oxygen in 11.2a. The higher order states acted as sinks, and that dissipated the oxygen potential. Hmm. All right, that makes sense. Uh, so we got till page 7 today. What do you guys think so
You don't
far?
want to finish the section? You don't want to finish
Oh,
the
I'm tired,
section?
man.
Okay.
I'm tired. I need to get to, in effect, like I need to get to college tomorrow at noon.
Yeah, I feel
Right?
you.
It's close to like
My
2.5
classes don't
minutes.
start for me until August. Like 4 weeks
Oh,
from now, classes start for me.
they already started for me, man. A little early.
Yeah. I'm gonna be
That doesn't
doing
mean
fucking lab shit, chemistry shit, and fucking biotechnology shit. You know,
let's go.
all that shit.
Mhm. Yep.
I got
That is
like I had one semester once of like DNA sequences and shit somehow at uni at like computer science. I took it as like an extra.
I did it as well. Like I also did a DNA sequencing class. It was pretty cool. I'm pretty sure I
Yeah,
still
it's
have.
interesting.
Like, if you guys wanna, like, I don't know if I should show you, but like, there's still probably some material from that class on this laptop. I might show you someday.
Yeah, I just backed up all of the resources I had from uni. I got a fucking folder with all of the courses, with all of the fucking shit. I didn't pay for nothing. I know it is a cheat sheet.
Fair enough. So, anyway, ending remarks. How was it for everybody? I hope it was good.
Yeah, for me, there was no issue.
Honestly, I thought we were gonna get halfway, but it's all right.
What happened?
We didn't get halfway.
halfway, but I mean, it's whatever.
Yeah, I mean, like, sure. I mean,
I think
It's
next
better to
we
make
must.
a little progress than to just skip without understanding the first parts, because then it's just
Yeah.
useless.
I mean, yeah, it's fine.
Mhm.
You know, like obviously, Luca has a lot of questions. So
Okay.
Yeah,
Right.
I mean, it looks like it. I mean, it looks like you're motivated to look more into it to continue. You know.
Yeah. I will get the paper. We will get the paper done at least. And I'm gonna do further research, and we're gonna make that series as well. And on my own as well, I'm going to do
Yeah.
further research because there is certainly something here. I don't know how much. Like, so far, I think they're exaggerating their case, but like I'll need to actually like read all of
You'll be
this to understand.
surprised.
I mean, if you look at example, because like I'm doing it not just for intellectual like just satisfaction, right, for the sake of it. Like I'm doing it because like I think I can make money with this. I think I could make money like innovating in biotech with this shit. You know what I mean?
That's good. That's good.
And that's why even getting that's why I'm even really getting that biotech, right? And that's really my motive here, Like when I'm talking about anything, when I'm talking about any of this shit, like I'm talking about money, bro. You get
Yeah.
it?
G.
That's what it is for me.
Mhm. And
Like
that is the right way
I
to
think
do it.
about that. I think about that money speech from Francisco in Atlas Shrugged.
Yeah. Mhm. And I would say
When
that
he's
is the
talking about
right way
money.
to do
Like,
science, right? Like science is,
yeah.
like in my opinion, like the the value of science is, what you can get out of it, like the technology that you can get out of it, right? So,
Yeah.
and like
Thank goodness G's a
ultimately,
gready capitalist, or else I wouldn't know any of this shit.
No,
yeah,
yeah, and I understand exactly why you would sort of sympathize with Inductica because he's that, and that's exactly why I sympathize with him. But then I just had the fucking the ambition to be like look even further because I went to Antarctica because I was looking even further than like I went to Binswanger in the first place because I was looking even further. So then past Binswanger, I was looking at all these different objectivists, people talking about all these different things, and looking into physics and looking at all this other stuff, right? And then I looked past Inductica, I looked past fucking Gibson, I looked past Turvey, I looked fucking to everything to integrate it all together. You know what I mean?
Mhm.
And then I
Fair
just
enough.
looked what's forward. What do I do? Like what can I do to progress?
Mhm.
Like this whole intellectual like history. You know what I mean? And like
Mhm.
push the boundaries. You know what I mean? Ask
What do
the
you
right
want to talk
questions
to?
that need to be asked.
What do you want to talk to Inductica about this? We could potentially have a debate about it.
I mean, sure. I think we should talk about it ourselves first, so I can understand sort of what I would even say to Inductica. Because I mean, I
Yeah,
really
it's
don't
kind of
take
the
it too
same
I'm not
seriously.
trying to
thing.
Like,
like I'm
People
not trying
want
to like
like
put you
yeah.
on the spot here. I'm just like thinking of like good content ideas for me because I'm a capitalist, right?
no, 100%, 100%. Yeah, I just don't take it so seriously as of now. Like I need to be like immersed back into like it again, because I totally just went. I'm like way past that right now. You know what I'm saying?
That's
It's
fair
like
enough. And like,
I don't take it so seriously because it's something I used to like hold, right, like sort of like interest in, and then I just like I don't anymore because I like evolved past that. You know, I'm looking at bigger things, grander things
Transcended.
now.
mm. And by the way, like full disclosure, I do think you're like from everything I've read, at least about the physics, I think Inductica is correct so far. But of course, like let's see where we go, right?
I mean, see
Because
some
I
of the
would,
stuff that I've said about physics, man. I don't know.
yeah,
I mean, I don't even know
yeah,
what
for sure.
Inductica says about
I would want
physics,
to.
but
There is a random spider on my table.
You can find a lot of like stuff that I've said in the server here, just like randomly searching around, like that I've said about a bunch of stuff, bro. But maybe like around probably search first what I've said about Inductica's view, like the ether stuff.
Yeah, I will look into it. But so far, I'm an etherist because it just makes sense to me. And like, of course, as you said, you used to be there.
makes sense.
So yeah. All
Yeah.
right. Mhm. Okay.
I mean, it sounds
So
plausible the way he explains it, sure, but like it's like, yeah, I know that I didn't know better. Right now, I know better now. You know what I'm
mhm,
saying? And
mhm.
so like it sounded plausible because I didn't know better.
Okay, fair enough. All right. So I'll get to bed. Thank you guys for being here, and we'll continue this soon. And thank
Can't
you, everybody,
believe
for
Stratino
having
wasn't
me here.
here. Stratino
Oh
watches
yeah,
this
so search up
recording.
also Penrose. What I've said about Penrose, like in this server and in Zulu server. You know how to spell Penrose?
Yeah.
Because you'll find a lot of stuff I've said about physics around there. Wherever I talk about Penrose.
Yep. All right. Okay. See you. So I'll just get to sleep now. See you guys later. Bye bye.
Yep.
Damn, bro.
Damn, bro. Bro, what happened to Eddie?
Just one thing, which would be, if Sakura was a recording, please do send me that. I'll put it on
Yeah.
my.
Oh yeah, do you have this
It will
tool
be,
called
won't it be uploaded to YouTube
log?
sooner or later?
Yeah,
Yeah,
it will
because
be.
I'm not gonna be able to send it to you through like normal means. Like it's like 3 hours long, bro.
Like, probably send in a link to the YouTube after it's uploaded soon.
Yeah. Okay, so you upload it to YouTube, and I'll just get it from there.
Yeah,
Just let
YouTube
me
to
know.
MP4 or something.
Yeah,
I mean,
yeah, something
I
like that.
mean, we
We
could get
will.
Zatetic. Zatetic gave me like a tool that I could use to like just
Yeah,
directly
yeah, yeah.
give it to you.
Wait, it
You,
didn't
you don't want to
probably.
wait until we finish the paper and then like upload it all in.
Oh, we could do
So
that
we
as well. We could like stitch it
We could
together
do
in the
that,
code.
though that
yeah.
will also take like 10 years and
No,
stitching
like
MP4.
no. I just got back from doing stuff. I'll be able to join.
What's he doing?
I don't know.
That guy was cleaning a flute.
Uh,
Okay,
to
so
each their own hierarchy of values.
hopefully my mic doesn't sound too crappy though. So this is what we're gonna have to work with.
It low-key does, but it's whatever. At least you're intelligible.
All right, that's good. And we're gonna have Tristan here.
Okay.
So what's up, Luca? How you been, bro?
Pretty good. I watched a little bit, like half of it, half of the podcast on affordances that Binswanger did a while back.
Okay.
So that in the ecopsych stuff, that's what I did. Apart from that, I'm continuing my reading of OPAR and editing some more podcasts that I'm going to put out. Apart from that, some college stuff and pretty much that and
Oh no.
personal stuff like maintenance of human relationships. That just keeps most of my day. And like making money and having a job. Oh,
Yeah,
a
bro.
lot of things.
Making money. So I don't know. Do you want to wait for? I think we should just start. But
Yeah, we can do that.
willing up something like maybe. Yeah, you can share your community.
We could wait for him. I'm gonna mute my mic, but I'm right here. If you guys need me, just call for me and I'll be back. I just
No, we're
want to make a
we can
phone
start it. Oh, okay. You're gonna make a
call.
phone call.
Like
Yeah.
if we are waiting for someone, like that's fine. Like I have time today. Wait.
I mean, we can like whatever you want to do, bro. Whatever you
Okay.
think. Like we can do it in the time you have to like finish the paper. You know what I mean? Like I think maybe we can start before Christina gets here, and then Christina will get there at a good time.
All right. Give me just a bit.
Yeah, but
Shit.
so
Let's meet for like
he's
5 minutes.
barely intelligible to me.
Yeah, me.
Really?
Yeah, well, if you
Guys,
put
you
your
might
You
mic,
might
I
have
think
to
it's okay.
turn me up.
Yeah, you have
Yeah,
to
turn
them
me
up
up.
a lot.
I turned you
I
up,
literally
it's
put
not that.
G on 227% because he's.
Is it good now? Like I'm holding it up to my mouth. Is that better?
Yeah, that's
It's
better.
like very
Yes.
sounds very muted frequency wise, like it's a shitty quality mic.
Yeah, I bet.
So like honestly, you should probably like get some program that will just up the volume of your microphone and just use the
What I
other
can
one.
do, I can just
I was
mess
in
with the
the
audio
server.
settings. I can mess with the audio settings on Discord. Certino said he's gonna join at 2.
Yeah,
By
because
the
like
way.
volume is something that you can fix in software, and the audio quality is something that you need a good mic for. And this mic is shittier, so it's better.
Yeah, to me the noise level wasn't
Okay,
a problem.
how
It's
about
just
that? Is that better?
It's a
That's
bit
Yeah, that's better.
quieter, but it's a higher quality.
Quieter?
It's quiet.
Can you hear me?
You're quiet.
If I up your volume, but I have an extension that lets me up the volume like above the maximum, so it might be hard
Okay.
for other people.
How about that? I'm lowering the input sensitivity.
You're fine. You're fine now. I've got you on max volume and you're fine. Just don't like
Yeah,
speak
on max volume,
extremely
it's
loud,
okay.
otherwise it'll come through extremely loud and then my ears will die. So
Okay, is this better now?
yeah, it's fine.
it's better.
Yeah.
Before you sounded
Volume wise,
muffled,
it's
now it's a
usable,
little
but
bit
quality
less.
wise, it's eh.
Bro, if you ever switch back to another microphone, my fucking ears are gonna get blown out. But
That's true.
I'm just like looking at what voice settings I can do to make it sound better.
I think the bigger problem is when you're far away from it or something like that, it sounds like it's in a can, so like all of your voice becomes equalized and
Yeah,
Okay.
like I said,
Super muddy.
it's super low quality.
Well, it's the best I got, man. I'm living the
Fine,
broke
fine.
color.
It works, okay? It works. I'm
gonna listen to the playback, bro. It's gonna be like I sound like a robot, bro.
You don't- you sound like you're in a can.
robot. That's you sound like a robot inside of a can. That's true.
What
Just
sound like,
imagine that
um,
picture, bro.
Is it because
yo,
I'm in a
it kind of
can?
sounds
Is it
like
because of this stuff?
Gee, you ever hear those like air traffic control recordings? Like the quality is like that.
True. Exactly.
I'm probably using the same microphone they have, bro.
All right. I think we should start. Like if you guys are ready. Like, how long do you think Stantino might take to come?
He said he's gonna come at 2, so that's
That means
like
come
25.
It's like
What's the
20
time right now
minutes.
for you guys?
It's 1:37, so 23 minutes.
Okay, do you want to wait or do you want to start?
We should start.
All right. I'm gonna share my screen. and gonna get started. Can you guys see my screen?
Yeah.
Let me also
I think I have another
do something.
big loud as shit.
Yeah.
We were just below that figure yesterday.
So we were right here somewhere, right?
Yeah, around there.
Do we start from here? Like I think we did the respiration. We
I
did
think we did that paragraph.
Yeah, we did this paragraph.
And then yeah, the next paragraph. But I'm gonna like fill my water bottle and stuff. So I'm like go stuff right now.
Okay, so come back and let me know, and we'll start.
I'm here. I'm listening, bro. I just gotta fill my water and like walk to the backyard and stuff.
Okay.
Walk to the back.
All right, let's get into it.
Who the hell is
Schrodinger's 1945 life feeds on negentropy. So that I would say that's
Negentropy.
negative. Yeah, that's negative entropy, right? Or is it a new term altogether?
Yeah, that's what it is.
Highlights that living things are not equilibrium states, but rather steady states maintained away from equilibrium by a continuous flow of energy and matter. A living thing must continually convert energy into organization, and thus the order defining a living thing adds ceaselessly to the universal entropy. Figure 11.A and 11.2b, which we saw yesterday, underscore that with the production of more order, with more numerous and more richly organized living things, and with the progressive production of higher states of order, the addition to the universal entropy are made at a greater rate. Schrodinger's life feeds on negentropy should be added. Life enhances the rate of entropy production in large. In sum, the significance of the phenomena captured in 11.2a and 11.2b is the following. Living things and their surroundings are not logically independent of each other. Together, they constitute a unitary planetary system abiding by a single and directed evolutionary strategy that opportunistically produces, in progressively more varied and intense ways, the means for the global unit to generate entropy. Swenson and Turvey.
Yeah,
Organism
and if you see in Zulu's general chat, like I posted a bunch of links, like more on this, you know, from Swenson and Survey. There's a lot more that goes into this.
Yeah. Would you want to explain this principle that they have given? Like, what does it mean?
The law of maximum entropy production.
Yeah, go into a proper explanation for someone who's, let's say, uninitiated.
Well, I mean, Swenson like does that in like every one of his papers. So I would recommend reading Swenson's papers, like his newest papers too. They're like his 2025 and 2024 papers are really good. Uh, but he goes through like really like goes through a short history like lesson first. You know, like he builds it up, he motivates it like properly. You know, it's not really something to go all into right here. You know what I mean?
Right?
But yeah, I posted that. You see, I responded to Zulu and Zulu server.
Organism environment dualism. Where did we go? Yeah.
Yeah.
Organism environment dualism, a meta hypothesis, is placed by organism environment mutuality and
Does it
reciprocity.
give the statement? Does it give the statement of the fourth law there, or like I can give the statement of it if it doesn't give the statement?
Sure. Go ahead.
I don't think he does.
Yeah, it says that the system of interest, right, selects the path or assemblage of paths which produces entropy at the fastest rate given the constraint. So it's a physical selection principle. Like the second law, it says nothing about rates or paths. Paths here are just dissipative paths, right? Like dissipative structures. Dissipative structures are dissipative paths. Prigoghine's dissipative structure theory, right? It's like key to non-equilibrium thermodynamics. So, yeah, but Swinson goes into a whole explanation of it, and all of his papers really like he like does the same kind of like explanation in each of his papers, but like with different like details, so it's useful to read multiple of them. Yep.
All right. Organism environment dualism, a metaphysical hypothesis, is replaced by organism environment mutuality and reciprocity, a scientific fact that Henderson most surely would have acknowledged gleefully. Presumably, this fact of global relation of life and earth is foundational to inquiry into the local relations of organisms and the niches that constitute the subject matter of a science of cognition. It suggests, for example, that there must be reciprocal expressions of organisms as knower and environment as known. Mhm. I'll need to, I think I need to read more, like say, explanatory literature to actually like parse out what this means because
Yeah,
there is, yeah, go ahead.
I definitely, and there is more to it. Like especially Turvey's papers, there's a lot more to it. In Turvey's papers, you'll see like he expands on it. So yeah, I agree.
Mm, fair enough. But like in a very simplified sense, what I am getting out of this is that there is a cyclical reciprocal relationship between the environment and its organism and the organism, right? Uh, in like basically, are you familiar with reinforcement learning in robotics?
Yeah.
Like that's what I'm getting here. Like that's what this is talking about. Something along those
Well,
lines.
it's a bit different than that. It's a lot more than that, really, too. But
Yeah.
Turvey talks about that in lectures on perception, the
Mhm.
reinforcement stuff.
Sure enough. But I do think like
I
so
didn't bring
far
my
there's a
lighter.
concept. Yeah, I'll just need to read more on this to understand.
Yeah,
Currently,
like
I don't know if I agree or disagree on this. You know, I can certainly see a certain interpretation
remember
I would agree.
yesterday? Can you hear? Can you hear me, bro?
Yeah,
Remember yesterday I posted the like the PDF for like my notes on like the organism environment system. There's a lot
yeah.
of really good stuff in there about this question that you're having in particular. There's a
Mhm.
lot of really good stuff in there in my notes there.
Okay. Hmm.
So just refer to that. Really. That's like the best source
Okay.
because I put together all the stuff like from all the other sources on that. But I'll be right back. You can continue, but I'll be right back because I need to get something from my room.
So we can just pause for a bit. Like that's fine. Like let's take a 5 minute break till uh we can join back because he's the person who's leading the reading.
Okay, I'm back. Yeah.
Yeah.
I'm back, bros. What's up?
I don't know where Luca is. Luca said we were taking a break.
I was in my room really quick.
Or you just
You're
lagged
just
really
lagging like
loud.
crazy.
Somebody want to ping him?
G the robot.
Somebody want to ping him?
I guess.
Yo.
Yes.
Because my whole lagging for me, my whole thing. Oh no, it's frozen.
Bro, what the hell are you?
Okay, there we go. Okay, my screen isn't frozen. My screen for a bit. Where the fuck is Luca, man? Did you ping him?
You did,
Yeah.
but you're lagging like crazy.
It's barely understandable.
Yeah, it's like
He leaves, Totino arrives. Tino, you there? I'm just singing Levian Rose.
Oh shit, Tino's here.
Womp womp, womp womp, womp womp. Okay, that's not Levian Rose.
Hello, is that better?
We'll see.
I closed everything else. Chromebook.
it's better, yeah.
You're on a Chromebook?
I'm using a Chromebook right now. Yeah.
You can
Bruh.
install Linux on it. That's the solution.
Unfortunate.
Oh, you had a
Yo.
computer again.
Stratino.
Yeah.
How am I sounding right now, bro?
You sound like you're at the beach.
Beach.
Very
You're
cool.
just blowing
I
the
know it's not
microphone.
good. Good enough.
Does it sound good or bad?
Well, it sounds
Sounds good.
passable.
Tolerable.
I don't know where Luca went, but
Gone, reduced to atoms. Oh, it's
let me
back,
see.
it's
Let
back,
me
it's back.
DM him.
Okay, you're still muted.
Is he?
Oh, he's gonna call apparently. I can see him typing on his stream. He'll be right back. Some call.
What
He just DM'd me.
roster of
He said he got it. He said he got a call.
Yes, we can see on his live stream. He's streaming your DMs.
Oh shit.
Imagine having like
Oh, you guys are
Zulu,
flirting.
and Casimir all on the blunt rotation.
What'd you say?
Oh man.
Like I was looking at his DMs, he's got like G, Zulu, and Casimir all on a blunt rotation in his DMs.
That's horrible.
Who, Luca?
I like the DMs you showed.
Luca. Dreadful. Dreadful.
Oh man, I wonder how many people blocked me because my account got hacked and like I DM'd a bunch of people.
Did that even happen? I didn't even get
I
a
did.
DM or anything. Nothing happened on my end.
Boys, I'm back.
You're just not
Yeah,
important
yes.
enough. You're just not
Some
important
people
enough.
did. Oh,
Yo,
What's up?
Luca. Stratino's here.
Yeah. Hey, what's up?
Hey, oh wow, I got a
Finally.
better microphone. Holy shit.
So
I remember back when Lucas used to sound like he's under the water.
that's brutal.
All right.
Isn't that the other day?
It's good.
Okay, now that Stratino's here, let's get into it. We're in the middle of reading the ecological physics paper, but we're gonna get into the juicy stuff, and so you came at the right time.
I'm going to ask a lot of questions. So that's going to be just something you guys have to deal with because I haven't.
Oh yeah, obviously.
We already established that that's not a problem.
I've been trying to restrict myself so much, Stratino, bro.
Yeah, no, G suffers from acute babbling disorder.
So let's go toward a functional semantics. Now, what does a functional semantics here mean, or does that just get explained in the paragraph and we don't need to worry about it?
Yeah, it's explained. It's explained. It's explained.
Okay,
Yeah.
let's just go ahead. Okay. Different organisms can occupy the same space or habitat, but not the same niche. I agree with this. The term habitat refers to where an organism lives. The term niche refers to how it lives. Fair enough. The point is that two or more species can live in the same location, but do so, they must go about their lives in very different ways. Principles of competitive exclusion is often advanced as the reason for defining a niche abstractly, as the thing in which two sympatric species, that's a new term, to me at least. What does that mean?
I don't know exactly what that means.
It gets explained
That
seemingly.
just means
in the
living in the same area.
Yeah. Like,
Doesn't it
My
like
English
clarify what it
comprehend-
means right after? Like if you read the brackets right after this
Oh.
word.
we should just read more and talk less.
Yapping.
Those with the same or
Man,
overlapping.
he's ahead of all of us for writing this paper. We already perceive that we're going to.
Those with the same or overlapping areas of geographical distribution do not live. Okay. Okay, fair enough. One principal goal of evolutionary ecology. I don't know if how much of this is from that class, but I had a evolutionary biology class in college because that was being offered and it was relatively easier.
What year?
I think last year, I think. So
Okay, did they talk about global evolution or thermodynamics?
a little bit, not too much, but like similar.
Yeah,
topics.
A little bit.
it's
No, no,
becoming mainstream.
Yeah, it is. I do.
It's only become mainstream in the past couple of years, by the way, and that's pretty crazy. That came from Swenson first. That came from EcoPsych, and then it went into the evolutionary biologists. They eventually like accepted it.
Yeah,
Damn,
and
yeah.
I do see a lot of this sort of like at least from what I'm reading right now. Like this seems very familiar to me. I've studied this in my classes before, so that's
Yeah, I
good.
bet.
One principal goal of evolutionary ecology is descriptions of the surfaces and substances surrounding an organism that capture uniquely the fit of that organism to its surroundings and clarify the partitioning of any given habitat into distinct niches. In the latter third of the present century, Gibson, then a bunch of papers, coined the term affordance to provide a description of the environment that was directly relevant to the conducting of behavior. This is an important term. This is probably like an important principle.
Yeah, and in another paper, the consequences to ecological psychology, consequence to commitment to realism, right? I sent you that paper as like one of the papers we might read, like
Yeah,
alternative.
that's the one we read next, right?
Um, either we can read that one next, or we can read a Swenson paper next, because it might be easier to
Okay.
digest Swenson's
We can
paper.
figure that out. Yeah, we can figure that out.
But in that paper, in the commitment to realism paper, they say that the concept, like a notion, like something like affordance, like that concept is necessary. They show how it's necessary for a commitment to realism.
Hmm.
So
Makes
it's very, very important.
Yeah. All right. An affordance of layout is an invariant combination of properties of substance and surface taken with reference to an organism specific taken with reference to an organism and specific to an action performable by the organism. An affordance of a change in layout, an event, is an invariant combination of changes in the aforementioned properties, again in reference to an organism and its action potential. Now, this is some like, what does this mean in truck drivers English? Like,
I don't particularly like this like defining of an affordance. I really do like framing affordances as dispositions in the environment. That was something we like G and I had like talked about to no end for a little bit. That affordances are like real dispositions out there in the world, that organisms are developing specific effectivities in order to like essentially
Probably doesn't explain much when you did define activities.
yeah, well, I mean effectivities is like they're developing ways to deal with this
Well,
environment. Like they're
to be clear, effectivities are affordances. They're just affordances selected as means. They're the effect, like you would select some affordance as an affordance goal, right? And it's like it constrains the range of effective means for realizing it, right? So like my arm is a thrower, a grasper, a reacher. You know what I mean?
and essentially there is like structure in the environment that denotes like, you know, if you are in a field and you have a ball, there's structure in the environment that denotes throwability because there are dispositions out there in this field that structure that behavior.
Well, I wouldn't say I would be careful with saying like it's just it denotes. You know what I mean?
Well, I don't know like what word you would use there.
Afford.
Yeah. But then that's just using the term again, which was what I was trying to avoid.
Yeah, but it's very a very precise conception. You know what I mean? It's like exactly like what would be able to structure, you know, light, like ambient energy, such that it's specific to, you know, the requirements of activity, right?
I still don't get it, but like, fair enough.
Well, there's a lot that goes into that. I'm not saying it like I'm keeping it very surface level, right? It might sound vague to like one who doesn't know the literature, right? But like it's a technical term, right? That's what that's something that
it's sort of
clear. Like
affordance is like
give me an example of
it's
an
a
affordance
technical
so that I
term.
can conceptualize it.
Like the pass through ability of a gap is a good one.
like
Sitting,
you can the fact that you can sit down on the chair and sit like a different animal would be able to sit down on the chair. So like to you, it's an affordance of the chair to be sit onable. To an animal that cannot sit on the chair, it doesn't have that. It doesn't see that affordance to itself.
I reference pass-through ability because Introduction to EcoPsych has a great range of examples of like research that has been done on perceiving pass-through ability. Yeah, there's a lot of stuff in there. Great examples in Introduction to EcoPsych that are very digestible, and Introduction to EcoPsych in general is very digestible because it's made for undergraduates, right? Like specifically. So I'll link that right now, and there's also an audiobook for it.
by one of the authors who was narrating it.
I
Right?
love that.
audiobook? Wait, I want that. Holy shit. Where can I
Yeah.
find it? Can you like send?
So it would be really good, probably as an introduction, right? I mean, it's introduction to
Yeah.
ecosec.
I love
Like,
audiobooks, man. Like I can like listen to them.
You can
whenever
call
I
it-
want.
ITEP.
The
The
in the
great thing
audiobook,
about
maybe?
the great thing about the pass-through ability example is that not every single organism can pass through. Like there are you see the ability to pass through the hole. Some may not be able to even detect that. Some may be too
Okay.
big.
Hear me out. Hear me out. Like let me give an example. Let's say I have not let's say, like I do have a door in my house, and because of my size and structure, the door has the affordance of pass through ability for me. However, if like a 11-foot giant comes along, it's he'll have to bend down, but it's still there. But potentially, like for an elephant, it will not be.
Well, they can detect that they're too big. You know what I mean?
Yeah. So like that's affordance. It's a property of the object that allows me some potentiality of action with it.
It is a property of the object, but it exists in relation to a given organism at the same time, or like
Yes,
organism
yes,
with
exactly.
specific specifications.
Yeah, that makes sense to me. That does make sense to me. Oh, fair enough.
Right. Think about a brink and a surface. Coming right about a brink and it might. Right. Think of can you guys
Extremely cutting out.
think of
right
think
now.
in
Yeah,
like
cutting out.
you sports right? They're pushing and
Oh my
different
goodness.
speeds. Maybe
Gee, we cannot hear
Shit.
you cutting out too much.
really.
Now
Okay,
you're
not anymore,
good.
I think. But when you started talking a lot, it was like cutting so much.
Yeah.
I'm saying, is it good now?
You're like,
Okay.
No.
Still lagging there.
Hello.
It's really fucked. It's over.
Is it good now?
It's so over.
Yeah.
He's
Like-
dead.
I'm starting to like this paper from here on out. Like I think my main disagreements were in physics, but the more we are getting towards like perception science and biology, I'm like in full agreement. So
Also,
I
like
have-
partially related, a really interesting thing that was like one of the, I think, exams. Not sure where it was exactly anymore. But for example, if you close your eyes and you hear like some object, like let's say I have like a clicker or something, that that's I can click with it. If you close your eyes and I click around it, people are usually able to tell if it is. They can perceive if it's reachable for them. Though they cannot like tell the exact distance. If you click it like a bit too far for them to reach, they will usually sense that feel. Even though it's only the sound.
Okay.
you're back in
It's
the
even
It's not
worse.
back.
It's even worse.
Hello. I'm back.
Bro, it's not
We are so not back.
Bro, wait. Just wait.
Okay, it's a little better. It's really going in and out of phase.
Is it good now? No? Okay. Well, I think what is better now, right? I think what happened. I winked at the insect.
Oh, no.
No.
Wait.
It's okay. It's like
Is it good?
you ask, is it good now, and you can hear that question perfectly clear, and then you continue and then like all of it starts like being a fucking robot that's dying.
Okay. What is it good now? Hello.
Right now, it's
good now.
Can I
fine.
talk?
Oh, now it is.
No,
Not
it's not.
anymore.
Okay. Basically, if you hear us laughing,
Okay.
that means you have to go
Whenever
back
you
one
ask the
sentence.
question,
Okay.
whenever you ask the question, is it good now? It's good, but right after that, it's not.
Yeah,
Exactly.
I think it can be like slow outside.
Yeah. Internet is such a pain in the ass.
That's what
man.
I'm gonna do.
Sometimes it's good, sometimes
is.
it's not.
That can be annoying.
Let's go.
I'm gonna go inside and see if it's better if I go inside.
Let's look at this example. For example, one invariant combination of properties. So one question is invariant with respect to what? Because like variance and invariance is in relation to like something, right? Like
Mhm.
this is something I have a question in.
Yeah,
But
yeah, and that's a key point in ecosec. That's actually a key point that Gibson like really emphasizes, like
this
the
word
basic,
invariant
like a
here
lot of
is
things.
literally followed by an example. Like if you continue reading this sentence, it literally lists an example.
okay. One invariant combination of properties affords grasping by a person. Another affords support for climbing by a person. Another affords catching by a person, and so on. Affordances are opportunities for action, and the perception of them is the basis by which an organism can control its behavior in a forward-looking manner, that is, prospectively. To assume this essential role, however, the term affordance cannot refer to states of affairs that depend on perception or conception. For this, their existence must refer to the real opportunities. Okay, this is something I really like. This is very based, very primacy of existence build. Let's go. Uh, from our perspective,
Okay, is it better now?
this relative, yeah, somebody wants to say
Okay,
something.
no, is it better now? My mic.
Your
Yeah,
mic
but
is now
Probably.
shit.
yeah, nobody can hear you now.
Okay, no, is that better?
There we go.
Yeah, it's
That's
better.
better. That's better.
Yeah.
Okay, so I mean, it's kind of funny that you say that, given what Zulu said today in
Yeah.
in Zulu Chord.
What did he say?
He's
Oh my
gaslighting you.
goodness.
What did he say?
What did he say this time?
Did you not
He
see?
said probably like the
No,
opposite.
what he
I
said.
didn't. I didn't see. What did he say?
It's fucking bro.
I know what he
It's so
has.
funny. He must have been like stalking what we were doing. I don't know what he because he's referred like he screenshotted the paper that we're reading, right? And then he fucking just mocked it like superficially.
He's
Mhm.
grasping at straws. It's so bad. I haven't been paying
Did you guys see it? I don't want to go off the page that I'm on right now, like the
Oh,
Discord
I haven't
chat.
seen it, but somebody.
No way, bro. Does he
You're
know?
right.
Does he know? Bro, he says we're primacy of consciousness. Does he know? Does he know? Bro, does he know that he's a Kantian, bro?
Yeah, no, like this is. I'm glad that Luca, like, you're able to notice the difference between affordances as like real opportunities, independent even of like the organism. I wouldn't say it like that specifically, but it's like they are real. Like the organism doesn't need to represent affordances in order for them to be real. Like there is the school of like
Give the
like
squirrel
representation.
example.
Yeah, like with the squirrel example, that a squirrel is not able to detect a real affordance of like maybe chop down the tree ability, but that affordance is there for a human if a human were to come along.
The client, bro. The tree. It affords, right? I mean, it's disposed to entertain, right, certain force relationships with certain organisms like squirrels, right, with certain
Mhm.
capabilities, whether or not squirrels exist, right, independent of the existence of squirrels, right?
Also dependent of whether there is a squirrel nearby or like a human nearby.
Right.
Like,
So those force relationships are possible, but like they need not be like there need not be organisms, right? Like squirrels to exist
like,
for that to
even if
like
we
that
kill all
affords
of
to be
the
like existing.
even if we kill all of the humans, a chair is still something a human could sit on if we still
Yeah.
humans again someday. Like when that
And that's really why like things like squirrels evolve the capabilities to like translate upward on a tree, right?
There was
Because it affords that.
I had told
Yeah.
G about an old debate that Nye and Zulu had about art. Like, even if nobody existed, if the art were to be able to still be interpretable. And I remember Nye was of the position that one human somewhere out there just had to exist for the art to
Yeah.
be interpretable. And Zulu took that no, even if there were no humans, the art could still be interpretable. And that is
it just means that
more
it won't be
closely to
interpreted.
No, but
That's
like,
closer to the dispositional theory of affordances.
Yeah, it is.
Exactly.
uh, let me think about that. Well, interpretable. Like, sure, like if let's imagine this. Let's imagine something happens tomorrow. Like an asteroid comes and wipes all of humanity out, but like some art pieces are left. There's nobody left to actualize the potential of interpretability, but the potential still exists, right?
Right.
Because
So
the
you're
art
thinking about it
actually
exactly
is a
like
property of art.
you're thinking. Yeah, potentials are real. Affordances are basically potentials. You know, they're
Mhm.
resources, right? And that's
Yeah.
how we understand it actually. Like thermodynamically, that's how Turvey understands it.
Yeah, and for example,
Mhm.
if like a trillion years later, maybe not trillion, but like many years later, if aliens evolved and then came to Earth and then saw the art, they could still like try to interpret, and maybe if they were lucky and had enough information, they could.
And so connecting that to the fourth, remember the fourth law earlier that we talked about? Turvey and Swenson in their papers and like in lectures on perception, you'll see Turvey, he talks about like basically life exists in order to access otherwise inaccessible potentials at, you know, the scale where living things exist, right? And
I wouldn't say
you
that's
know,
why life exists.
well, that's what that's what Turvey and Swenson would say, right? With reasoning from the fourth law, right? And global evolution. That's what global evolution claims, right? Or it implies, right? But with the ecological understanding, right? It implies that, right? And like they like give a whole like argument for this, right? Lecture, like in lecture 20, Turvey goes through this whole argument about it, and like in other places too, you'll find it. Sorry, is my mic fucking up, bro?
No, that's all right.
No, no, it's fine now.
Sorry, I was
Uh,
laughing
it's
because I was
mostly
reading
fine.
what you said in Zulu core. Bro.
Oh,
Fucking
I don't know
based.
how. So far, I don't think I agree with like life exists for that, because that feels like an intrinsic purpose to life.
well, think about it. Well, it's not like that. It's the planet as a whole, right? Is it selects for certain like it selects for order, right? Order, increasing order to be like life, you know, to be produced, right? Uh, in order to dissipate, right, the geocosmic potential, right? Well, there's the geocosmic potential, right? Like this, the Earth is being bathed in radiation, right? And it's like there's this real opportunity, right, to sort of exploit that and increase the rate of entropy reproduction with living things, right? And um,
And one thing I noticed, for example, is that light gets absorbed by dark things more, and it so happened that when humanity evolved and we invented solar panels, we are now covering Earth in like black squares, and that's like capturing more of the radiation from the sun, literally, and like it's just
Well,
order that makes production
plants were
entropy
like
faster.
the OG solar panels.
No, but like even the current ones, you still need to like even if it's not for heat, it's like for like knocking off electrons or whatever. But still, the panels have to be black so they absorb the energy.
Uh-huh.
You don't reflect it
Well,
back; they just absorb it into bouncing off electrons instead of absorbing it into heating up. But the effect is the same. You capture the energy, just more efficient to capture it like off electrons from the atoms instead of just heat up black surfaces.
But like, yeah, like the Earth initially, maybe like 3 billion years ago, was like this molten lava hot planet that just had like all of
Yep.
this constantly changing tectonic shifting and super unstable, massive energy synced environment. And then over the course of like the past 3 billion years, there's been life that's been developing in order to, wrap up a lot of this energy. Without a lot of this life that is going on, there would be like all of, we'd be back like 3 billion years ago where, it was a super unstable, disordered.
Yeah, like the atmosphere composition was completely different and stuff, and so on.
Mhm.
Yeah, like I think like there's this oxygen sinks, like iron in the
Yeah.
ground got oxygenated, and there's still more saturation of oxygen after that, and so on. It's
And
the potential.
yeah, Swenson talks about in his lecture from the I think it's like the Swiss Institute or whatever.
Pretty sure
He
it's
was
talked about
talking
in this
about how
paper too.
over the course of like living things history, as the oxygen increases, there's been like more and more uh you know we went from plants to what, like animals to,
Yeah.
more and more developed species until we got to like humans, who are basically like the generalizers of the world. We do like almost all sorts of different things that maybe like plants would do, and
Yeah,
But
scavenge.
we farm plants, we harvest them, and
Yeah.
we do the solar panels. We take out oil from the ground, and we use up the chemical energy potential by burning
Where did
it.
G go?
So on.
I don't know.
G
I
left
had
a
trouble
few
with
seconds
that.
ago. Maybe he's trying to fix his internet. Also, I need to walk my dog for a second, so be
He
back
got
in
dissipated.
10 minutes.
uh, well, the problem that I'm having here is, like I I might need more time to like properly formulate this. However, like give me like 5 seconds to like think about this.
Oh no, I could just add something that describing like what we do in terms of these thermodynamic explanation doesn't take away from what we actually experience, right? It's like, oh yeah, you can describe love and chemicals, and that might be part of it, but that doesn't exhaust what love is. It's not because we explain what we do as humans in thermodynamic like language and principles that oh yeah that our ethics is any different. Right?
No, that's fine. That's not what I have a problem with.
Okay.
I think I remember Luca's issue was like the idea that it's intrinsic. That like,
It very much feels like evolution is this like universal central
Already
mind. Like
covered it.
I'm just like I'm
Mhm.
probably like misinterpreting something, or
Yeah,
maybe
no,
there's
that
like some problem.
Swenson, I think, covers that as well, like the watchmaker analogy that Darwin had, where it's like, somebody's like out there, casting all these spells for living creatures to come out of, but like really
Got a wizard money
the
game.
shift has been understanding evolution as much like a tinkerer. Like, it doesn't have like a grand plan here. It doesn't have like this intrinsic plan for, the progression of beings to develop out of. It's just that, there's random bullshit at the wall that's being thrown. There's like all sorts of different very unique and interesting living things, living species that are coming out, and then slowly over time, what is being selected are the, best species to achieve whatever role
And
it's trying to
that's
achieve in the
fair
universe.
enough. But like, wouldn't you say that that's a like to me what's happening here is, let's say there is a particular type of uh, physical chemical environment on Earth which led to the you know formation of organic matter, which is like carbon based matter, and which led to the formation of the first prokaryotic cells, and then
Sure, but
you know
like, sure.
from there it was simply niche maximization, and that what we describe it as evolution, but it's not like evolution is a thing which does the selecting. Like the
Mhm.
selection is a descriptive and not a active process here.
Well, it is an active process. It's just that it's not like an intrinsic process. I think that's my point more or less, is that like, yeah, we can have a world where, the physical chemical properties of the world are, allowing the development of certain organisms to occupy various niches. It's just that at the same time, there's a lot of incredibly active energy that is going on the earth, that we've seen and we've understood that, like, billions of years ago the earth was rampant with energy, and then it's been a
Yeah.
process over time of organisms slowly, dissipating that energy, all these potentials, because like energy is like rampant potential. So,
Mhm.
all these organisms have just been developing to dissipate potentials, and that's what
See,
thermodynamics is about.
I do. I agree in a sense, and I disagree in a sense. And let me explain how. I would agree that that's what organisms are doing, but I would phrase it like this, and let me know if you agree with that. Is that due to the presence of all of this energy, it allowed the development of these organisms, right? It's not like they had this divine purpose to just dissipate energy out there.
No, nobody's saying.
It's not
But
divine.
like,
Yeah, no.
can you guys hear me?
Yeah, we can
Yeah.
hear you.
Yeah, now we can. Yeah.
It's
Yeah.
not.
No.
There's nothing
No.
divine in
Yeah.
a room.
Physics is. There's nothing magical about this, right? Physics is active and directed. All of physics, right? Irreversibility is a ubiquitous phenomena across all scales, right? All real world processes are irreversible processes, right? They're end directed, right? They're insensitive to initial conditions, right? So
Yeah.
that's why thermodynamics is universal.
I think something important to add is that the world is rich with meaning. So the fact that there is indirectedness, it doesn't need to be supplanted by something outside of the universe or something extraordinary. It just needs to be that.
Yeah, if you can hear me good,
Negative.
I can give a good example of the fourth law and work.
Mhm.
Go ahead.
Right. So, can you hear me good?
Yeah.
Yeah.
Right. So, Swenson and Turvey, they give multiple examples. They give, repeatable, testable, like experiment, like to show it, right? But they also talk about the example of like a cabin in the woods, right? Like it's cold outside, right? And it's warm inside. There's a fire, right? There's this temperature gradient, right? There's this temperature difference, and so like right now, like the heat, right, is trying to flow out, right, to the environment, right, trying to spread out, right, is going to the environment, right, to the colder. The heat is trying to go to the colder place, right, and the cold is trying to come inside, right. So it's going through like the cracks in the wood, in the windows, in the door, and all that, right? Like wherever it can go, right? It's transported by the circulation of the air, right?
Mhm.
The heat being transported by the air, right? And so what happens when you open the door, when you just open a door, right? Uh, the whole room, right, organizes to transport as much heat as possible, right, out this new path, right? Like, and it's like that's why they tell you, to close the door really quick, right, not let all the heat out, right? Because it'll go out like as fast as possible, as much as it'll transport as much heat as possible out that new path as fast as possible, given the constraints, and then it'll allocate, it'll select, right? It'll allocate as much as it can to that path, and then it'll allocate to the next fastest path. The cracks in the window and all that, right? And the next fast path and the next fast path. And that's just like an example. That's just like a metaphorical like example, right, to illustrate it. But like there's like an experimental like sort of like apparatus with like adiabatic like barriers. I forget exactly how they do it, right? But like they set up this kind of like experiment where it's like you can go through this path and this path and this path, and it allocates, right? It selects, right? And it's like there's nothing mysterious about this. It's just physics,
No,
There's nothing
I don't
mystic.
disagree on the science of it. Like I'm disagreeing on the
Well, yeah,
theoretical
but
part.
it's not. That's the thing. It's technical. These are special. Like you need to actually look at the experiments and the research, right? You can't just like reason about it like just like abstractly from your
I'm just,
armchair. You know what I mean?
of
That's not how
course.
thermodynamics like throughout all of history developed. Like it
Sure,
like
sure,
developed
sure.
through
I'm not
the
saying
study.
that I am doing that. I'm saying from from where I'm sitting, like so far what I've read, like I do like the best thing that I've
Yeah,
found is the
this paper isn't about the fourth law. Like it's
yeah,
not
yeah,
like that's not the
fair,
center,
fair.
the focus of this paper. Like that they have multiple other papers, and like there's a lot of other literature about that in particular, right? because it's like
I'm just telling you.
it's been a, like
what I am getting.
a research like a subject, right, since they've been working on it since like the 80s, right?
Sure. I'm not saying anything other than what I am getting out of this paper. These are my potential problems. Potential problems. Of course, like
Okay.
I am not sure about them because I've not interacted with the whole literature, and I will. But like, even there, I do think like the best thing that has come out of this paper for me is the idea of an affordance. Like that's a good, valid concept, and I'm gonna keep that in my mind from now on.
And it's
But-
just a super surface level like understanding of affordance. Really, there's so much more like you'll find in other papers about it than in this one.
Mhm. Sure, but I'm still getting something, right? So I'm gonna
Yeah.
conceptualize that. Let's continue.
Like I don't know why you're so quiet on my end. I have everything turned up all the way. Like I just joined back, and now you're so quiet. Like before, you weren't so quiet.
Uh,
Struggling
I
here,
can
but I'm
lean into my mic a little bit. Is this better?
no, bro. It's mine. It's my end, bro. It's like
Okay,
fucked up on that.
no problem. Okay, so
Yeah, we'll keep going.
let's go.
Hopefully, it doesn't echo. I'm gonna play it from my speaker, my computer.
Mm.
Hopefully, it doesn't echo. I'm gonna turn it. It's gonna be like I can hear you guys.
Affordances are opportunities for action, and the perception of looking them is the basis by which an organism can control its behavior in a forward-looking manner, that is, prospectively. To assume this essential role, however, the term affordance cannot refer to states of affairs that depend on perception or conception.
And again, this whole idea of affordance-based control is like not like just like a vague hypothetical idea. This is built on like real like a large body of empirically like a large empirically established body of work on affordance-based control and like how to study it.
For sure. Like that, I have no problem with so far. I have some problems with certain theoretical formulations, but I'll better be able to voice them when I've read more of the literature, I believe.
Yeah, like I said, it's a technical concept, right?
Yeah.
It's not like a philosophical concept.
Mm-hmm. From our perspective, this relatively innocuous identification of a niche as a space of real opportunities for action promises to revolutionize the study of cognition. As an organism moves with respect to its surroundings, there are opportunities for action that persist, opportunities for action that are newly arise, and opportunities for action that dissolve, even though the surroundings analyzed as objects and the relations among them remain the same. In the effort to model cognition in the present century, the knowledge base presumed to be needed by organisms or agents has been identified as innumerable static objects and relations. The affordance interpretation contradicts this presumption. A change of pace or a change of location can mean that a brink in the ground, what is brink? I don't know.
Like
I was saying earlier, like a falling off place.
Okay. Now affords leaping over, whereas at an earlier pace or location it did not. Further, subtle changes of action can give rise to multiple and marked variations in the opportunities for subsequent actions.
If you want a visual illustration of this, you can look in lectures on perception. Like you can control that for brink, and there's like a visual like figure of this, and like several other papers too. This is a common example.
I mean, from the point we have started this headline, I don't have much problems. I think like this is good stuff that I agree with, so to speak. Where were we? Therefore, where were we?
We're right there.
Brink.
The affordance.
A change of pace.
Yeah. A change of pace or a change of location can mean that a brink in the Further, subtle changes of action can give rise to multiple and marked variations in the opportunities for subsequent actions. The environment for the organism is dynamic and action oriented, while the environment in itself that which has been the target of most modeling in the latter decades of the present century, is fixed and neutral with respect to the organisms and its actions.
It's not saying that the latter is valid. Like it's
Yeah,
saying
yeah,
that like
yeah. I have no problem with this. Yeah, yeah. In the new century will witness a thoroughgoing attempt to build a functional semantics, if for no other reason than the need to build robots that work with respect to environments that are real. Okay, that are real. What do we mean by functional semantics here?
yeah. Can we catch a glimpse of the building blocks of this function-oriented semantics?
Yeah. So,
It's the next paragraph.
oh, okay, okay. But like, what is the word
I
functional
mean, it's giving
semantics?
you an idea with the example that it was just giving you about
Sure, sure.
opportunities to action, real opportunities of action that
Yeah.
that newly arise, that dissolve, that change.
This
In
is
the eventful environment.
this is, I believe, like from my experience, this is like a reinforcement learning robotics, right?
Yeah, it's similar to that, but it's a lot. It's really different. Like there's a lot more. Like you probably don't even. It's not familiar to you, you know.
Yeah.
But there's a lot more research that since this paper, since like on affordances for roboticists, right?
Mm-hmm. Can we catch a glimpse of the building blocks of this function-oriented semantics? In conventional physical analyses, the property of a thing that is potential or latent or possible, that is not occurrent, is referred to as a disposition. Okay. Like this is a very academic paper. They don't mince words. They don't try to explain what they're saying here.
Yeah, because they're academics.
Yeah.
Turvey, he's like a
I mean,
legit academic.
He did describe something, and then he said that's a disposition.
Mhm.
So he did explain.
Yeah, but like it's not like friendly to the first time reader. So like
Well, yeah,
it
it is a
true,
research
it's
paper,
not.
of course.
It's not first
fair
reader
enough. Like
friendly.
it's made for researchers by researchers. So yeah, I'm not like bashing them for this. I'm just like describing that's what I think.
Oh yeah, this paper is definitely made
True.
for the ecological psychology crowd.
Mhm.
And it has produced like this paper in particular has produced a lot of like I don't know what you want to call it, right? I don't know what you would call it,
Buzz.
like progress, right?
I was gonna say
Like insights and yeah, stuff like that, right? Like Turvey in 2013 gives a review like of like the history a little bit and like mentions this paper, and like how they were they've like where they came where what's the fucking way I'm trying to say it, bro? Where they came since then? That's not the right way to say it, right?
I don't know what you're talking
How
about.
far they've came, how far they've came since, right? That's the way I'm trying to say it.
Sounds like a retrospective.
Yeah. Yeah.
Like influences and progress in the.
Yeah, the paper I think is called "From Physical Education to Physical Intelligence." It's in the collection of Turvey's papers that I linked.
Yep. Hmm. All right. So what do I understand by disposition so far? And then there is a potential or not a okay, fair enough. The primary characteristics of a dispositional property are three in number, and they are basic to developing the notion of affordance. First, the disposition to do something is prior to doing that something. Fair enough. For example, a crystal will actually refract light provided that is refractive to begin with. If it was refractive to begin with, then it was so whether or not it was exposed to light. Let me look at this. What does this mean? A crystal will actually refract light provided that it was refracted. Okay, so a thing will do a thing if it has a property of doing that thing.
Yeah,
Yeah,
and
crystal is not
there's a lot of literature on dispositions, like the ontology of dispositions in particular. We did a whole, like, if you look on Sackler's channel, we did a whole like discussion on affordances of dispositions, and I gave a bunch of references to the literature. So
All right. Second, dispositionals or causal propensities come in pairs. For example, that I can already understand. That this is a point Inductica makes in his broad physical categories as well in the recent.
yeah, I know. He makes a similar point. Yeah.
Yeah.
You'll appreciate that Turvey makes like a lot of similar points. Like he's low key like an objectivist. I think you know he's actually referenced. He's cited objectivists
Yeah,
like
no, I'm
David
pretty sure
Kelly.
he was.
Yeah, but he just isn't like he's an academic, so he's not going to be like super explicit about it. You like a lot of the stuff that Turvey says on ontology. I think you'll appreciate if you appreciate the stuff that like Inductica has said. You know, on the broad physical category stuff, especially.
Yeah.
I was watching some video. I'm not sure what it exactly was. It was like someone talking about the ecological psychology in general and like philosophy behind it, and it was basically like pretty much objectivism.
Yeah.
Does somebody want to link Turvey's ontology paper, the 1992 paper?
I know.
What paper?
The one on perspective control. An outline of the ontology for affordances.
I don't think I have it.
It's in the Turvey papers.
Is it a
Collection.
2013 paper?
No, it's 1992. But
1982. No, I don't think I have that one.
it's in the important Turvey papers, like in the collection that I give. Okay, whatever. Just link it later.
This is what
Just keep going.
so far, I didn't agree
Yeah,
with
just keep going. I'll shut up for now, bro. I'll shut up.
Yeah. Like so far, like I'm really enjoying as we're getting to the biological and perceptual science stuff, I'm really enjoying and agreeing with this a lot. I didn't agree with a lot of the broader theory about like physics and the thermodynamical theory they're going into, and that I'll do my due diligence there. Either they're wrong or I am wrong. So like I'll do my due diligence to find out. But so far as they're getting into like biology and perception science and evolutionary biology, like a lot of agreement here. Like this is like music to my ears so far.
Yeah, it's interesting as hell.
Yo, Sertino, are you still there?
Yeah.
I haven't heard you talk, bro. You gotta talk more, bro.
I mean, there's not much for me to say.
Okay, I'll just wait until Luca asks a question, bro. Because I just feel like
that's
if we
what
keep
I've
talking,
been doing. I've just been answering questions.
Yeah. For example, all light rays are also just a quick question. Have you guys been following? Of course, like there's very little information about it on online, but Inductica did a video about concepts as volumes, I believe.
what?
Like
What?
it's an AI thing. Like look up Inductica's video on like the new AI project that they're working on. Like you might be interested in that. I cannot reveal too much because I am under a NDA about that. So just look at his video.
Huh.
Okay.
Yep. Like basically, I can reveal only what was said in that video, but I don't remember what was said in that video, so I'm not going to say anything. Just watch the video. Yeah.
Okay, man. I won't say anything about it then. Right now.
Yeah.
Don't want to get shot by the Inductica Mafia, I guess.
It was a voluntary NDA that I signed, man. Like, it's fair enough.
God, I didn't know you had to sign an NDA over it. Is it like are they
Great.
doing like a big
Let's
reveal?
continue. Let's continue.
Yeah.
Let's move past.
Yep. Hmm. Where are we nowadays? Yeah, there.
Second, dispositionals or causal propensities come in pairs.
Second, dispositionals or causal propensities come in pairs. For example, all light rays are refracted if and only if some pieces of matter are refractive. In respect to the organism environment mutuality and reciprocity thesis, it is noteworthy that reciprocity occurs in the very definition of a dispositional property. But dispositionals never fail to be actualized when conjoined with suitable circumstances. The character of an affordance can now be more clearly expressed. It is a real possibility, that is a dispositional property, and it is reciprocated or complemented by another dispositional property, an effectivity. Yeah, this is cool.
A good example for this is like like a cutting system, which we would call a cutting, like for we identify the function, right, and what's required for cutting to be realized, right, and it's like
Mhm.
we take a saw and a tree, right, one has to be sufficiently soft and the other sufficiently hard for cutting to be realized, right, so they don't have to be identical, right, one doesn't have to copy the properties of another, right, they
Yeah.
just have to fit like puzzle pieces, you know what I mean, and like mutually support the function, right?
That was like the
Yeah.
major innovation of blacksmithing, was that the metal always needed to be harder than the metal being worked on.
Right.
Yeah. Mhm. Uh, yep. Yes, continue. And effectivity is the causal propensity for an organism to effect or bring about a particular action, whereas an affordance is a disposition of the surrounding environment, and effectivity is the complementing disposition of the surrounded organism. Bunch of papers. Thus, an affordance is a particular kind of physical disposition, one whose complement is a property of an organism, a property of an organism. The upshot is that from the perspective of investigating knowing about, an organism's needs constitute two structures that relate in a special way, such that understanding of one is simultaneously an understanding of the other.
Yeah, we have
The
an
form,
organism referential description of the environment joined with
yeah,
an environmental referential an environment referential description of the organism.
yeah, that's fair enough. Like I agree with that, and I can like it fits neatly within my head about this. No contradictions detected with present knowledge. If the form of this special relation could be made precise, then an important step would be taken toward understanding the class of material systems that exhibit knowing about. Hmm. Yeah, makes sense. Mutuality implies a sameness, a commensurate dimension. They use commensurate, based.
Yeah.
Let's go.
I was hoping you were going to notice that.
Yeah. Mutuality implies a sameness, a commensurate dimension over which organisms and in their environments might transact business. It's
The
capitalism.
dimensions of activity in
Yeah.
particular, right?
Yeah.
Activity relevant dimensions.
Yeah. The relationship between organisms and environment must reflect their different functions in the ecosystem. A bipolar dimension over which they act and react in a reciprocal but distinct ways that nevertheless fulfill one another. Consider the analogy to numbers that add up to one. They are mute. they- Consider the analogy of numbers that add up to one. So this is like infinite series adding up to one kind of thing. Yeah.
Not really. It's about like they might have different values, but they both add up to one, right?
Yeah. Fair enough. Fair
Like
enough. Got it.
a change in one
Yeah.
is a reciprocal change in the other.
Yeah. Yeah.
A proportional
But the
change in the
sum
other.
is one. Like yeah, makes sense. X plus y equals to one, right? Like
Mhm.
if you increase one, you got to reduce the other
It's a
one.
conserved totality, basically.
Mm-hmm. Are mutual in the way they may be added to one another, symmetry, but reciprocal in the way they have different values, asymmetry. A symmetric property can be reconciled with the asymmetry property by moving to a higher level of analysis, namely to the notion of numbers being complementary in the sense that they complete one another. Likewise, taken together, the organism and environment may be mutual and reciprocal, symmetric and asymmetric, but at a higher level, they are complementary duals. They combine to make a whole, an ecosystem. It is apparent, therefore, that the asymmetry of dualism, where organism and environments are merely incommensurable kinds, must give way to symmetry notion of duality, where the two are commensurate kinds. Otherwise, there can be no synergy, without which there could be no ecosystems. Under this synergy, biology and physics come together with psychology to define a science at a new scale, the ecological scale, at which physical law might conceivably become more unitary. The alternative treats the relationship between knower and known as a metaphysical dualism, with the organism as knower and the environment as the known, coming under different laws, or worse, viewing the environment as being lawfully independent of its function or supporting the organism, and the organism as a perceiver actor whose functions lie outside the scope of any law. Hmm. Fair enough.
Can somebody screenshot the figure in lectures on perception in lecture 24 on ecological action mechanics? Screenshot the figure in the description right below it. Just screenshot it.
Lecture what?
Lectures. Which one again? Sorry.
Lectures on perception. Lecture 24.
24. Okay. 300.
I'm in the wrong one.
Finding it now. Lecture again 24.
Which
Yeah,
figure
the
is
section
it?
on ecological action mechanics.
121. 23. 20.
Just keep going while they find it.
Found it. Okay, it's which one?
I think it's this one. I think I found it.
The figure in the like description of below. Like it's like a one paragraph section. The
That
figure.
one?
Did you post it? I can't look
Yeah.
like where my is gonna fuck up. I'm gonna lag.
1 second.
Luca Brazil, you can look at
Which
it.
figure? Which figure exactly? Because they are numbered.
24.3, right?
Yeah. Posted in VC
Yes.
text.
Yeah,
it's in VC text.
yeah.
Wait,
You
also
look
the
in VC
paragraph.
text,
The paragraph
Luca.
also.
Luca.
To include the paragraph.
Bruh.
Yo, Luca.
Yep.
You look in VC text, bro.
I'm gonna do that on my second screen so that this doesn't get disrupted.
Just show it up on the screen, bro.
Switch,
that we're looking at.
just switch the tabs to it. Just click the Discord tab. It's in a higher up.
This one?
Yeah. the description too. You see? So this is one tool that we use, right?
Mhm.
The description is in the other picture.
The second one is with description. The same thing, but the second one has a description also. Just look at it and also the description.
Oh yeah, you didn't get the whole description, bro. That's just like you cut the paragraph in half with the paragraph. Like the paragraph is above the figure, whatever. But yeah, it explains like how we define like the like the ecological scale using what is it? Planck's.
Mhm. Fair enough.
Yeah. There's more that goes into that. Yeah. Just to give you an illustration, sort of how we do it, right?
Mhm.
But I think it's like it explains there what the inner scaling is and the outer scaling is. You know, the quantum physics
Yeah.
in the top paragraph. Yes, Planck's energy distribution equation for the lower scaling, and Einstein's energy conversion equation for the outer scaling.
Mm-hmm. Fair enough. All right.
All right.
Okay.
I thought that was important. You know, I thought
Yeah,
you would have liked that.
I do. I just like don't disagree, so I have nothing to say. I'm just like learning.
Nice.
Yeah. I do appreciate it. In sum, a special relation in question between organism and environment seem to be the particular kind of isomorphism captured by the mathematical notion of duality. Duality is an abstract rather than a concrete idea. It refers to a relational property, a correspondence holding between a pair of mathematical objects. Duality holds even if two objects are of unlike kind, so long as some property of the first object plays the same role among its total property set as played by a property of the second object among that object's total property set. For example, with respect to a series of perceptions and a series of actions, as might be exhibited over time fulfilling a goal, a duality will be an operation that establishes a correspondence between the properties of two series, even though they are quite different. What do you guys have something to say about like explaining this? Like,
Yeah,
what?
I was about to ping you here.
Mhm.
There's more on all that stuff, like a bunch more on all that stuff in the again organism environment system note. Like I collected a bunch of stuff on that. But
Yeah.
yeah, they also uh, reference Shaw and Ali there. This is something that Shaw talks about a lot in a lot of his papers. So I can I don't know if it's gonna lag me. I can try to link Shaw's papers. I think it's gonna lag me too much.
Well, I don't see it as all too different from what G was talking about with the example of the saw and the tree, where
Mhm.
they might be different, but they're complementary in fulfilling some sort
Yes,
of goal.
yes, but Shaw gives he tries to he talks more about this like mathematical description of it, like understanding mathematical understanding of duality, this duality notion, and he talks about a lot of stuff he talks about also is like symmetry group theory, like Noetherian like kind of analysis.
Well, I guess the important part is duality as an abstraction versus where the dualist will treat reality or duality as like a metaphysical fact. And that was being talked about in the paper, how like for example the Cartesians will treat
Well, it's just saying what it's saying is that any distinction, any difference, or anything, right? If there must be some conserved totality, some commensurate, you know,
Mhm.
or some level, some scale at which they're commensurate, right?
Yeah.
What it
Like
reminds me
That's
of,
what it's saying.
I'm not able to fully connect it, but uh,
Yeah,
have you guys
and
well,
also I'm saying go in BC text. I linked you. I mean, I pinged you to the organism environment system note.
yeah, yeah.
If you search like commensurability stuff in there, there's a lot of cool stuff in there on that. Like a
what
lot of cool
was
notes on there
what
that I
was
think you'll like.
Mhm. Yeah,
I think you'll really appreciate that.
I will.
You could always ask me about it. Like if you're reading it, you could always ask me about it.
All right, I will DM you. But this reminds me somewhat of, let's say, a convergent evolution, if you have heard of that.
Right.
Like,
Mhm.
yeah. So like, uh, I have to like,
Yeah, that's one. That's one example. Like that's one analogy,
yeah.
sort of. But I that's also in my notes there.
Okay.
Mhm. But yeah, no, I think that the explanation that you gave is probably the best explanation, where it's just that like there isn't like a fundamental dualistic incommensurable split between two specific things. There is a, if we zoom out, there is always going to be a larger axis by which they are commensurate. Two things that seem uh incommensurate, if they are zoomed out, they
Yeah,
will.
and this is just the first law. This is really just what I take to be the first law of thermodynamics. What we're talking about right now.
Mhm.
Like if it looks like energy is being gained or lost, you need to widen your view to where it stays the same. There's no energy being gained or lost.
All right. The discussion of duality that was initiated by the implications of figure 11.2, which was this is 11.2. Okay, fair enough. Are encouraged by the issue of a functional semantics has in the immediate preceding comment focused upon the fit between perception and action under an intention to do so and so. Most of what follows is concern about the steps needed to understand that fit. Controlled locomotion and the
We can go fast past this one. Like a lot of the stuff here, we go fast.
so go fast or go past.
Like in these paragraphs here, like in these paragraphs on this page, we can go fast.
Okay. So controlled locomotion is the paradigmatic form of knowing about. For most scholars grappling with cognition in this final decade of the 20th century, the dominant tendency is to equate knowledge with concepts and to inquire about their form and about the inferential process, explicit when cognition is defined as symbol manipulation and implicit when it's defined as connected subsymbols that operate upon them. The grounding of the concepts, that is, how they can refer to the environment of the knower and the origins of the constraints on the inference mechanics, that is, reasons that these mechanisms should function in just the way that renders their consequences sensible, meaning that one could, in principle, act upon them, are not of paramount concern. For criticisms of this attitude from our perspective, see all of these papers, a lot of papers. Tends to be investigated as disembodied rational process. As a disembodied rational process, concepts and inference mechanisms can be lifted away from organism environment systems and perception action subsystems that express them and modeled in their own terms. Accentuating the already troublesome features in this modeling strategy is the fact that it requires a designer who must determine what constitutes the objects, events, and relations to be conceptually represented on the basis of his or her own experience, creating a frozen static ontology peculiar to the designer's whims, kind of based language there. A major promise of the neural network perspective is that the preceding difficulty is circumvented because the concepts in the perspective are not described but emergent, arising from the interactions among very many symbolic processing units. Unfortunately, a critical examination of net talk, often offered a primary example of successful emergence, reveals that conceptual distinctions eventually exhibited by the network are already implicitly coded by the designers into the patterns fed to the network. I do not know how much I agree with this, because what I have read about
Turvey talks about it. This is in 1995. This paper, but remember Turvey's lectures on perception was released in 2019,
yeah,
and he gives
but
a whole he gives a whole discussion to the whole
yeah,
symbolic thing, like
sure.
theory.
But all I would say from my perspective here is that I am not an engineer. So, however, I've done some machine learning courses, and to my knowledge, like this is a black box. Like we don't act, you can't really code it. Like it is definitely like we don't know exactly what happens in neural networks in all honesty, but it's some
I mean, There is
does
this.
I mean, we do, but not with a we do from an engineering description, from a physical description that does not like that description is not what computation is based on, which is the formal description that the engineering and like the physical constraints actually like constrain, like they condition that like under those conditions, under these thresholds, we're allowed to treat it this way, treat it as like we're able to ignore the material details and all that, right? And there's a lot that goes into this, but like it's the black box understanding here. Like it's just a thing to do with how formalisms like work, and how
It's not
computation
really a
works,
black
and like
box,
how computational engineering works.
There has been like some extremely recent research where like Anthropic is trying to do some bullshit and make people think that Claude is like sentient, but the thing is that they're using like some mathematical transform to sort of decode the internal associations that the model is like using during the inference. So like if you ask it like what's the color of the fourth planet or whatever, it will like you can decode that it had Mars somewhere in the inside while it was like putting the token between the different layers of the thing. But yeah, it's still just like a just fixed function at the end of the day.
Yeah, I think with computers, really, especially like things like artificial intelligence, it's operating off of like the past 40 years of already provided information on the internet as its like database.
It's just
Literally the entirety of the human knowledge as expressed on the internet is it's
only can
database.
understand associations between like the.
That's the only way LLMs are possible.
Like it can't
I
create
think
new ideas.
Yeah, no, of course not. Here, Luca.
Yep.
On this is like, since it's talking about the motor, like this goes into a lot of the history there and like the black box perspective and like all that stuff, and but also look at lectures on perception, what Turvey explains there. Yeah, he gives a whole steel man. Remember, like I said, he gives a really like solid steel man of everything that they say, so you can understand what they're saying and why it's wrong.
But
Alright. Good.
I was gonna say, like, I do understand the sentiment that it's like the programmer does not have to intentionally code into
Yeah.
a machine learning system every single answer it might be able to say. It's, obviously computers are pretty nifty in that way. That we use computers actually in order to not do that kind of work, in order for us to not have to program every single small little thing into the system. We're able to replicate many things, we're able to automate many things, which is kind of what computers are meant to do in a sense, part of their role. So instead what we do is we provide a very large database of information for an automated learning system to acquire. But at the end of the day, even if we're not programming it, it's not.
But it's really a misnomer to call it learning, even.
Yeah, that I think that is the point. I'm using like the term of what they call it, but it's like how we call artificial intelligence. It's not like it's like a intelligent thing. That's again like another misnomer. It doesn't learn. It's not intelligent. It's like it's just a computer.
It's like large language models are like an extremely lossy compression of like relations between the symbols that we use for like actually describing reality. So you can get sentences and like phrases that make sense when it comes to grammar, and also when it comes to the relation between some of the to large extent some of the like keywords used. Like you can see.
Yeah, but its rules are just embodied, like its syntax is just embodied.
It's only like memorized.
It has to be embodied.
Like the structure is only a lossy compression of what we have encoded in language as keywords. So
yeah,
like uncommon relations between different words will not get like taken advantage of by the model. So like talking about topics on which
I think we should move on.
Yeah, that's true.
I think we should move on.
I think it'll take us one more session to get through this paper, man.
Let's say like 3.
We're gonna get into the juicy part now, where it's gonna really pull us through.
Yeah.
Yeah, that's
I-
You
right.
always say that.
I'm trying to get past this, but we're gonna get it.
Let's be realistic here. Like 2 hour podcast, like it's almost 2 hours now. Like it's gonna take us one more reading, man. We're like what, page 11.
Maybe 2.
Let's
but
do it.
yeah.
Let's do it. Come on.
Yeah. Yeah.
Let's get past
I'm
this.
not against it, by the
Let's
way.
go,
If it
let's
takes
go, let's
one
go.
reading,
Scout Steve.
I got the time, bro. I don't know if you got the time. Let's go. Let's get past this now.
yeah, where
Yeah,
were we? Like
this is all stuff that Turvey
Yeah.
talks about in way more detail in lectures on perception, so we can like
Mhm.
go a little past this.
The disembodying of cognition is a constant with organism environment dualism, and it reinforced by the choice of what counts as paradynamic cognitive phenomena. Popular choices are the human capabilities of syntax, problem solving, remembering, expert knowledge, and the like. These phenomena seem to be so focused at or in the individual that's so trivially dependent on the current environment or ongoing behavior that they invite analysis in purely formal abstract terms, and the modeling of environment and behavior conceived as inputs and outputs respectively
IQ.
in the same abstract terms. In consequence, broaching the problem of how symbols, inference mechanisms, and task ontologies are grounded rarely occurs in the context of preceding choices of paradigmatic cognition. And even if an attempt were made, it is not clear that these research domains can provide a sound basis for addressing the grounding issue. We have 2 reasons for this pessimism. First, grammar, problem solving, remembering, expertise, knowledge, and the like are too far beyond the pale of the current stock of scientific tools by which nature's phenomena are understood in general law-based terms, reducing thereby their potential as basis for substantial progress. Second, and perhaps more important, they cannot be considered as fundamental forms of knowing about, nor can they be considered as having posed major challenges in the evolution of material systems with the property of knowing about. Returning to the figure 11.2, most of the past 3.5 billion years seem to have been consumed by the establishment of the ability to move in a controlled and directed manner, to tumble, to walk, crawl, walk, jump, fly, swim, slide, burrow, and so on, among the environment's persistent and variable clutter, receiving the actions the material layout allows with
Also add with
significant
Turvey's later descriptions of like perception action for plants and all that, you know, growing too, you know, spreading out and all that.
with sufficient efficacy to discover energy resources and to implement the circumstances for procreation. We suspect that grammar, problem solving, remembering, and the like are capabilities that arose straightforwardly once controlled locomotion at each and every length scale occupied by living things was firmly in place. Makes sense. We need perception before we get cognition, conception.
Right. Yeah, and this is a good. There's a good quote on from Gibson on this. Like before we even try and think about like a theory of like remembering or like not maybe remembering is not too bad. That's more grounded. But like I mean like dreaming and imagination, right? Stuff like that. We have to. We won't even be able to dream of such a theory without first understanding perception. You know what I mean?
Yeah. What will become extremely apparent as we examine what is involved in controlling locomotion is that understanding knowing about will demand both a broadening and an enrichment of the current understanding of energy and information, an appreciation of the confluence among all 3 intuitive ideas, and a physically grounded understanding of an even more inexact idea, namely intention. This I need to absorb. Let's see. Understanding knowing about will demand both a broadening and an enrichment of the current understanding of energy and information.
Remember how we started the paper, right?
Yeah. and an
So
appreciation
he's saying
of
a
the con-
broader understanding than that understanding that
Sure.
19th century and the 21st century developed for energy and information, right?
Sure.
Or 20th century.
And let me read this and like get it in my head once. That's what it'll mean. An appreciation of the intuitive ideas. What three intuitive ideas is he talking about here?
Knowing about energy and information.
Oh, okay. And a physically grounded understanding of an even more intention. So we're talking about intention now, I guess. Figure 11.3 depicts a dragonfly weaving its way about a thicket of the kind, typifying New England in the summertime. A dragonfly feeds on small insects such as mosquitoes. Let's look at the thing. Opening, barrier, when to swerve, how much torque, perch, edible, right size, time to contact. Yeah, that is all it needs to figure out to properly utilize the niche that it exists.
Or does it need to figure out?
I mean, like something needs to figure out. Like,
Or is it just there to be perceived?
yeah, but like perception is that process of doing that, right?
Yeah. But the information, the structure is there. It doesn't need to be processed. That's the key. It's in this understanding of information is that it's structured by the environment, and we just have to detect it, differentiate it. Right? We don't have to enrich it. Right? We just have to detect it, and we don't have to like. It's not even the kind of thing that can be processed or transmitted along like a signal channel or anything like that.
A dragonfly feeds on small insects such as mosquitoes. In seeking its prey, the dragonfly must perceive paths through the thicket. To do so, it must perceive obstacles to its forward locomotion and openings that permit it passage given its size. Given the many objects within the thicket, insects, birds, leaves, berries, flowers, and so on, the dragonfly must perceive selectively those that are available for it, commonly insects, certain length, scale, and degrees of softness. Must also perceive places that it can alight upon, places to rest between searches, and traveling through the thicket and in direct pursuit of a prey. The dragonfly must perceive when an upcoming twig or upcoming prey will be contacted if current conditions with wing torques, forward velocity continue, so that suitable adjustments can be made both with respect to the body as a unit and with respect to the most forward limbs that are used to effect a catch or a landing. It must perceive the amount of required rotation, elevation, and yaw in three-dimensional space. When it and a prey are not aligned, it must perceive the distance of prey when more than one is within range, and it must perceive when to decelerate, when it is decelerating appropriately, when the catch is close to occurring, and similarly when it's descending onto a perch. The dragonfly thicket system expresses why it is that controlled locomotion in a fundamental form of knowing about. To satisfy its intent in the thicket, the dragonfly must know where it is, where it can go, when it can go, and how it can get there. Let us see what happens, what kinds of things students of cognition in the 21st century may have to grapple with in order to account for how the lowly dragonfly promotes successfully. Yep. So we're going to do direct perception. Like I think let's set the goal of like where does the paper end?
I sent you another link, by the way, on the physics of controlled collisions and like some illustrative figures on that. Like it's pretty important, you know, like because it's different, right? Like it's not like mechanical collisions, right?
Yeah.
Like controlling the forces to prospectively to land softly, right, on a like a perch. You know what I mean?
Yeah.
That's very important.
Yep. And this is, of course, like to the uh, to the living being, it is automatic, but I assume like implicitly there is some computational calculation going on here in like,
Oh no.
isn't it?
Why would there be a need to?
Why would there be a need to?
I mean, to successfully do those maneuvers.
Well, what if the variables are in the environment such that the dragonfly can actually detect them and use them
Yeah,
without
Yeah,
having to like
proper
construct
control variables, right?
yeah, but like, how does it detect and thus appropriately act upon it? Like, there must be.
No, that's what we're
all
going
of
to
that
talk
is
about. That's what they're going to talk about in this paper, and like
Yeah.
what the entire research program of ecological psychology is all about.
Yeah.
that's
I was
true.
saying, let's go to where do we decide to stop today?
like if you see at the beginning of this section here, go up.
We should stop at this point, I would say.
At the beginning of this
This
section,
is where
right? You can see, like you can see the questions that they list there, right?
Yeah.
And one of them is how is the energy that is controlled related to the information that's I forget what they say exactly, but it's like they talk about that in this paper, right? But it's also you know very like there's a large body of work on this particular question because we our view of information is that it's something that doesn't need to be processed and that it successfully guides everyday successful perception action, right, for all living organisms, right?
Yeah.
Just how that works, right? And it's like that's very key. Like there's like the ecological information hypothesis. There's a little bit more to that, but it's very important, right?
Yeah. Like, to me, like, so far, like, this is my intuitive answer to, like, of course, like this is just me thinking about like how this would happen. Like, there is
Yeah, sure.
Yeah. there is like
But I think you'll quickly be realizing your error there. And
okay, let's see. But fair enough. Like,
like in
let's
your
read.
research,
Yeah.
introduction to ecopsych, they cover that pretty quickly. I think you'll get a lot from introduction to ecopsych, especially because there's the audio book. You said you can listen to
Yeah.
that. Right? It's in announcements, by the way.
Quite
The
right.
audio book.
Okay. So I would propose that we end after direct perception because the next topic is like 4 pages long, and I don't
Yeah,
think
but that's where they actually start getting into that question. Actually get into meat and potatoes of it.
no, the problem would be like I don't think we should go for the entire paper today, because like if everybody's like my brain would be too tired to understand by like page 20.
Your
Like,
brain.
what's the point
Yeah.
of like reading
So,
3 pages?
yeah. So let's finish this,
Yeah.
and then
Yeah.
maybe you could listen to like that audiobook later.
Yeah, that's
Because I think
I'm gonna
the beginning
completely
parts of the audiobook are really like they set like a good context for a lot of this stuff, motivation and stuff.
do send me that audiobook in BC text. I'll listen to it.
Yeah, it's in announcements, by the way. Like just
Okay.
you can look in announcements and find the audiobook and the full book there that we did for the book club. Right, we were doing it for a book club. So
All right. Why is there a thing called the Epstein files? Did you guys do something? Oh, that's just.
you mean the channel Epstein files?
That's just that. I just looked into it. It's nothing.
No, yeah, it's just a log bot. It's just log.
Just a log. That's what I thought. Like, have you guys done a deep dive into the files?
Yeah, the Epstein files were redacted for a while. G was getting very upset.
Yeah.
Yeah, the bot stopped working.
What is the ecology of the Epstein Island? That's why we were
Yeah,
reading.
let's finish
Not a
this book.
single libertarian or objectivist in the files, by the way. That's a.
Oh yeah, you can see how the dragonfly locomotes successfully. Right?
The dominant view of perception on the cusp between the 20th and 21st centuries is that it is very much a matter of inference, very much a process that involves
I
reasoning
don't
like
think we
steps.
finished the last paragraph.
We did. Oh, yeah. Oh. No. We did.
I don't think we did. No, I don't think we read this paragraph at all.
This one, right? I remember doing that.
Okay.
I could do it again. What's the problem?
No. I just I don't remember reading this paragraph.
Yeah.
But okay,
I
That's
do
done a
remember, like,
lot.
yeah.
if you said if you said you did, that's fine. That's fine.
Okay. All right. The dominant view of perception on the cusp between the 20th and 21st centuries is that it is very much a matter of inference, very much a process that involves reasoning like steps, albeit unconscious and irresistible. To a significant degree, this view is shaped by the widely held understanding that the light distributions available to the eye, the sound distributions available to the ear, and so on, fail to specify the properties of organism environment systems. The energy patterns ambient to an organism are traditionally thought of at best as containing cues or clues to the world. Consequently, in the standard view of the 20th century, perception becomes a roundabout or indirect way of getting acquainted with and maintaining contact with one's surroundings. Interpreted scientifically as a kind of justification via inference of an organism's perceptual beliefs. This interpretation, which casts perception in the mold of proposition making activity with either true or false consequences, renders perception as a potentially questionable basis for an organism knowing about its surroundings. The ecological approach places tight constraints on the use of the term perception. By promoting a conception of law that allows meaningful relations between organisms and environment to hold, it constrains the use of the term perception to relations governed by such laws. Further, it reserves the term perception for designating only really possible and actual states of organism environment system. These constraints on its usage vindicate perception as the in incorrignite what the hell? Incorrigible. What does this word mean?
Corrigible.
Incorrigible. What does that mean?
Yeah,
So
it
that
means
it doesn't
not.
need to be corrected, I think.
Yeah, it doesn't need to be corrected. It can't be corrected. It can't be changed. It can't be altered epistemically, or supplanted.
Mhm. The incorrigible base for an organism knowing about its surroundings.
It's it's not there's no you know how Binswanger says that perception is inerrant.
Yeah.
That's basically the same idea.
Yeah, I agree with that. I agree with the incorrigibility of perception then. Yeah. Consider the statement O perceives E, where O stands for organism and E stands for environmental property. Under the ecological analysis, this statement proposes a law L, a property E of an ambient energy distribution. Example, light is lawfully related to E in that it is unique and specific to E in O's niche. Now given L, O perceives E designates a factual state of affairs. 1. E is present. 2. The P resulting from 1 and L is available to O, and 3. O detects and define and P is defined in 2. The incorrigible basis for an organism knowing about its environment lies in the satisfaction of L and the three conditions. The statement O perceives E picks out a property of the organism environment system emergent when L and the three conditions are fulfilled. The importance of calling it
He says this elsewhere, and he doesn't use the word emergent, so I wouldn't put too much into his use of that word there.
Okay. The importance of calling it a property is that property, as opposed to attribute or concept, is present or absent, existence or not existence, but not for true or false. Fair enough. Given the satisfaction of L and the three conditions, an organism in principle is directly aware of E. In the formulation dominating the 20th century, an organism is directly aware of something else, such as the states of its nervous system, or of an internal representation and only indirectly aware of the states of the world. The notion of perception as indirect goes with organism environment dualism. The notion of perception as direct goes with organism environment mutuality and reciprocity. Hmm. Okay.
Yeah, and I sent you again in VC text something else. Lecture 3, lectures on perception is really a must read on direct versus indirect perception. Understanding that, like he puts it so perfectly in that lecture, like in that chapter of the book.
Yeah.
He puts it so perfectly, honestly. But
Oh.
he also describes this later in the book. Like I think it's in lecture 22 or something. He talks about this like L and the 3 conditions. That's in other papers too. If you look in the organism environment system, no, I collected all the like references on that, like all the different stuff he's explained, like with regards to that, right? And a bunch of other
Yeah.
stuff, like similar stuff.
Great.
So really give that organism environment system a look, bro. Like and like talk to me about it later. You know, I think you'll find a lot of cool stuff in there.
All in a PDF.
I think I will.
You don't have the. I
Yeah.
don't know. Does he have the volume?
I think. Yeah. I do think like
You have
today
Obsidian,
was
right?
much. Yeah, I do.
Okay, so I can probably send you my vault. But that's from my vault, or you can just look in the PDF. But it's in my vault.
All right. So I think today was, like I would say, in my opinion, more things that I agree with and more things that I learned than yesterday, and like not yesterday, day before. There are some concepts that I'm iffy on, which I'll do my thinking on in my own time because like I do.
Yeah, and that's why, like,
Yeah.
man, yeah, I should send you my vault. But like that organism environment system note is a good resource because you can just control F in there. Like for any terms or concepts that are like you're iffy on, I promise, like I collected a bunch of stuff on that concept probably, to help you with that. But yeah, whenever you're thinking that, like control F in there for whatever concept you're iffy on, like, and you'll probably find some cool stuff in there.
Okay. All right. Anyway, I think that's where we should stop today. And the next reading, we're going to complete the paper. So,
And it's crazy because, like, if you saw before, like Sakura and me, we were trying to get a read along of this paper done, right?
Mhm.
Like, we ended up getting to this point, like in our first session, and like this past this point was like where I really wanted to like get in, like I had a lot more to say about a lot of the things and past this point because it's like really like this is the really like the heart of the
hyped for the
paper
next
is
one.
past this point.
Juicy stuff.
well, let's do that. Like the next read along, he gets
Yeah.
to say a lot more of what he wants to say.
Well, yeah, I'll still try to restrict myself, but I think you'll have a lot of questions either way.
All right. I will
Yeah, bro.
be. I think so. What we'll do it either
Do you have any
tomorrow or day
closing
after.
thoughts?
You know,
Yeah, that's
Uh,
fine.
and I will be doing my work on like I'm gonna finish the affordances lecture by the affordances podcast by Binswanger, and I'm going to read a little bit of like I'm going to listen to more of the audiobook that you were talking about. So
Yeah, it's in announcements, remember? But yeah,
Alright.
the beginning of that audiobook, like it's really like a good context of the setting things. Like a lot of the beginning stuff there is really great. But I don't think of like honestly, I don't think Binswanger really understands so much Gibson's like understanding of affordances too well. You know what I mean? So I don't know how much time you want to.
Yeah, like in that very video, he basically gives a similar point to what you were saying that even then we still need like some computation. It needs to be in the mind, right? He kind of says the same thing in one of those videos with Lee Pearson.
Yeah, and then Lee Pearson, who was actually a student of Gibson, who introduced Binswanger to a lot of the stuff from Gibson, right, is really against Binswanger on this. You know? He's like, Gibson would be rolling in his grave, bro. You know, like I could feel it, like when you see his discussions with Lee Pearson, he's like, man, Like I just like imagine like I think he's imagining what Gibson would say right now. Because he was his last graduate student, you know, Lee Pearson was Gibson's very last graduate student.
He would just scream, "You're all a bunch of rationalists," and then he would leave. Mises style.
Yeah.
Bro, you gotta do.
You wouldn't say it like that though. There's a lecture from Gibson. There's one lecture from Gibson on YouTube, and you can see how he talks. He's like he really reminds me of Rothbard. So I think he'll talk like imagine Rothbard, like how Rothbard talks. You know.
G's gotta do the same thing Lee Pearson did to Binswanger. He's gotta do the same thing to Zulu. Be like, no. That's not how it works. No.
It looks like I don't know. Fucking Zulu, you saw it. He was like I don't know. He's like you didn't post the video yet, right? So I don't know what he's like stalking us, bro. You know. Because he posted a screenshot of the paper that we're reading.
Maybe it's Luca. Maybe Luca was like, "Yo, bro, check this out."
Did you do that, Luca?
I mean, I did talk to him recently, and I told him that I'm doing like a read along.
Okay.
I mean, he might probably found this through that talk maybe, but it's not like I was doing a dissing thing. It's not a
No, yeah, that's fine. But you look at what he said. Look what he said in general chat.
Yeah, did you not see it?
Look,
I saw that, and in all honesty, that you can see how he gets that interpretation.
I don't know, bro.
No,
it
I
seems
don't
like
see it at all.
cherry picked. Like, look at all the stuff that we went over, bro. Like, if that's the thing he was able to cherry pick, like, and pick out, like, that's pretty, I don't know, telling.
Yeah, I guess, yeah, because it was talking about. Let me look at the image that he sent.
Like, I don't know, he's just mocking it superficially, not even thinking. Just like, oh, this sounds kind of funny. If I say it sounds kind of funny.
Yeah, that's basically it does. I do see where he's getting it from, and
I mean, yeah, if he actually read that part, like, he should be in agreement, bro. Like, if you're an objectivist, you should be against dualism. You should be against dualism.
Well, that's when he says that, oh, note the implicit primacy of consciousness and speaking of logical independence rather than physical. Isn't that just an appeal to dualism in itself?
Well, I think it's more so.
I realized that, but I wasn't gonna press him on that. I was just like, bro, like that's just what dualism is.
Yeah, because I mean, I'm assuming the logical independence there is more so referring to like the term dualism and organism environment.
Yeah,
like epistemological like terms. You know, it's like a methodological principle and stuff like that.
I think he's coming from the logical independence. It sounds somewhat like Hegelian Marxist language, right?
No, but that's just what a dualism is. Like it's like they posit some logical independence of some two distinct terms, and some incommensurability.
Yeah.
In all honesty, I can't say too much on this because I still don't know if I agree with that.
But if you look at the quote, it's just like they're just critically examining the dualist view. That's what they're doing. They're just saying like organism and environment are not logically independent, like the dualist claims. And I don't know why he's cherry picking that. You know what I mean?
You can ask him.
I did. I mean, I explained it to him, and he didn't respond to me. So.
Seems to me that what he would be saying is that they're physically dependent, but logically they are independent, and since they're saying it's not like I don't know. It seems to me that Zulu's own conception is pretty based on the dualism here.
No, I think what it's more about is that, like, why even talk about logics? I think it's something along those lines. Like, why are we talking
I
about
don't. I'm not
physical?
saying that to like insult Zulu or shit on Zulu, but I know like he said before, I can't remember where, but I know that he said, "Oh yeah, no, dualism is true. That's why we have, economic theory. The Austrian method is like
Oh
is
man, he
based
said
on a
that.
dualism."
Like that was more along the lines of like, uh, sure. Like you could. I don't even remember what that was, but from what I remember, it was, like why is there a methodological dualism in Austrian economics? It's because you cannot
Oh,
study, uh, you know,
yeah.
uh,
Oh,
like
it's a
human
protection
beings.
from the
Ow.
the positivist empiricist, right? It's like the
Mhm.
Yeah,
Austrians.
but I think it just grants them too much.
Yeah,
The positivists.
yeah.
It
Well, I mean,
grants them too
it
much
just
ground. It grants them the whole of
absolutely,
fucking
yeah.
physics. You know what I mean? Like,
Well, it gives it gives everything. Yeah, it's like,
yeah.
well, no, we can't actually observe
Like,
things
how
to
about
get
we approach
mechanisms. We have
human
to
action
deduce it.
and we use human action as the standard for, developing appropriate physics and mathematics for you? Wow, okay. Just saying. Let's do some science here.
Right, guys, it is my bedtime. Uh, I hope you guys enjoy the rest of.
And one thing on that, ecological psychology, right, has established research methods for studying human action, like goal-directed action, right?
Mhm.
Very solid empirical,
We need
like
ecological
methods.
Austrian economics.
And it's totally compatible with Austrian economics, right? So,
Yeah.
yeah, there's some integration to be done there. I mean, there's a lot of potential there for sure.
There's already, well, I know he's the.
Oh yeah,
I
there's
don't know,
Barry
read
Smith.
about Adam
Barry Smith. I
Barry
forgot.
Smith.
Oh
Yeah,
yeah,
Barry Smith.
talk to books.
He's
Talk to books about Barry Smith. He's been studying Barry Smith. He's an Austrian and he's an eco-psych bro. Very cool.
he's a minarchist though.
Okay.
That's
That's an
okay.
Austrian
I'll see
though.
you guys later. I'm gonna go to bed now, and
All
it
right,
was
see
a
you.
Yeah.
productive session. All right, bye
Yeah,
bye.
All right,
see you, bro.
let me know, bro, about next time or whatever.
Yeah, I think tomorrow or day after, depending upon when I'm free. I'll let you know.
All right,
All right, bye bye. See you.
you.
But yeah,
All
man.
right. What do you guys think?
I'm really enjoying the
I think
paper.
what Zulu said was funny as fuck.
Oh yeah, you want to talk about that?
Yeah,
I think Zulu is like under the impression that he like it basically doesn't.
I mean, I don't really
have
think
any.
I don't really think he like read it really.
Yeah,
He just like skimmed through it. Like, what's some funny thing here that I can mock without having to like look at
Yeah.
anything? Here? Like,
Basically, he believes
Yeah.
that
no, like
he's
somebody
like,
dumb.
he's a
Somebody
that
dumb is
philosopher
gonna
that
read it and
knows-
be like this is like only dumb people read this and be like, haha, yeah, Zulu. Zulu.
Primacy of consciousness.
You're so right, Zulu. Oh.
Like,
it's privacy of consciousness, bro.
like he was literally doing that, bro. He was like trying to find like the shit that like the dumbest like lowest common denominator is going to like rally with them over.
Well,
I don't know what
bro,
the fuck.
like I think like bro, this is like a thing I've noticed. I've noticed it with like divinity too. Is that like they take like you saying like the world has like some kind of meaning as like intrinsicism or something like that.
I mean, they're totally unaware of the impredicativity. That the divinity, like the whole divinity gang, Sue, Shane, all that, they think that like humans are of this intrinsic property of ethics, and they ascribe it to things, and that's how it becomes objective. Like they're just computationalists.
Yeah, and they just like totally don't understand anything about objective epistemology, the objective
That's
method.
That's why divinity
Yeah.
says that in some way objectivism is anti-realist. Like that's actual claim of him.
Yeah, bro, that's what rationalism does to a motherfucker, bro. And Peacock explains this. He fucking describes it perfectly. Like you're reading Understanding Objectivism, right? And Understanding Objectivism is just exactly what's going on with them, right?
Yeah. But, you know, I thought it was very funny.
What do you think, Eddie?
Eddie.
I'm at work, so I can't.
Oh, actually,
Not too much.
But I don't know. Do you think your suspicions are confirmed that he's like lurking in the server?
it's not. Maybe the explanation that Luca gave is plausible.
Right. Yeah. Yeah. Like maybe Luca letting him know, kind of like made him look into it just a little bit.
Well, I don't know if he looked into it really.
Like, give it a glance.
I think he just thinks that the findings of ecological psychology are useless to the legal aspect of anarcho-capitalism, and that's why he doesn't really concern himself with it, I feel.
Well, I mean, as G said,
sufficiently.
It gives us perception of entities.
I mean, yeah, as G already said, there's a lot that ecopsych can do for Austrianism and law and stuff like that.
Yeah, there is 100%, and it's like
That's really where the biggest
how you verify
route for integration. That's really where the biggest route for integration with
The
objectivism.
whole field.
Yeah, I mean, you don't even have to really ask, like, oh, what can it do? I mean, you just have to look at the situation right now. You know what I mean? It's like, oh, you have us, right? We're over here integrating shit, and then you have like Zulu, who's just like withering, like.
And look at him. He's just like, what is it? He's just like angry, you know?
He's just like seething, bro.
Did you, like who says this, bro? Who does this? Look at this shit, bro.
Yeah, it's especially if he does like want to focus on law, natural law, and ethics, like having an actually embodied
Notice how he
approach
didn't
to
respond.
ethics and meaning.
He hasn't. He's just like offline now. He just like hasn't talked at all since I fucking responded to him.
Yeah,
Yeah.
I noticed that too. He didn't say anything in response.
Who didn't, sorry? Talking about Zulus, or?
Yeah, Zulu never responded to what G was saying. Because, I mean, G was literally there being like, oh, so you disagree? Well, what do you have a disagreement over? Radio silence.
Oh man, is he avoiding it?
Go
Yeah,
from
like
Liquid Zulu in his server in general chat, bro. It's literally the last message in his server because he hasn't talked since.
Yeah, he hasn't talked
He hasn't said
since.
anything since. He's gonna wait until we're probably done VCing and stuff. And he's not gonna respond. Like I bet he's not gonna respond.
And it's also like like I know we have like, you know, like I know we do like, you know, say things here about him, but I don't think we ever really say like, oh, like we're enemies in this, right? It's never like that.
Not at all.
No,
But it's
it's
like-
been like this is just normal. Like we've been this is supposed to be like a community where we debate and stuff and like get to the better ideas. You know what I mean? Like it's been like that since way before the ecosec stuff. We just debate and figure out stuff. And talk
Yeah,
about.
which is I mean that's why I just don't understand why he's like
Have
I don't know bitter.
intellectual.
Like he's like
Stuff.
bitter
I don't know.
over
Well,
it.
he's become bitter about a lot of other things. I think not just I think it's just how his life is going. Probably. I don't want to psychoanalyze too much, but
I see.
I don't take it personally. That's for sure.
Well, I mean, yeah.
We-
Well, I should say when I said he was bitter, I meant like in the message itself, right? He seemed like very angry.
Yeah,
about
he's
it.
definitely he's definitely sounding bitter there. I mean, he does this, bro. Who does this? This is definitely some. It's bitter is the word to describe it.
Yeah, it's like I don't really understand why you gotta be angry. It's like we're not enemies
Girl
here.
lost the Dave Smith debate and never recovered.
Yeah, he never recovered after that. That's crazy, bro. Do you think he lost the Dave Smith debate? I don't know, bro. I don't know if I would call that a debate.
Nah, it was pretty dog shit all overall.
Well, I don't
Maybe
know. I
I'm
mean, I
cooking.
guess when you consider Dave Smith's like goals, like Zulu did kind of play like right into it. It's just like
And I tried to help him, bro. I tried to
it's
we were
just like
DMing about
it's like a
the
game of
strategy
rhetoric,
of what to do.
right?
We were
It's
DMing about the strategy of what to do, and I was trying to help him, bro. Like, he just didn't follow any of my tips, even though he said he was agreeing with the tips, bro. He just didn't follow any of
I do
them. They
remember
would have got him.
having a rant at the end of one of the streams about I think how you guys are talking playing some strategy or something. And
What? What did you say?
maybe it was not about you guys, but I remember some strategy where it was I think it was like the Haas debate or something like that. Zulu was basically it was like a 3 hours discussion on a single point or something like that. And then Zulu had a rant at the end that oh yeah this worked out super well and I didn't need the whole thing that
well, yeah.
other people talk about. That was about you guys, right?
Wait, I'm trying to listen
Yeah,
to
I mean,
I can't hear him while you're fucking talking. I can't hear anything. Repeat what you said, Ixie, before Stacker fucking open his mouth.
Okay. I remember watching this debate with Haz, and at the end of the VOD, Zulu is talking about how he didn't actually need what other people were telling him to debate about with Haz or something like that. Was that about you guys, about ecological psychology?
I don't know. I didn't talk to him about that as debate. Last time I talked to him about the debate about debating and all that stuff, it was the Dave Smith debate.
It's really hard to hear you, man. Sorry, it's
Sorry, the last time I talked to him about debating and all that stuff was the Dave Smith debate. I didn't talk to him about the House debate, so I don't know.
Then I don't. That's probably something else then.
yeah.
But I think Zulu just generally was getting hate about how he was debating and his style of debate lately.
From what I remember from the Hazal-Dean debate is that
he stopped. He's debating really.
Yeah, I mean, if you
went into an ontological debate, and Zulu's position wasn't really defensible at all. It was kind of I think he
I mean, yeah, if you go, because I had recorded the after conversation of the Hazal-Dean stuff, and Zulu was in there, and he was basically talking about his strategy for debate, and it's very rhetorically focused. It's very on the rhtorical side rather than
yeah, but he hasn't even been doing that though. He, if you look at his old debates, he was nailing it, bro, and now he's just I don't know, bro. He lost his game. I don't know how else to describe it, bro. I mean, I've described it in more detail, ideas about what I think that's happening. When we were reviewing those debates and stuff.
Well, yeah. I think the whole rhetorical strategy he did, like, I guess it kind of worked with Hazaldine, but when it came to like the Kantian and stuff like that, bro, it just like doesn't work because it's like I don't know. It's like stuff like that, strategies that are like very rhetorically focused rather than actually being knowledgeable on the topic.
But yeah, you're not talking about anything. You're just trying to. From
Yeah.
both of those topics, it's like trying to. Rhetoric. You're trying to appear as if you're winning, as if your adversary isn't answering question, but anyone that's actually knowledgeable about it, like when we watched the Kantian debate, we were all like, "Oh my god, the Kantian is just beating the fuck out of him." We actually understood what the topic was about. But I could see someone who doesn't really understand the problem of perception, seeing this and being like, "Oh, Zulu dominated," and it's like, dominated on what? Did you?
Well, yeah,
Are
because
you
it's like
aware of what was discussed?
yeah, because it's like you have somebody who's engaging in rhetoric, and then you have another guy who's like being, I mean, very scientific, even though the content's wrong. He is being very like scientific about it and
More than
stuff like
Zulu.
that, right? Yeah. Um.
We covered it all in our review.
Yeah.
That debate, really.
And that's kind of, I think, I mean, it goes with what you're always stressing the importance of epistemology, G, and that's kind of where, yeah, the more these our ideas are going to come into like these exchange and these conflicts, um, epistemology is going to be more and more important. And if Zulu doesn't keep up with it, he's not going to have much to offer, really, apart from surfing on what he already has. But that's not going to last, I don't think.
Yeah, it's not stuff like that. Like you can't. Oh,
Apparently, I'm the mom. Really, the
members are muting your server. You're getting a notification for every message. What?
I don't care. People can mute it. I don't give a shit.
Set default settings to mentions only? What? No, I don't give a shit.
I mute every server except for mentions.
I've never gotten that pop up. Did anyone else get that Discord
Me
pop up?
either. Yeah, I think that's because we're like
Members are muting
moderators.
your
We have
server.
access.
Yeah, people are muting the server, I guess. Okay. Who cares?
I already had the default as mentions only. Alright, I think I'm gonna go, bros. Unless you guys had anything else to talk about, maybe about cool stuff.
No, I have some work to do before the end of the day, so I was gonna go focus on that.
Yeah, me too.
Yeah, no, not currently. I don't think. I don't have anything to say.
Alright, see you guys.
Alright. See ya.
Roll some different smoke really quick. I just got inside. You know, I got a fucking medical card, bros.
Yeah.
I've been going to the dispensary, getting some dispensary. Okay. So how is how much time do you have, Luca?
I would say my goal is to finish the paper today. So,
Okay.
but I would say I have like close to like 1.5 to 2 hours to do it. After
good.
that, I'll have to move on. But I'm pretty sure we can get it done in 2 hours.
Alright. How you been, man? You've been busy
Yep.
with work and stuff.
Yeah. I can't hear you well.
Oh, sorry. Sorry. I said I know you've been busy with work and stuff. It seems. I asked like how you been.
Yeah. Like there is more work than I can tell you, but the good thing about that is that at the end of this month there will be a lot of money. So
Is it just like video editing stuff or like
yeah, there's scripting, video editing, that kind of stuff mostly.
is that what you went to school for, bro?
Nope. And I'm still in school, so like this is mostly
Oh,
like a side project.
I feel you. I feel you. I feel you.
Yeah. But it pays well, and what I went to school for, I probably will do very little of, which is electrical engineering. Probably do some sort of computer science stuff,
Okay.
but it's close enough. You know.
I'm still super anxious, bro. I'm like super anxious about starting classes in like just a couple of weeks.
Oh, you're gonna enjoy yourself. Don't worry. School's not too bad, and you're gonna make good friends.
I'm just rolling up right now. Sorry, I'm not like stalling or anything. You can start reading if you want to start reading. You know,
Yeah,
I
it's
don't
fine.
think it doesn't look like anybody's joining. It's pretty early, so
Okay, let's start reading then. Uh, okay, we're doing today physicalizing and intentionalizing information. Okay. Consider the possibility, already identified, that the emergence and extension of material systems exhibiting knowing about accords with a physical selection principle. Namely, those things, processes, etc., are selected that increase entropy production at the fastest rate. This consideration provides a glimpse of how it could be possible that cognition is intimately connected to principles of the most generic kind, and not merely a contingent feature of nature at the terrestrial scale. Material systems with the property of
And you
knowing
said
about.
you did learn a little bit, maybe not so much about Swenson's fourth law, but you did learn a little bit about global evolution, like the planetary system's role in like natural selection or like evolution as a whole. You know.
They're cutting out a lot.
Sorry, I'm trying to talk as close to my mic as possible. uh,
Uh,
but no, you did
mhm,
say that you did learn a little bit about like an evolutionary biology class or whatever
mhm,
about the global
yeah.
evolution stuff and like the planetary system's role in like selection, like in evolution. You know what I mean?
Niche. In effect, it's you know, like niche optimization, right? Each
Hmm.
organism optimizes its own niche.
Yeah, but it's like saying, it's like in just the base Darwinian view, right?
Yeah.
With just like uh I guess
Mhm,
it wouldn't be Darwinian, neo-Darwinian, right? But like where it's just it doesn't it really leaves like it begs the question of the the fecundity principle or like the striving of nature, right, to like to exist, right? The striving of living things for existence, right?
mhm,
Right, and it just like it kind of assumes that principle. It doesn't like entail it. You know what I mean?
mhm.
And that's right. That's like what uh that's a big part of motivating like Swenson's fourth law, like as a universal physical selection principle.
Mm.
Sort of like it's the. I mean, I don't want to get too into it. Just right off the
Yeah,
bat, you know.
sure, sure. That do interrupt me whenever you want to say something. Okay.
Yeah, I was just getting the context back because we were talking about the fourth law
Yeah.
last time. We didn't really talk too much about it, you know. And I wanted to refer to it again. This is what it's saying. The selection principle here is talking about the fourth law.
Hmm. Yeah. Hmm. This consideration provides a glimpse of how it could be possible. We did this. Uh, Material systems with the property of knowing about can interact in more diverse ways with their surroundings than material systems restricted to force-based interactions, extending thereby the opportunity for global system to degrade energy. Hmm. Let me see what
What do
I
you think
have
about
here.
that?
Yeah, sure. That is true. Like the thing is, I'll need to like properly think about this, but the central purpose being for this global system to do this, like I'll have to think about it. Like it's new to me.
Mm-hmm.
But
It's understandable. Yeah.
yeah, let me think about it. See if I spot any problems that I have with this or not. But it's certainly something that doesn't come intuitively from what I know. Okay.
I mean, what do you think it's intriguing? You know, like
Yeah, for sure, for sure,
it makes me want
for
to
sure.
learn more about this. Yeah.
Yes, and and I certainly have like, on my to-do list like knowing more about ecopsych. So like at least that mission is there. You know.
Okay, I'm going to my backyard to smoke. I'm bringing my computer, but hopefully it doesn't lag like crazy when I bring it. Here's hoping. You know, but if it does, I'll just come back inside. Yeah.
Okay. Mhm. Colloquially, one would say that the interactions between organisms and surrounding, typifying knowing about, are information based. Consider, for example, the dragonfly vis-a-vis thicket in Figure 11.3, which we saw above. In speaking this way, however, one seems to be using the term information in a very different sense from the mathematical formulation of information as the minimum equivalent number of binary steps by which a given representation may be selected from an ensemble of possible representations.
Yeah, Shannon
Mathematical theory of
information.
yeah, yeah. Mhm. Mm. Sure. This mathematical theory of information was developed to address the formally defined states of affairs of communication and representation, and not the physical states of affairs by which informed interactions might occur between an organism and its surroundings. It is a theory suited at best to the organismic capability of discriminating. Within the theory, information processes are viewed as selection processes that must be made from among a specified set of alternatives. And if the selections are to convey information, the set of choices must be known in advance.
I don't know if you were here when I mentioned that Shannon information is only a metric for distinguishing P from Q from an already fully specified set of, like an alphabet, right? But it's not a metric for specifying P or specifying Q, right? It relies on it already being fully specified. But Gibson information is that metric for specifying something, right? That's the
Mm.
key difference. And
Mm.
there's I can't send it now because I'm on my Chromebook. Sakura, maybe you can send the intelligence from first principles paper because that point is in there. So
Mhm.
just you can continue, Sakura. Just send that in the VC text
Right.
if you can
Okay.
find it.
Can you elaborate a little bit more about what Gibson information is and what it does?
Well, they're about to get into that, really. So
Okay, okay, fair enough. Read the paper.
yeah,
We were here. Within the theory, information processes are viewed as selection processes that must be made from a specified set of alternatives. And if the selections are to convey information, the set of choices must be known in advance. But discrimination among members of a set presupposes that the members are perceptible, meaning that the capacity to discriminate is derivative and, by itself, a poor basis for knowing about. Hmm. Furthermore,
yeah,
poor
it's talking
knowledge of
about
the
the point I was just making, but it's also made in intelligence from first principles. That paper, like it's a newer
Mhm.
paper, and they make it much more like they make it a bit differently. They make the point a bit more precise uh, about Shannon information versus like what kind of information we actually need.
Mhm. Yeah. Furthermore, poor knowledge of the environmental entities to be encountered is incompatible with the intuitive understanding that information detection should be the basis for adjusting behavior to novel circumstances. Organism environment interactions require information in the sense that information about something, information specific to something, that is, information of a kind that permits the perception of something rather than the discriminating among things. 19 all those papers. Even more poignantly, the actions by which knowing about is expressed.
Basically, it's not the information that it's saying that we need is not only selective but also specifying, right? Both, just like it both is able to distinguish and specify, right? Not just it's
Mhm.
not just selective. Like Shannon information is just selective but not specificational, right? But Gibson information is specificational and selective.
Mhm. Okay. Even more poignantly, the actions by which knowing about is expressed require that information about environmental facts be referential to the energy for behaving with respect to those facts. Mm, mm. Okay. For the dragonfly of figure 11.13, 11 aiming itself at prey at a prey. To see the distance to contact is to see the work required. To see the time to contact is to see the impulse forces required. To see the direction to contact is to see the torques required. Mhm. In sum, the response in 21st century to the challenge of knowing about, a challenge expressed quite substantially by our dragonfly, will require a theory of information that takes information to be physical, that is, a law-based property of real states of affairs, as opposed to simply a logical or mathematical attribution. I would agree with that. Pursuit of the theory will consist in significant part in the empirical determination of properties of ambient energy distributions mhm, that are specific to behaviorally relevant properties of organism environment systems. A lot of mathematics and physics will be needed in this enterprise, and much of it will have to be developed. Yeah. Importantly, in keeping with the argument that systems express knowing about are more general in respect to their principles that underlie them than the systems accommodated by contemporary physics, it will have to assume that the intuitive idea of
Think
information.
for a second just how radical this is for an approach to psychology, right?
Mhm. Yeah. Mm. Yeah. Mm. It will have to assume that the intuitive idea of information, in its most fundamental form, can be captured only in organism environment systems. Mm. Mm. Yeah, I'm starting to understand what it means more and more. And I think the way I was reading this before, this is a complicated and hard paper, of course. So, one could forgive misinterpretations, but I don't know if I'm interpreting it right now correctly or not, but right now it seems to make more sense to me.
Yeah, one thing I
Mhm.
want to say, right? Like what I like to say when people ask me, like, to give like a statement, like what the ecological approach is, right? I like to say it's just, we're trying to develop the right physics and mathematics appropriate to the facts of psychology, right? Rather than treating
Mhm.
them as like unreal or illusory, right? Belying some fundamental reality, so-called fundamental true reality, where life and mind and the facts of psychology can't even exist, right? They're just non-existent. You can't find them there, right? But, it's like this paper, right, is so key because it's like like a diamond in the rough, bro. Really, like you when you look throughout the literature, like even in ecological psychology, people often forget, right?
that
Mhm.
statement that I just gave. Like that's the aim here, right? You get what I'm
Yeah.
saying? And this paper
Yeah.
really is the paper that emphasizes that and has pushed research in that direction more than anything else, really. This paper.
Mhm. Right.
And Turvey as a person, really, in developing, an environment for research, right?
Mhm. Yeah. The development of the requisite understanding will be founded on the answers to questions such as what kinds of energy magnitudes and energy forms are involved, what kind of structures carry or contain information, what are the physical conditions for generating information, this is the thermodynamic, what is the thermodynamic cost of detecting it, how is information connected to dynamics, how is information respectable, that is, scaled to the systems that
Yeah.
use it.
What we need is a
This,
conception of information in the reach of dynamics, right?
yeah.
And
Mhm.
Shannon information is not that because it's purely formal. You know what I mean?
Yeah. Yeah, that, yeah, it makes sense to me. Yeah. Like, of course, like, it doesn't completely, I don't completely understand the either the problem or the solution, but I can see where this is going, and I certainly agree with the direction of its growth in the sense that uh, Shannon information does tell you something, but it's incomplete because it's not physical. It's not connected to how
Yeah.
organisms actually
And
are and how they
there's
act.
actually arguments about why Gibson, Shannon information is actually parasitic on Gibson information, specificational information, right? Like it actually relies on it, Gibson information,
For
it's
sure.
dependent on Gibson information,
I,
you know?
I would use the term determined more than parasitic, unless and until the term parasitic is more appropriate. Uh,
Yeah.
you know, but certainly I can see that before we can do any Shannon operations, we'd need the information from somewhere, and the way where's
Right.
the information coming from? It's coming from these organisms, right?
Yeah, it's not coming from a larger field of Shannon information, you know?
Yeah, exactly. Yeah, I can easily see that argument, and I agree with it. Let us see. Yeah,
But
how
yeah,
is information perceived?
these questions,
Mhm.
maybe slow down and absorb these questions, right? The importance of these questions.
Yeah.
These are really in the context of psychology, these are radical questions. Yeah.
Mhm. Yeah. 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 That makes sense. Makes sense. Hmm. Also, like, this kind of clarifies another uh, you know issue that I was having, which was I was not I was getting confused in the uses of the word special and general
Hmm.
before, and it felt like uh, you know uh, that the paper was saying that the physics you get from these organisms is the real physics, and all the other stuff is like bullshit. But I think what they're trying to say actually is that it's a more complicated system, so you would need you know you'd need more
But
detailed physics.
I would be careful about that. It's not just more complicated, right? It's like Rosen makes the distinction between complicatedness and complexity, right? And you know, there's no like you can't just in a purely in pure syntax, right? You just can't by rote iteration, plus one plus one plus one, you'll never get to semantics, right? You'll never get out of the formalism. You know what I mean? And it's how he understands it. There's modes of entailment, right? Complexity involves modes of entailment that simplicity, simple systems, like Newtonian mechanics expresses, right? Just cannot it's out of the reach of their entailment. You know what I mean?
I don't know if that is the way I'll approach it, but I can
It's a bit
see.
like there's no threshold, right? Where you just like you just increase like like more detailed, simple atomisms like of the like
Yeah,
the
yeah.
structureless
I
particles.
do agree
You
that
know,
one scale is not fundamentally more real than the other scale. Like that, to that point, I agree.
yeah, it's a much deeper argument, right? I'm just like
Yeah.
I want to be clear about that. It's like qualitatively
Mhm.
different.
Okay.
You know what I mean?
Fair
Not
enough.
just
Fair
more
enough.
complicated. You know what I mean?
Yeah, yeah. Fair enough. Uh, so it's not just a difference in degree of complexity. It's some sort of a principle difference.
Yeah. Like I would just recommend reading Rosen on like his understanding
Okay.
of complexity. Rosenian complexity, you'll see is like a very key point. Like in the intelligence from first principles paper, like that's one of the guidelines is Rosenian complexity.
Yep.
But it's very
And,
important for Turvey's program.
yep. I've written that down. We'll get that done as well. Okay, let's go
I
further.
mean, we can talk about it later, and like I can point you to like resources we could talk further about it. Just like I don't want to
Yeah,
bog us down here, you know?
I understand as well. Like every line could be a 2 hour conversation, and we need to finish papers.
Yeah.
Yeah. Okay. What kinds of energy magnitudes and energy forms are involved? That's the first question. Oddly enough, this question is closely linked to the question of what makes a system complex. So we have complexity here. There are a number of
Right.
ways. Hmm. Okay, like I understand why this question is linked to this question. I can understand that. The more
Yes.
complexity, the more magnitudes and forms it would require.
Mm.
Yeah. There are a number of ways of addressing this complexity question in present day science. But for the most basic and at the same time most relevant for our present purposes, focuses on the degree to which the flows of energy from the interior to the exterior of a system can be time delayed. Okay.
Yeah,
Mm.
this stuff, all this stuff here is also explained further in Intelligence from First Principles and also elsewhere in Turvey's work.
Most focus on the degree to which the flows of energy from. Okay, yeah, it makes sense. The more complicated a system, the more time it would take from energy to flow from its interior to its exterior. That makes sense
And
as
it
well.
could control like the pathway, like the throughput of that energy, like how it flows through it. You
Yeah,
know?
makes sense. Like a simpler system would just have a more direct flow of energy, right?
Yeah. This in particular comes from homeokinetics, which
Hmm.
was founded by Iberol. Uh, you see Iberol being cited there, and you'll see homeokinetics being mentioned in a lot of other Turvey's work. Iberol, like he's a physics guy, you know. He started homeokinetics, and you can do like just a Google search on homeokinetics if you want to know what that is. Like there's a wiki page and everything. But basically, like the Iberol later like through Turvey and like their like appreciation of his work, he actually got into like he wrote a few papers for the ecopsych journals and stuff. You know what I mean? Like he got into ecopsych later on. That's happened a few times with a lot of
In
physicist
all
people.
honesty, uh, one thing that I would say is that like to properly understand ecopsych and perhaps you know that is true for all fields. Like I'll need a lot of time and effort. Like
Yeah,
I understand half of this at this point, which is I guess good because I do understand half of this. But like for a detailed understanding and for me to actually have a good and informed opinion about this, because right now I am uh
I like to keep in mind the spiral theory of knowledge. Right? You can.
yeah,
It's great to like I think it's really like people are afraid to like get into something, right? Like what we're doing here, they're afraid to get into it, right?
yeah,
Read any of it or start like because they think like they're joining in on like lecture 97 and like it's like so much that they have to catch up with, right? But it's
yeah,
really like just come in, bro. Don't be afraid and like just absorb what's being said and then just like let it be. Don't like stress on it, right? And you'll just because you've absorbed that like at the base, you know, just even if it's vague at first, you don't really understand it too much at first. Later on, right? You're learning more things, right? And then you're able to spiral back to it, right? And get it look at it with a larger context, with a richer context and like
That is something
better
which is,
understanding about it.
like that is a novel approach to knowledge that I have not thought of before. But and I can see how it connects to the spiral theory.
An
Uh,
objectivist thing. The
yeah,
spiral theory of
yeah, for sure. I can see how it connects, and I can see that that is a very empowering view, because that, one could just jump in, and that's such a great view.
yeah,
Uh,
Sakura link like you got the timestamp for where I was talking about that the other day, right? Do you want to link that in the VC text? Because I was in
Yeah.
we had a whole recording about how like my whole approach to like reading stuff. 'Cause
Yeah.
I've been like getting like I've been reading through things like lightning fast, really. Like I just like I understand a topic that I want to learn about, and I'm just like I got to learn everything about it, and I just like I give my whole like strategy there how I do that, you know, and it's
Yeah.
like that's part of it, right? I don't read books in like a linear like order at all, you know. I just like jump in and like where look for what I'm looking for, you know what I mean? And then I just like branch out from there, you know what I mean?
Yeah. That I wonder if that is. I can see that approach is, the merit of it is that you get what you want much faster without waiting
Yeah.
through so
And
much
I
of.
found it really successful. I found it to be really like
Yeah.
successful, like or like productive, you know, and like efficient. You know, I've learned a lot this way, like you know,
Fair enough. Fair enough. Yeah.
yeah. But I recommend watching that if you're interested in that. Like Sakura could link it in VC text.
Okay. Okay. The ability to delay external to internal to external to so on and so forth energy flows affects dramatically a system's mode of interaction with its surroundings. The system's enslavement to the external force field is weakened.
Oh, also I should note, right? All of this stuff, you know,
Yeah.
like it's like they say a lot of these things that they say also in a lot of other papers, right? But like with a little bit more context here, a little bit more different details here. You know what I mean? So like I sent you my vault the other day, right? Or I sent you the
Yeah.
organism environment system note. So
Yeah.
you can control F in there, or elsewhere in my vault, you can do the Omni search, and you can search for these things, like what they're talking about right now, like the time delay stuff and all, like of energy flows and all that. And what I did is I collected all of all the text like you know from all the places that they talk about it and like with all the different details, and I put it all together like close to each other, right? So it's a good resource, you know, for that.
Mhm. That makes sense.
Right.
Ability to delay external so forth. The time decaying of energy flows provide a local, internally based source of forces that can compete actively with the external forces. Hmm. Sure. Sure. A dragonfly
That's
can.
that's just a base description of it. Like they literally wrote a whole book on this, Kugler and Turvey.
Yeah.
They literally wrote a whole book on this, going deep into like the detail of it, like the physics of it. You know what I mean?
Hmm. Yep. A dragonfly can fly against gravity and into a breeze. As system complexity magnifies, that is, the internal forces become increasingly less dominated by force. Then there's the MLT dimensions of force, which for anybody not initiated means mass, length, and time. So you can say that, F
Right.
equals ma. So A is L by, acceleration is, meters per second squared. So this is how you can figure out these dimensions. So F equals ma. Therefore, F equals to capital M to the power 1, which is
Mm-hmm.
mass, length to the power 1, which is meters, length, and the per second square, that is divided by s to the power 2, i.e. t to the power minus 2.
Yeah, I think you'll definitely like Kugler and Turvey's book. You see it's cited there, Kugler and Turvey, 1987.
Yeah.
I think you'll definitely like, because you'll understand it. I had to do a lot of research to even understand like the basic stuff that it was talking about.
Yeah, and these are really helpful things to like. Dimensional analysis helps you out in physics in pretty
Oh
neat
yeah,
way. Yeah,
and it's a big thing in ecosec dimensional analysis.
fair enough. That's good. That is good. Momentum,
Like
which
specifically in
is
ecological
MV.
physics, which like subsumes like ecological optics, ecological chemistry, ecological acoustics, that kind of stuff. All right.
Because what you can do actually is like very neat things. Like you can look at a like complicated equation. You can isolate its dimensions, and then through those
Mhm.
dimensions, you can identify these physical facts. And
Right.
that's a pretty neat thing. For example, if you can isolate mlt to the power minus 1 somewhere, that is momentum, that is mv. If you can isolate this, that's kinetic energy. That's the formula of kinetic energy, half mv square in a lot of places. So that you can isolate a lot of things, the physical meaning of a lot of terms in equations through dimensional analysis.
Yeah, and but the units they're using here, the meters they use here is they talk about it in terms of body scaled and action scaled units, right?
Sure.
Or
Mhm. Yeah, yeah, fair enough. Uh, mm.
and there's a lot
That
that
is the
goes
big,
into it.
yeah,
But it's very cool. I want you to think about that, like how we do dimensional analysis, but like talking about affordances, right? And like activity, right? Perception action, right?
that is the basis for the interactions will become increasingly less dependent on observables defined through the mass m dimension, and increasingly more dependent on observables defined solely through the dimensions of length and time. These observables are geometric, fashioned from L, spectral, fashioned from T, and kinematic, fashioned from both. That makes sense? Hmm. So when we're talking about observables, we're talking about okay, fair enough, fair enough. Consider that living things are immersed in energy distributions. A dragonfly, for example, is immersed in light. The force impressed upon them by these enveloping distributions are low relative to the forces that we can well up from the interior of organisms. For example, the forces of enveloping optical distributions or enveloping distributions of volatile materials with respect to the forces generated by a flying insect or a running mammal. It is these low energy distributions that connect the dragonfly to the thicket's behavioral opportunities or affordances. These are the basis for force-free epistemic contact to to be contrasted with the forceful non-epistemic contact characteristic of the systems that surround studied in classical mechanics.
Oh, yo, Eddie's here. Nice.
You
Yeah,
Okay.
I don't know if you were here. Do you remember the Lee room example, the moving room?
Yeah.
Yeah, about the forceless information link, information movement coupling of posture. With the Lee room with the surrounding surface layer.
I'm having trouble hearing you, and I don't think I remember that. Could you tell me it again?
Yeah, okay, because I explained it yesterday. I explained the how you don't remember the Lee room, the moving room example.
No, I don't think I was there yesterday.
You
But
might have. Yeah, that might have been Aurelius. You explained that too. I can't remember.
Yeah, should I explain it now?
Go for it.
What do you
the
think? Lito?
videos in general, Chan.
go ahead, go ahead.
Should just play the video.
Yeah, so
like, okay, I can start with the posture. So like, if you try and stand perfectly still, like just like stand up, you can try and stand perfectly still as hard as you can, and it's like you'll notice that you actually end up like losing your balance, like you end up like falling a bit, and like you have to catch yourself. You know what I mean? It's
Yeah.
because your postural like stability, right, is actually like a function of like the variation of like your posture, like the postural sway, right? You know what I mean? It needs all those micro variations in order to keep you upright, right?
Mhm.
And
Okay.
so, like, and it's not like a trivial thing, you know, like standing upright. We think it's like a trivial thing, really, but like it's like we're always exerting like forces and like energy to like keep us upright. You know what I mean?
Yeah. Yeah.
Like we're always doing work, right?
Yeah.
And the way we control that, right? Well, like learning to walk, like is this process of uh sort of establishing this information movement link, this coupling, like we're hooking our activity, right,
Mhm.
onto the information, right?
Yeah.
And what we're saying is basically that the surrounding surface layout, right, is the support, right? It's what supports postural stability, and it's like um, you're just like constantly like your postural sway, like your postural control, right? It's just constantly linked to the surrounding surfaces, right?
Mhm.
And so what the Lee room, the moving room shows, you know, if you've watched the virtual insanity video, right? The floor moves, right? But like, well, it looks like the floor moves, but really the wall is moving, right? It's just that the wall is hanging and it's like flush with the floor, but it's not like connected to the floor. You know what I mean?
Mhm.
So
Yeah.
it's like from some rope or moving it, right?
Mhm.
And you can do these experiments with like a moving room, kind of set up like this, right? And basically, like even it's like it's unnoticeable, right? That we can like we can move the room like forward a little bit, or like in whatever direction, and we can like measure that like you know your the back of your like ankles or whatever, right? You're leaning yourself forward proportionally to the move, like we're moving the walls forward, right? And you don't even notice it, right?
Mhm. Yeah.
Right? And we can also like if we move it really fast, right? We do a sudden like disruption, right? It like makes you fall forward, you know, you like totally just fall, you know?
Yeah.
And so it's like there's no momentum exchange from the wall to my body, right? There's no uh forces being imposed from the body onto me. Like it's not pushing me. I'm from the walls onto my body, right? It's not pushing me,
Mhm.
right?
Yeah.
Not touching me. You know what I'm saying?
Yeah. Like the body is calibrating according to the environment, and therefore, because it looks as if the room is moving, the body expects to balance according to the movement. But because there is no movement in
Yeah,
that,
and it does that by coordinating with the information specific to that,
yeah,
right? To those
yeah,
state of affairs, right?
yeah,
Well, that's
that
the
makes sense.
hypothesis.
That makes sense. Uh, So let's move on to the second question that we have to address, which is what kind of structures carry or contain information? The descriptions in the optical case, for example, are the spatio-temporal structure, that is the adjacent and successive order that is imposed on the ambient optical distributions by the layout of environmental surfaces, attached and detached objects, places, one's body, movements of one's body, surface displacements, deformations, collisions, etc. An ecological conception of information is found on the assertion that invariant relations exist between layout properties of general significance to the governing of where did we go? Activity affordances. Whoa, wait a second. Yeah. Activity affordances and macroscopic non-inertial properties of substructured ambient optical, mechanical, chemical energy distributions. The latter, therefore, can specify the former. In the case of a dragonfly, flight consists of transformations of different intensities, spectral contrasts, and specular highlights in different directions. The mathematics and physics of fields are necessary to reveal, for example, the optical properties lawfully generated by gaps that are passed throughable and by edible objects that are
They're
interceptable.
lawfully generated by.
Yeah. Go ahead.
Oh, sorry.
The key. They're lawfully generated by the surfaces of the layout, right? So like the information that's detected, that's picked up, that's differentiated, right? That's used to control action, right? It's it does not need to copy or even resemble or like be a representation of what it's specific to. Right? It just needs to be specific to, right? What it's information of, what it's informative of. It just needs to be specific to it, right? So if Y is specific to X, then to detect Y is to perceive X, right? Then they need like Y need not be a copy of X, right?
Yeah, fair enough. Okay. The distinction between information and about something and the distinction between information about something and the something in question deserves emphasis.
Oh wow, it's going right into what I just said.
Yeah. Fields of diffusing volatile materials fill the air and are ambient to each and every animal. The sources of these odors are the other animals and their products, plants and their products, and a few types of inorganic things. For the most part, the minerals of the earth, the air, and water are odorless. The information carried by a diffusion field specifies its source, but is not chemically identical with its source. Thus, the body odor of an individual animal is specific to its body, but does not have the same chemical composition. Behind the explication of the information carried by fields of diffusing volatile materials is an ecological chemistry. The chemistry expresses the fact that some vapors, and in the case of tasting some solutions, are informative about their sources without being chemically identical with them.
And that's gonna be my main research goal. I mean, just like there's not a lot of research on ecological chemistry,
Yeah.
but that's what I want to do mostly. Like, is well, at first is I don't know, try to research ecological chemistry. Like
Excellent. Mhm.
I think it's a really cool idea.
Yeah, that makes sense. Analogy, analogous tasks confronted ecological optics, Gibson, ecological acoustics, ecological mechanics, and so on. Hmm. Also deserving of emphasis is the distinction between available information and detected information. Energy distributions ambient to a point of observation are structured in ways specific to the surface layout surroundings, the point of observation, and to the point of observation's point relative to those surroundings. They provide, therefore, opportunities for being informed, or essentially, for planning and controlling goal-directed behavior. These opportunities exist because of the invariant relations between the properties of the surround and observation point and the properties of the structured ambient energy distributions. These opportunities are not dependent on living things. They are simply available as a consequence of the lawful regularities at the ecological scale.
These invariant relations, by the way, are what we call ecological laws, right? And they're embodied in information, right? But a good example of an ecological law, right, is to move forward, right, make the ambient optic array flow, right?
Yeah.
Right, just make the light, the optical texture elements, right, make it flow, like if you're like looking here,
Mhm. Yeah.
like if we're representing this, like, right. there's a point of infinity ahead of you, right? And
Yeah.
imagine like arrows, all like extending outward, like vectors, right?
Yeah.
Extending outwards from that point of infinity, right? And as you move forward, those arrows get generated, right, and move and moving past you, right? They
Yeah.
flow outward, right?
Mhm.
That's like the basic representation of optic flow, right? There's a lot of stuff on optic flow,
Yeah.
but yeah,
And
basically,
that's what one perceives when they are moving, right?
yeah, and it's like basically like it's you see it's an invariant like link between these like between self motion, right, uh relative to the surroundings, right, relative to the surface layout, and and optic flow, right.
Yeah. Okay.
And so even if like even if no observer occupied, right, those that path of observation, right, even if it was just a rock, right, it would still be specific, right, to what the rock would need to do to move forward, right? That's like a crazy thing. It would like still be specific to what the rock would need to do to move forward, but the rock just doesn't need to detect that, right?
Mm. Yep. Right.
Yeah.
Mm. They provide, therefore, opportunities for being informed, or essentially, for planning and controlling goal-directed behavior. These opportunities exist because of the invariant relations. Where were we? Let me just read from here. These
Sorry, is my
opportunities.
mic lagging bad?
No, you're
No,
good. You're good.
it's
Okay.
fine.
These opportunities exist because of the invariant relations between the properties of the surround and observation point and the properties of the structured ambient energy distributions. These opportunities are not dependent on living things. They are simply available as a consequence of the lawful regularities at the ecological scale. It is, however, to be understood that laws of information, like laws of mechanics, electromagnetism, thermodynamics, are necessarily involved in the makeup of living things. The meters, perceptual systems, and actuators, muscles, energies of organisms can no more lie outside these information laws than the metabolic, respiratory, circulatory, hormonal, etc. Processes can lie outside the mechanical, electromagnetic, and thermodynamic laws. Fair enough.
All right, we've already been through two sections. All right, remember what these sections are for, just to like
Yeah.
to absorb it. Right, it's like we're looking like if you look right before the section started, right, the first section. If you scroll up just a second.
Yeah.
To before the first, yeah, there we go. Right there, yeah. It's like let us see what directions the answers to some of these questions are likely to take, right?
Yeah.
So remember this is in 1995, but like the first section, I don't know if you want to say it, like this is your reading, right? Like I don't know if you want to say like, oh, like I get the direction, like
Yeah.
it's satisfying what it said it was going to satisfy, right?
It
In that
is.
section,
It is.
you know what I mean?
Yeah. There is payoff to these questions in these sections right here. So it's answers to these questions.
Yeah, I was just asking if you wanted to like say like what you like think you're getting like for the question of the section, you know what I mean, from what you read in that section, like oh yeah, I see like the direction, you know what I mean?
Mhm. I do. I certainly do. Um, because we are like, each section does like satisfactorily answer its particular question. So so far I have no like I don't have any problems so far. In all honesty, that's
Yeah,
all.
I know. I'm not. I'm saying that you don't need a like. You don't need a problem to say something. I'm saying you
Yeah.
could talk particularly like, oh yeah, like for integration purposes for the viewers. You know what I mean? Like,
Yeah.
I like I've just read these paragraphs of this section. Like now, let me look back at like what the question was asking. Like, seeing like how did they answer it? Right.
Yeah.
That's good for integration, is what I'm saying. You know.
Yeah. Yeah, that makes sense. We
But
can do that.
yeah,
We can certainly do that because
yeah, I'm asking you if you want to do that.
Hmm. Yes, because here like they do address it like from complexity. Like the more complex a living organisms, the more length and time dimensions increase and so on and so forth. Like we're talking about like you know uh, certainly like that's I would say the crux of what I'm getting from this section right now. What
But
kind of
also, like what I said, right? It's talking about a new kind of basically a new whole range of like interactions, informational interactions with the mass dimension suppressed, right? And like how
yeah
it's talking about there's a qualitative difference here, right?
hmm
And
yeah
that's what it was getting at with the complexity discussion and the time delay stuff, and then the suppression of the mass dimension, right? And why that's connected to complexity, right?
hmm yeah
Yeah, I mean, I just want to, I don't want to like sort of forget what insights
yeah
we're getting from you. You know what I mean? And just like read past it, and then just
yeah
immediately forget.
I understand that. And like of course like that is it's good to stop and reflect. So here as well, like what kind of structures carry or contain information. Like we have, you know, uh, first of all, like we have like various amounts of like one example here can be like the body odor example, right? Like it's a sort of like chemical composition which identifies an individual animal, right? And so that is then that's also going to be certain sound, so that's going to be acoustics and so forth. So like these are certain physical facts that are carrying information about an individual animal. So uh, that is something that I would say I'm taking from here. And Mhm. and of course like uh, the physical facts of the world, the facts of mechanics, electromagnetism, and thermodynamics, they are needed and they are presumed in the development of like a proper
Right,
organism.
and that's extremely radical for psychology. I mean, the whole cognitivist school relies on the disembodied cognition assumption, right? That we can just ignore all of that. We can ignore thermodynamics. We can ignore physics. We can ignore what the brain dynamics are even doing, right?
Mhm.
And we could just pick up cognition and just like study it like just like independent of all that stuff. You know what I mean?
Yeah. Mm. But, I do agree. Like I am getting like a picture of what exactly the project is from answers to these questions, and I'm liking it so.
Okay, I just want to keep that in mind as we move forward. Maybe make that
Yeah.
more explicit what you're thinking. No problem, right?
Yeah. Yeah. Controlled. Fair enough. Given an onboard source of energy, chemical energy carried in muscles, what are the constraints on its deployment to bring about directed movements? Perception by the dragonfly on the direction to contact with the mosquito is rendered as the application of a specific torque to bring about the coincidence of axes of dragonfly and prey in a three-dimensional space. Patently, to generate this specific torque, the dragonfly must allocate a specific amount of its energy resources. At first blush, information about direction to contact and its energy for torque to contact seem to be two very different and unrelated things. If they are indeed so very different, then it is difficult to comprehend how the dragonfly or any other creature such as ourselves can begin can routinely interconvert them. The daily challenge of directed actions would be analogous to attempting to convert one currency into another, Deutschmarks for dollars, routinely and reliably in the absence of an exchange rate. It made me think about this. Uh,
I don't know if you can catch it yet, but it's
yeah.
like they're setting up that like I don't know if you can catch it, but it's like we're setting up sort of. It should sound like we're looking for something like a conservation principle, right?
Yeah, yeah, for sure. Like because we're looking for, how how does the dragonfly know this conversion rate? How much energy, how much
Hmm.
chemical energy should it expend to
Right.
create muscular, tension in whatever like muscles or equivalent parts it has, to then generate upward force, which is like torque, right? Like because it's yeah, exactly. So generate torque, which will then generate an upward force from the ground, which will allow it to move through the opening in the thicket. You know, all of those, all of those decisions need to be taken into account and how it does this.
Yeah, bro.
Yeah.
Yeah, you're definitely grasping it.
Yeah. Daily challenges of directed actions, of course, yeah, convert one currency in another in the absence of an exchange rate. Information and energy are independent and without a common basis, then the conversion must be arbitrary and the fitting of actions to surroundings a matter of happenstance. In our view, a strong version of organism environment mutuality implies that information and energy are locally dependent and relate in the double dual manner expressed above. That is, this is a profoundly important hypothesis about the two focal topics of the past and present centuries. When properly understood, information and energy are reciprocal aspects of nature. This reciprocity is neither required nor revealed by a physics that considers natural systems that exhibit the quality of knowing about a special systems. The reciprocity is brought to the forefront only when systems exhibiting knowing about are understood as more general in respect to the principles that underlie them in the material systems currently addressed by physics. That there may be a common and intrinsically defined energy dissipation principle underpinning animal activity is suggested by the following remarkable fact. First of all, like we should slow down and
Yeah.
absorb this.
To be clear, information here is more like topological form. It's just the structure of energy rather than energy as such, right? How energy is structured by the surroundings. I don't know if you were here when we were talking about like the Gansfield effect, right? Where like if you can put these glasses on, these goggles on that diffuse light, right? So you just have a completely homogeneous simulation, right? And your eyes are being bathed in light, right? And whatever the color of the light is, you don't see whatever the color is or anything. You don't see black. You just see nothing, right? You start seeing nothing because there's no information, right? There's no structure, right? And it's the same phenomena you see in like snow blindness, right? And it's like it's not energy as such is not what's important, right? Like your eyes are being bathed in simulation, right? But what's important is the structure of the energy, right?
I'm gonna be back in just 1 second. I think a delivery arrived for me. I'm gonna go pick it up and be right back.
All right.
It will take less than a minute.
Mm-hmm.
Oh man.
Yeah, you guys got to talk more, bro. Eddie, bro.
Let's just say over there. A lot of things on my mind, so I'm gonna just brain dead. No, I'm just.
I
Mr.
mean, Sakura, we
Cameraman.
talked about Sakura. Come on, we talked about this stuff before. You know what I mean? The stuff like about describing right the patterned energy distributions ambient to an organism, right? Uh like in geometric, spectral, and kinematic terms, right?
Yeah.
Like in body scaled units, action scaled units, like all that stuff.
Yeah.
You remember we talked all about that.
Yeah, we have a whole prompt about it.
Huh?
We have a whole prompt about it too.
Yeah. Like, are you making any connections to what we said before?
I can't really say it's not anything I
Back.
just
I am back. Let's go.
yeah, like I don't know. I
Uh,
can't say it's nothing I haven't heard already that I've never heard.
Yeah, it's a little hard here because Luca's the only one who hasn't heard a lot of this stuff before.
yeah. Well, I will certainly hear more about it. When I read and listen to the audiobook.
Yeah, no, I'm just saying why like Sakura and Eddie are having a hard time like like finding out what to say because like they like or it's like nothing like new to them. You know what I mean?
Understand that. I would like anything they would want to say, they can say. Like, but
Yeah, that's what I'm trying to tell
yeah,
them.
yeah.
They're camera shy or
Let's
something.
see.
I don't know.
Yeah, that's fine. That's fine. I have no problem with that. Let's see. When properly understood, information and energy are reciprocal aspects of nature. So the information, let's try to understand this reciprocity. So the information in the environment determines the energy required to, act in that environment by the organism.
Right.
But what's the reciprocity? What connects it back?
Well, we're getting into that actually. I think we're gonna get
Okay.
really like you're gonna see it.
Okay.
I don't
So
want to
like, let me
spoil it.
just continue then. Yeah. And there
You see,
may be a
we're
common
getting into that.
that there may be a common and intrinsically defined energy dissipation principle underpinning animal activity is suggested by the following remarkable fact. Locomoting animals exhibit an independence of energy cost and speed such that the amount of energy used to run a given distance, say 10 meters, is nearly the same whether it is run at top speed or at leisurely pace.
What
Mass
it was
specific,
saying, by the way, remember if you remember,
yeah,
that this reciprocity is understood once we sort of remember what it was saying about symmetry and asymmetry, right?
yeah,
We basically we look at the larger system to understand this reciprocity, right? The organism environment mutuality, right? You get what I'm
yeah.
saying? That's what it was
Mhm.
saying here. Like just to be clear, right? It was like in a double dual manner expressed above. This profoundly important hypothesis, when properly understood, information, energy, or reciprocal aspects of nature, and like then it goes into when systems exhibiting knowing about are understood is more general, right? But what I understand here, it's saying is that what it was saying earlier, right? When we look at the larger system, what previously looked like two aspects of nature are more like numbers that add up to one, right? Because there's this mutuality, right? In the larger at the larger scale, right?
Mm. Yep. Mm.
In
Like
the more
mass specific.
inclusive context, right? Rather than because we can't look at energy as such and we can't look at information as such, like we can't like it's like just like the cheese round or the pizza, right? We can't slice it in triangles and in rectangles both at once, right? We can't look at information and also look at energy as such, right? Because they're complementary, right? They're reciprocal, right? They're distinct, they're not identical, right?
Mm.
You get what I'm saying?
Yeah, that makes sense.
We can only understand one in terms of the other, right? But it's like,
Mhm.
I can only understand X in terms of Y, and I can only understand Y in terms of X, right? But there's an irreversible flow to this loop of entailment, right? Because I can't go from X to Y and Y to X at once, right? But going from X to Y requires that I go from Y to X, right?
Mhm.
And vice versa. That's just like the
Yeah.
main idea here of mutuality and reciprocity, right?
Okay. And mass-specific rates of energy consumption are plotted for a given animal as a function of locomotory speed. A straight line is obtained from an insect with the vertical axis at 0. Uh, this is this linear dependency of mass-specific rate of energy consumption on speed holds for bipeds, quadrupeds, and polypeds, for anthropods and vertebrates, for limbed and limbless animals. It is a dependency of great generality, suggesting a fundamental principle governing locomotion that is independent of morphology, physiology, size, and taxa. Spelling out the types of quantities involved in the linear dependency, we see the net cost of locomotion is energy per unit mass by time divided by distance upon time. Therefore, energy per unit mass by distance. Hmm. This is good. This is good. This is a real principle. So this is good.
I mean, this is just the like very like beginning, bro. Like very surface level stuff. You haven't even seen like some of the stuff, bro.
Yeah. Mhm.
Like remember that figure I showed you about like scaling the ecological scale with Planck's energy distribution equation and Einstein's energy conversion equation, right?
Mhm.
You remember that?
Yeah.
Yeah, the paper that's from is like it talks about this stuff, but like a lot more of this kind of stuff. You know, like much deeper, you know, into that, like in this kind of idea, right? And I think it came after this paper. No, actually, it came a little bit before. So maybe they're referencing some of the stuff in that paper.
Yeah. Yep. And
It was called by Sean Kinsella Shaw. It was called Physical Geometry of Intentional Constraints.
mhm. Okay.
I think
It
I
is.
like that paper. So because you thought it was really good.
Can you tell me the name again?
Yeah, it's called Physical Geometry of Intentional Constraints. I think it's a 1988 paper by Shaw and Kinsella Shaw.
Okay.
I don't have the freaking collection of Shaw papers either, man. My God.
It's somewhere like
Mhm. Okay.
That's
I'll look it up.
Swenson.
yeah,
That
you should be able
is,
to find it on Google though.
yeah. That is the net cost of locomotion indicates the amount of energy required to move a unit mass of animal a given distance. The slope of mass-specific energy rate of consumption versus speed varies inversely with mass, as shown there. On the basis of empirically determined slopes, it can be concluded that that to move a unit mass of 1 meter, a cockroach of 3 grams dissipates twice as much energy as a crab or mouse of 30 grams, and 9 times as much as a dog of 3 kilograms. Small animals on per gram basis require more energy per time and per distance. Conversely, if an arthropod, a reptile, a bird, or a mammal have similar masses, the energy to be dissipated by each to move 1 meter will be nearly identical. Mhm. Yeah. Mm. We might hypothesize, therefore, that the dragonfly in 11.3 is relieved of the burdensome task of determining how much energy to use for this or that path through a thicket at this or that speed by a fundamental principle that is at once thermodynamical and informational. Yeah, that makes sense. The form of this principle escapes current science, but its relevance to everyday locomotion has been duly, if implicitly, appreciated by dragonflies for nigh on 350 million years. That's a good conclusion to the dragonfly story. Well, it's not concluded yet, but it's a good writing. It's good writing.
I really love how they conclude the whole paper with a little like, oh man, it's so beautiful what they say
The
about the
stuff about the
dragonfly at the end to conclude
dragonfly.
the paper. I don't want to spoil it, but it's great, bro.
Yeah.
Like aesthetically.
intentional behavior as a symmetry of the ecological scale. Dragonflies perceiving and acting are conjoined in that they serve a mutual aim, catching small insects and maintaining, in consequence, onboard energy resources. At the same time, they are disjoint in that they serve the aim in reciprocal ways, by the detection of information that constrains action and by the performance of action that constrains perception. In a circularly causal manner, a dragonfly's perceiving alters its actions, engendering thereby new opportunities for perceiving and entailing, thereby further modifications of its action. Intuitively,
Did
understanding the
we read that
conjointness of
figure? I don't. Did we read that figure that we skipped
yeah,
past?
this one,
Yeah.
we read its explanation. It's basically the central point being that pound per pound mass,
Mm.
like regardless of the form of the animal, if it's like of a similar weight, it's going to have a similar cost associated with it, but different structures. Whereas smaller animals have a higher per pound cost. So
Sorry.
something like that
I
is
see.
the lesson here. Like this is what is explaining that entire. This is
And what
simply
was the question of this section?
which is how is information that is related detected to energy that is controlled. So like so far this is the best section that I like because we get a like mathematical law here. So this is amazing.
Mhm.
Like this is music to my ears. This is good.
Yeah, and this is what we mean by like a law-based approach, right? Like we actually try to look for laws, like, and you don't find that in any other approach to psychology. Yeah.
Yes. Uh, okay. Intentional behavior as a symmetry of the ecological scale. The dragonflies perceiving and acting are conjoined in that they serve a
We
mutual
already
aim.
read this,
Catching
right?
small. Yeah. Yeah. This is where I was. Catching small insects and
Mm.
maintaining, in consequence, onboard energy resources. At the same time, they are disjoint in that they serve the aim in reciprocal ways by the detection of information that constrains action and by the performance of actions that constrain perception. In a circularly causal manner, the dragonfly's perceiving alters its actions in engendering thereby new opportunities for perceiving and entailing, thereby further modifications of its actions. Intuitively, understanding the conjointness and disjointness of perception and action is a cornerstone of the theory of knowing about. The dragonfly's pursuit of prey is an example of intentional behavior. Such purposive movements or goal directed actions are a hallmark of living things and are commonplace terrestrially as the motions addressed by physical theory.
Hey, what do you think about this?
Cybernetical,
Hmm?
I really like it
Like,
because I like it because we can, like, I can see a grounding of, what do you say? What the hell? I'm blanking out. A
I'm
grounding
sure
on,
that some
in
people,
effect, praxeology and Austrian economics out here.
yeah, right, right, and so it's really like praxeology. We're identifying people that
Yeah.
can be generalized more broadly, right?
Hmm.
But
Yeah.
like also, um, people like Zulu, right, would be very again, like would be very repulsed by this kind of statement or whatever, you know. He wouldn't really like
He
this
might
statement at
not
all.
be. He might not be. Uh, you, he might not be. Like I would just say, uh, like do your best to reach out to him regarding this. Like it's fine. Like I would say Zulu is not, someone who's against development. So like I'm pretty sure like what
Well,
it
he does.
is you're gonna have.
He really does hold like a Cartesian, like human animal dualism, where animals are just pure automatons.
Sure,
Like
I mean like
he's explicitly said that like multiple times.
no, I'm pretty sure he Well, I don't know. Like maybe you can talk to him about this, but like I would say animals do not have the level of volition, like conceptual volition that we do, but they do have like
They
certain
don't have the
perceptual.
kind of volition. They like, you
Yeah,
know what I mean? I wouldn't
yeah,
say level.
Yeah, that's also another
yeah.
important thing to understand is that it's not a like volition is not a matter of degree.
Right.
Yeah.
And I've talked about this before. There's like I can show you some pin messages where I've given like probably the like when you read it you'll be like, oh, this is really good. The explanation. I mean, remember where it is? I think it's is it in general chat where I pinned it? Oh, hello.
Yeah, you're
'Cause I
good.
think I'm lagging a little bit. It might be in general chat where I pinned it. Like it's a bunch of screenshots. Yeah, here. Like if you look in the pin messages in general chat at a bunch of like you'll see a bunch of screenshots, right? It's of
Hmm.
my like whole like explanation there, like what people are misunderstanding about this whole thing, and I think it's really. I think you'll like it. It's
Hmm.
pretty
Okay.
uh good.
All right. Let's continue here. Uh,
Hmm.
yeah. Cybernetical efforts to capture intentional behavior conducted for most of the later half of the present century sought to render intentional behavior as a combination of initial conditions, a set point, and control laws. Rather than providing understanding, this move regressed the general problem of intentional behavior to the highly particular problem of how and for what purposes given systems were designed. The thesis that systems expressing knowing about are the most general in respect to the principles that underlie them, such as that intentional behavior is likely to demand a physical account of the most profound kind, with extremely broad implications. In contrast to the material systems that have come under the scrutiny of past and present physics, systems that must be aimed by extrinsically imposed initial conditions, classical mechanics, upheld by a pre-existence attractor deterministic chaos, material systems such as the dragonfly literally aims itself towards targets. Stated more completely, the dragonfly as an intentional material systems exhibits both significant insensitivity to extrinsically imposed initial conditions. The thicket is clustered in variable ways at all length scales, a fact that will that the dragonfly does not seem to find overly bothersome, and an uncommon sensitive dependence on the final conditions. Mosquito is usually caught, regardless of the number of variety of impediments. It is as if the transformations in perception and action leave invariant the dragonfly state of wanting that it catch that particular mosquito. Philosophers sometimes refer to verbs that followed naturally by that is intentional idioms. Relatedly, it is as if the dragonfly is intending or wanting that it catch that particular mosquito binds the variables of information detection, energy control, and goal state in a special way so as to effect a geodesic at least distance, least time trajectory, and to conserve some particular but yet as yet unknown quantity. These observations suggest that a useful approach to the natural phenomena of intentional behavior can be provided by a mathematical theory of groups. This is group theory. Yeah.
Yes, this is talking about Shaw's work. You see, it's citing Shaw. That's the paper that I was
Yeah.
talking about earlier, the physical geometry of intentional constraints.
Yeah.
But also Shaw's work in general. He this is like this paragraph here is talking about what Shaw really focuses on.
But this is group theory. This is something I actually want to. One of my personal private projects is to study group theory as well. So this
Well,
is
yeah,
something
you
that
can.
might
There's lots of
coincide.
papers on Shaw. Like he has a whole research program called intentional dynamics, right? Where like his like main like method here is group theory.
Yeah. So like this lines up with my previous commitments as well. So that's something good.
Yeah, symmetry group theory. I
Okay.
mean,
Yeah. A great success, whether and wherever issues of invariance and conversion conservation of life. Where were we? Yeah. These observations suggest that a useful approach to natural phenomena of intelligence can be provided by mathematical theory of groups, a tool which physics has turned repeatedly this century with great success wherever and whenever issues of invariance and conservation arise. A group is a set G of transformations of or symmetry operations equipped with three rules. Any two operations can be combined to give a third, and this product is associative. That this There is one that does nothing at all. The identity that is a strange way to say identity. And every operation has an inverse, the combination of two being the identity. A group is closed. No elements outside G are attainable by combining elements contained within G. In its applications in physics, a group is a measurement device that reveals certain identically essential properties while ignoring others. Can a group be defined that captures the minimal essential structure, the basic symmetry of intentional behavior? And if so, what hidden structure is it likely to disclose?
You're gonna like this.
Yeah. A suspicion is that overseeing any efforts to identify the symmetry group or intentional behavior should be the thesis of organism environment mutuality, reciprocity, strongly interpreted in these papers. His thesis indicated a number of reciprocities. Some aspect of intentional behavior refer to an interior frame of reference, the biology of the dragonfly. Other aspects refer to an exterior frame of reference, the thicket surrounding the dragonfly. By the strong mutuality thesis, the processes referred to these two frames should be reciprocal.
Saying
Similarly,
that intentional behavior, right, intentionality is a problem of multiple reference frames, or the coordination of multiple reference frames.
yeah,
And that's why it's
similarly,
a symmetry at the ecological scale.
yeah, some aspects of intentional behavior are hereditary, and that what is happening now is entailed by what occurred previously. And other aspects are anticipatory, in which what is happening now is entailed by what will happen next. By the strong mutuality thesis, the past referring and future referring processes should be reciprocal. Also, by the strong mutuality thesis, a reciprocity should exist between the information and energetic aspects of intentional behavior, reciprocity that is already been underscored and remarks above. It is roughly apparent that roughly apparent that fulfilled intentional behavior, such as the dragonfly maneuvering through the thicket to nab a gnat, consists of four operations: detecting information, intending a particular goal, controlling energy, and successively realizing the goal. In order to lay hold on the symmetry of intentional behavior, we'll need to represent these operations in a manageable form. We need to assign numbers to them. Two of these operations act on stages in the exterior frame of reference, detecting information about the environment at oneself, and controlling energy to bring about specific movements of oneself with respect to the environment. The two, the other two operations, intending a goal and realizing it, act on states in the interior frame. Capturing the contrast between the exterior and interior pairs can be achieved by using real numbers +1 and -1 to represent the exterior pair as real operators, and by using imaginary numbers. I would call them complex numbers, but that's fine. Imaginary numbers +1, plus I, and -I to represent the interior pairs as imaginary operators. Since the information about an environmental fact is a basis for anticipatory control, its detecting can be treated as an operator -1 to convey its actuation. What is this? Acca-
A causal.
acca-
A causal.
acca- Oh my fucking god. To convey its bro. The, am I cooked? Why couldn't I figure out a causal? Convey its a causal time backward nature. In contrast, the energy control to move in a particular manner as the basis of hereditary control can be treated as an operator plus one to convey its causal time forward nature. In a similar vein, since it's tending a goal, basically here we are doing, in effect, a four dimensional, like not four dimensional, like they have like two axes here, like the real axis and the imaginary axis, and we're just
You're gonna see it. There's a
mapping.
figure.
Go ahead.
There's a figure on the next page.
Yeah. Basically, this is what we're doing. Yeah. Fair enough. That's for the mathematical structure of the dragonfly. The question posed.
No, you skipped the paragraph.
Yeah, I'm because like.
Oh no. You read that. You read that. Never mind.
Yeah. The question posed on how variables, information detection, energy control, goal state are bound together under mosquito catching intent, that they might do so by virtue of group structure, provides an answer that points to symmetries at nature's ecological scale, shaping the functional order characters of that scale. We underscore the significance of symmetry in our final remarks.
Yeah, all this stuff is really. All this
Go
stuff
ahead.
is the like the beginning. Like it's just going over the summary of like what they've done so far in intentional dynamics. Like it's been from this paper they've done intentional. Shaw has done like intentional dynamics for like a little less than a decade maybe, right? But
Yeah.
like they've released like Shaw has um published several papers like in 2012 or something, right? Like around there, or like since then also, all through like the 2010s and stuff, like about more intentional dynamics. You know what I mean? The methods in intentional dynamics are like there's like an introduction to intentional dynamics, and like it's all about group symmetry theory and stuff. Really.
Fair enough. Yeah. Okay.
But this like they learned a lot. What I'm saying is they've learned a lot. Like since now, like so what you're seeing is just the beginnings of like you can there's a large body of work on this. You know what I mean? That they've learned a lot from.
Okay. Mhm. Yeah. Direct perception, symmetry again. It is fairly obvious that perception is the means by which organisms know about their surroundings. Like it's not fairly obvious to philosophers. A dragonfly picks its way through the thicket and aims itself as a suitable prey by means of perception. Perception is not merely contingent, but entailed, following necessarily from maximizing the global rate of entropy reduction. Then perception is a phenomenon to be understood in terms of lawful regularities and symmetry principles, defined at the ecological scale of organisms and environments, rather than in terms of mental states and formal languages of representation and computation. I don't know if I agree with this, but we'll see. Uh, this leads to what may well prove to be in the next century the most important model for taking hold of knowing about in the rigorously scientific manner, namely the
I
understanding
think if you
of
really
laws.
want to grasp that point that you were stuck on a little bit, right? That snagged you a
Yeah,
little bit there. Is
yeah,
read lecture 1 of lectures on perception, where they're talking about partial systems versus total systems, and how like slipping below, like to a scale below the phenomenon of interest, right? Over decomposing, right? It like it has all these consequences, right? I don't want to get too into it, right? But it's like it's all about finding the appropriate scale, the appropriate like in, like the large enough system that embodies the laws, right? Such that
yeah.
the behavior, right, is not seen as like capricious or arbitrary, right? It's like
Mhm.
it's law. The laws are at a larger scale. It's just like it's seen as capricious when you're at the wrong scale. You know what I mean? And there's like really like illustrative arguments there
I think that really helped grasping this point in lecture 1.
Yeah.
And then it's like that's then they extend that like through to lecture 3 when they talk about lecture 3, like talk what they talk about in lecture 3, they extend that to where like that leads to like a recourse to like internal states, right? A lot of the time in psychology.
Yeah. This leads to what may well prove to be, in the next century, the most important handle for holding on, or taking hold of knowing about in a rigorously scientific manner, namely the understanding that perception must be direct, as direct achieve direct apprehension without intermediaries such as inference or matching to mental schemas.
Oh yeah, that's actually, remember I told you about the pinned message the other day where I was
Yeah.
like the closed entailment loop. You saw that one? I don't know if you read it, but like that's talking about what I was just talking about, right? Like it's a good like if you read that, then you kind of like will branch off from there and see like the point that that snagged you just there.
Mm. But this handle, fashioned for us in its contemporary form by Gibson, provides a means for approaching organisms as knowers and the environment as the mutually compatible terms. Direct perception is consonant with organism environment mutuality and reciprocity, where the interpretations of perception that have dominated the past and present centuries have portrayed the dragonfly and its surroundings in disharmony. Perception as direct renders the dragonfly and the functional description of its surroundings harmonious. Importantly, direct perception does not create the epistemological paradoxes that have befallen all other theories of perception. Paradoxes that would be expressed by phrases such as the dragonfly's visual system inverts its surroundings, the thicket has thicket and prey are illusions of dragonfly's brain, the dragonfly has foreknowledge of space, the dragonfly has foreknowledge of the basic concepts needed to interpret the signals from its sensory organs, and so on. For Gibson, perception is specific to the environment and to self
And all
movements
those
because one,
epistemological paradoxes are explained in a
yeah,
lot more detail in lectures on perception, like throughout the whole book.
okay, all right,
Like Steelman, like the views that lead to them, you know what I mean? And like why like those like those kind of things are like invoked. You know what I mean?
yeah. For Gibson, perception is specific to the environment and to self movements because one, information is specific to the environment and to self movements, and two, perception is specific to information. Specificity is an intuitive idea of considerable power. It's highlighted in our expectations for biologically relevant information theory. It should it should become evident in the next century that the top priority of a science of cognition is a general theory of specificity, of how one thing can specify another and how specificity can can be preserved over different and time varying components of an organism environment system. Examples: the components of dragonfly thicket system and the perception action cycles that it manifests.
See lecture 3 on lectures on perception for more on specificity. Like that's
Okay.
it's the best discussion like ever you'll find on specificity and grasping that concept.
Okay. Mhm. Yes. This contrasts with the pursuit of many scholars in the latter part of the present century for a general theory of representation. Example: Frodo, 1975. What is gained from the specificity of perception to the environment and self motion? Nothing less than the grounding of knowing about. Evidently, for those who would seek a general theory of representation, any viable theory of what concepts an organism may be said to have and how they may be said to refer presupposes and requires a theory of specification. Directness of perception follows, presumably, from nature being constrained in particular ways. Consequently, science in the 21st century can expect to advance significantly by pursuing, in a rigorous and as thoroughgoing a manner as possible the implications of the postulate of direct perceiving. The reason that direct perceiving can be used in the way suggested is because direct perceiving, like organism environment mutuality and reciprocity, and the persistence of intention over perception action cycles discussed above, imply a symmetry. Importance of this implication is that it happens to be the right symmetry, and the conceptual role of route to understanding knowing about
The
will have been
persistence of the intention point is about how I can vary the means, right? While the goal stays the same, right? I can vary the actions and stuff.
yeah. As we have learned so well in this century, symmetry dictates design. The idea of constraining experimentation and theory building by symmetries is the ultimate intellectual legacy bequeathed to the contemporary and future scientists by Einstein. Perceiving is a polyphasic phenomenon. The notion that perceiving is direct implies the various phases of matter involved: mechanical, plasmic, biological, psychological. Phases of matter. I don't know anything about this. I don't know if I would agree with this phrasing, but fair enough. Like it
Yeah.
doesn't matter. Uh, must
No,
obey
that's
certain.
that's something Shaw said. It's sort of in reference to what Gestalt, like some Gestalt psychology people would say, but like Turvey never said that, like in his stuff,
Okay.
and like Shaw never really said it ever again. So I don't know. It's not important.
Okay. Fair enough. Then doesn't matter. For the
Basically,
required
just the various forms of matter, that we see in
yeah,
nature.
yeah. Because like phase means something else, but it's fine. It doesn't matter.
Yeah.
Yeah. For the required compatibility, not only must laws be invariant within a phase, but they must exhibit conjoint invariance across phase boundaries. Different perceiving implies a symmetry in the structure of the interactions among the laws of matter's different phase. To come to terms with perceiving a natural state of affairs, therefore, is to understand lawful relations that are invariant to a change of phase. There are no illusions about the difficulty of pinning down the nature of the symmetry principle that fixes the directness of perceiving. It seems to us that neither data nor theoretical expertise available at the tail end of the 20th century is at the level of sophistication required to formulate the intrinsic symmetry of governing physical laws. To an important degree, contemporary data and theory are not up to the task because of a widespread and historical tendency to treat perception and action as they were phenomena outside the purview of universal physical principles and well tried physical strategies, and two, to be explained by accounts far less abstract and considerably less general than those that address the motion and change in non living material.
Like
Only
of
by
just non-equilibrium thermodynamic stuff, like just like physics of self-organization stuff, even
yeah,
like we shouldn't be stuck in like 17th century physics still in trying to explain psychological facts, right? The facts of psychology.
only by reversing this tendency can the science of the 20th century hope to reveal the symmetries that underwrites and the perceptual abilities of organisms and the action capabilities that they support. Such will be the charge for the new century students of cognition who will wish to understand the knowing about that is exhibited every summer by the likes of dragonflies in the thickets of New England and by the human observers like ourselves choose to watch and wonder about them. Yeah, this is a beautiful way to end this. This
Yeah.
is a aesthetically very beautiful way to end this. Like the dragonfly was with us the entire paper. It's a it's a great way to end it with the us watching the dragon.
And it also brings in subtly, the point that understanding perception, understanding like the psychology stuff, understanding measurement, right, is like
Yeah,
gonna help us understand science more generally, right? What can the sciences of
yeah,
life and mind teach us about science in general? You know what I mean? And doing
yeah,
science, right? And it's like we're part of the world we're striving to know, like science has to
be like it can't say that like the facts of psychology are unreal, right? You know what I'm saying?
Yeah.
Like it has to account for the fact that science is possible, that living things such as humans can do things like science. You know?
Yeah, exactly. So there we go, guys. We come to the end of the paper. I believe that's like a 6-hour reading,
Oh,
distributed among 3 days, and
Yeah.
I hope everybody
Oh,
enjoyed it.
hopefully next time we'll get through it much smoother because I think we got our flow. Now.
Yeah. All right. See you guys. Bye bye.
What,
see you.
any final thoughts, bro?
Yeah,
What
final
did you
thought.
think?
Okay, so these are my final thoughts. So I I have like respect and agreement this field of study. However, parts of it are very, parts of it make me suspicious, for lack of a better word. But like I have this view, right? I don't fully know it, but from drawing from my current integrated knowledge, I can see that much of this is very, very powerfully useful. And you know, someone from coming from objectivism who deeply studies this and integrates this is going to go far with it. Like that's what I'm thinking about it. And I certainly need to like have debates with the entire
Yeah, and
literature
we've
and
all seen that. That's why we're all
yeah,
here.
exactly, yeah, you know. And so I would I would want to like read more about the literature to see what certain points on which I'm like not sure about or iffy on currently, or
Mm.
my where my like my concepts clash with theirs. you know uh like let's see who wins out there, but like so far I can see that even if I find areas of disagreement where I think they're wrong, there are more areas of uh not just agreement but growth of my own conceptual faculty here. Like this paper was, I would say this reading was worth the time that I spent on it, and I would look forward to further readings like this, and like
Yeah, and
further.
I have a really good idea of what to read next. I
Okay.
think you'll really enjoy it. It'll be
Yeah.
a little
But
bit smoother, I think.
okay, we could do that. But first, I would want to, uh, you know, finish the audiobook on my time so that I'm coming with some more, knowledge and vocabulary.
Okay.
So we can do that in like a
Have you
week
been
or
listening to it?
week and a half. Yeah. But we can do that like in a week or two. Like when I'm done with the audiobook, that's when we can get back to it and do another
Okay.
paper.
I mean, I'll send you the paper so you can like give it a
Oh, for
look
sure, for sure.
until then,
Yeah, I
But
will. I will.
you've been reading. I mean, you've been listening to the audiobook of Intro to
Yeah,
Ecoscience.
yeah.
What do you think so far?
Uh, good. I, honestly, I'm just right now very tired. My mind
Sorry.
is a little tired. Yeah,
I feel you, man.
I'll get right back to you. But like today has been a lot of work, and then we did the reading as well. So like, just
Hmm.
gonna go and sleep in my bed over there. And we'll talk
Well, yeah. I
tomorrow, I
mean,
guess.
if you have some fucking like light bulb moments or something, just like
Yeah.
tell us to hop back in VC. Yeah, and
Okay.
we'll add that to the recording.
All right. Okay. Thank you, everybody, and this was a pleasure. Thank you everyone for coming to the readings. We got our first paper done.
It was quite a lot of
Move on to
people
the-
that came.
yeah,
Yeah,
you
especially
know,
yesterday, or not yet, or
yeah,
not. We didn't do it yesterday. The last time we did it.
yeah. So, uh, thank you everyone for contributing and participating. And I'll see you soon. And there'll be more readings in the future. And I hope you can join us. Thank you.
Alright, stay safe, man.
Cool.
I'll sleep now. Good night.